Hi everyone, welcome back again. I'm going to make this one super quick since we're a little bit behind. Welcome to the DCG 201 live stream. This is the second day of FOSDEM, a convention that normally happens in Brussels, Europe, that's going to be entirely online this year. And they cover all sorts of free and open source software. My name is Sidepocket. I'm one of the two co-founders of DCG 201, formerly known as DEF CON 201 or DC 201. We are one of the many DEF CON groups across the United States and across uh, the world. The 201 stands for the New Jersey area code. And we're going to be having our meeting on the third Friday of the month, which will be on the 18th. If you want to know more details, this is our website at dcg201.org. You can also use any of the variants like defcon201.org. We're also all over social media such as Twitter, Facebook, Mastodon, Instagram. Here's the master list of all of our social media. Finally, we are streaming on Twitch, Live, or YouTube. So if you like the content that you see today, you can hit that bell, turn on all notifications for YouTube, and subscribe or follow us for free on Twitch, Live, or YouTube. It's completely for free. We get notifications during the stream, and we cheer you on. However, we are streaming on a bunch of different platforms. Unfortunately, not PeerTube yet because it's still a big pain in the butt, but we will mirror them on PeerTube. Um, if you are watching on Facebook, there is a way to chat with us. I just posted that link right in the chat. Finally, which I will go into more detail in a bit. We are running, this is our last day for a fundraiser we're doing for the Children's Miracle Network Hospital. That's that bar that's above me here. We so far raised $308.50. We're trying to make $600, but regardless, all the stuff that's currently donated and what you donate via Tiltify will go for sick children across the United States and Canada. So if you're interested in donating, if you're on Twitch, if you scroll below, we have a little widget to donate. There is the QR code that finally works that you can scan on your phone. And what I'll be doing during all of the chat is I'm going to be posting the link directly in chat. So if you want to donate, even if it's just $1 or $5, that's how we got to the 308 in the first place. You can donate right there. So because we're behind, we're going to flip over to the screen real quick. This is normally our website and everything, and we are on day 2 of FOSDEM. And most of our stuff that we're going to be looking at is going to be in the security section. And I believe it's already started. We are going to hop right into the seamless kernel update, which, as they say here, in this project, they're going to put another solution in practice for patching the seamless kernel in Linux based on KXEC and CRU. So here we go. We're going to go watch this, and then I'll do a better explanation later on in a bit.
Same namespace with the kernel. It is impossible for us to save and restore all information, as the kernel version has probably changed between the seamless kernel update. Things like function API, data structure definitions may be different. Device status include many information, so I just list some important of them. So we can check here. For resources like registers, interrupts, we can just skip its initialization or request again, like I list here. This is how we handle PCI devices. If you have interest, you can find more technical details here. However, for the kernel driver itself, we need some obvious state transfer works to help complete this process, kind of like live patch mechanism. There are 2 important points here. First, we need partly isolate kernel driver from the kernel. Kernel drivers are managed in the granularity of sections. We rewrite the process of kernel module loading. And for some special sections with fixed suffixes, we will put
FYI, I'm going to turn the camera on in a moment. Just give us a couple of minutes.
When these drivers come back, they can reuse their former information again. The problem here is if these sections have function pointers, they cannot use them directly since the kernel has been reloaded and the address cannot be the same. We create a virtual function table for this. Every time kernel drivers want to make a function call using pointers, they can obtain an updated address from the table. This is kind of like procedure linkage table. And the second, it is only natural that we then need to hook functions in order to do state transfer work. Here we add a driver suspend and restore API. So it is a really rough framework. We can't handle kernel drivers like applications in user space. And therefore, we provide some mechanisms to help complete this process. The drawback here is that the kernel driver codes have to be adapted, which is not always easy work. So we can draw some conclusions here. We frequently use reserved memory to reuse information or resources. It is really an effective measure to save time. And currently, we do not find a universal mechanism to handle kernel drivers. So based on our experience, the adaptation of driver codes is necessary. And also, there is still a lot of work needed to optimize the Linux boot process. There are some technicals that I have not mentioned here in detail due to time constraints. Like we add support for CRIU to fully support Unix stream sockets, dump and restore. And we rewrite the process of how CRIU obtains firewall rules to save time. And also we accelerate the process of how ptrace hijack the syscall. CRIU works in user space to make itself less dependent on the specific kernel version, but we pay more attention to the time cost. So in the future, we are going to implement a tool that works both in kernel and user space. Furthermore, we aim to combine live patch mechanism and seamless kernel update to provide an automated solution. We will continue to explore potential solutions for kernel drivers to make themselves more standard and universal. So our ultimate goal is to provide support for virtual machine host update natively in the future. Okay, everyone, that's the end of this little talk on the seamless kernel update. Thanks again for spending your time with me. If you'd like to have any further communications with me or my team, feel free to contact any of these email addresses.
And that, excuse me, I'm full munching here. There we go. That was, oh, we still have a bit more here. Let's see.
For the amazing talk and also for encouraging new and young blood in the community. I would like request the audience to please put a huge virtual round of applause for Lou. And also, due to bandwidth constraints, we might not be able to have a live Q&A, but Lou is here with us. If there are any questions, he'll be happy to answer it on the chat. Thank you, Lou, for the talk.
Interesting that it is bandwidth constraints. I've never thought that was the reason for the gap. So we have a bit of time here before we go to the next topic. So I'm going to exit out of this and kind of put it on a generic page here. That was really neat what we kind of caught there. It's always interesting to see what people do with the kernel because, you know, the kernel is kind of the brain stem of the entire operating system. And oh, look at my crazy hair. I came back from New York. So, like, my hair is normally like all floofy microphone sheep, but because it's been in a um, in a thermal beanie for like the past 4 hours, this is usually what it looks like when I come back from work, where like my hair is just absolutely insane, and I look like it's like it's trying to turn me into Mickey Mouse. So yeah, I know I had to do the quick version because again, why is this? Hold on, why is this flat on? I have a comb, but I'm a heathen, so I'm gonna do this method. At least I'm not using a fork. I actually know people who do that, and it's like I have no idea how these people live with themselves. Um, where the hell is this thing? See, you came here for like cool hacking stuff, and instead you got Sidepocket attempting to and failing to groom himself. To the point where I think I have my comb in the bathroom. So I will get that in a bit because the next segment I'm probably going to have, there's going to be very few times, unlike last time, where I'm going to have the camera off. And looking at the schedule, I'm going to have it mostly off during this next talk. I'm going to pretty much have it on until I would say about 6:30. And then I'm pretty much, unless something happens, watching everything just all the way through until we get to closing, which will be around noon, and then we'll probably end at 1 p.m. So the stream's going to be slightly smaller. Also, for those of you who are new to this, in that corner right there, that is the Incent reward. It's a pretty neat feature, actually. Basically, there's a cryptocurrency called Incent, and you get in what you do is you go to get.incent.com, as it says right there, and you download the wallet, and in about 8 seconds, there's going to be a both QR code you can scan and a manual code to type in. It starts with DCG201, and or DC201, I think. Yeah, it's DC201. And what you do is you input that code or scan that QR code, and you'll get a little bit of incent every time that happens during the stream. And the cool thing about the incent cryptocurrency is that it is compatible with every single cryptocurrency on the planet. So you can easily just exchange it. Sorry, I'm just adjusting the camera here. For any like Bitcoin, Litecoin, Monero, all that other stuff. And if you exchange for something like Bitcoin or Litecoin or Ethereum, that can be directly also exchanged for fiat money like US dollars. So it's just a cool way to get cryptocurrency, potentially real money, while watching the stream. We've researched it a lot. We don't believe it's a scam. We've been using it for months now. It's pretty neat. Anyhow, um, so as I said, because we had to rush through the beginning, hi everybody. Actually, let me switch over to my face mode. So you can see all the details, including the dev share. I'm kind of in a relaxed mode. Also, we're not Battlefield Earth. I am so sorry for the Dutch angle. This is actually why I don't normally use the clip function on um, on this uh, on this light stand here, because normally I can clip the camera, but it unfortunately has a propensity to lean towards the left as you do in real life. So, unfortunately, it's just going to be this weird Dutch angle through the entire stream, and I sincerely um, apologize for that. Just saying. Yeah, hi everybody. It's going to wobble a bit because I've readjusted. I'm Sidepocket. I'm one of the two co-founders of DCG 201. We are DCG 201, formerly known as DEF CON 201 and DC 201. We are one of the many DEF CON groups across the United States and around the world. 201 stands for the area code of New Jersey, which is what we're from. We're in America, from New Jersey. Um, DEF CON Groups is a community, as I said, nationwide and worldwide, loosely affiliate groups, and each group kind of brings an element of DEF CON, which is one of, if not the biggest hacker convention in the world that takes place in Las Vegas every year. This year, it's going to be back on the Vegas Strip in August, mainly at Bailey's in Paris, but it'll be at a bunch of other casinos as well. But basically, we take that whole crazy experience and we kind of not necessarily replicate that at home, but bring the same sort of energy, creativity, and elite hacks that you see at DEF CON to all of our local areas. And so we try to just bring a nice slice of DEF CON craziness to New Jersey. In exchange, we kind of bring a bit of Joyzy attitude to DEF CON in of itself, which seems to be kind of positive in recent years. I keep tilting this camera down. There we go. Because you want it where the fro, you want there to be a little bit of headroom, so the fro should be in frame, but I shouldn't have like 8 feet above my head. That's a mistake that a lot of people often make. But yeah, we normally meet third Friday of every month, and in fact, our next meeting should be on February 18th. So next Friday. I'm already putting together all the stuff for that. I know last time we had to cancel our meeting. January was literally, I'm not even kidding. It's personally was one of the worst months I ever had, and it was also like the worst month ever for DCG 201. We already made some announcements where unfortunately some members had to step down due to all sorts of crazy issues that didn't have anything to do with us. It was just stuff. And literally outside of MagFest. MagFest itself and the Lockpicking Village that I personally hosted in our panel, which is either already online or should be online soon, was amazing. But everything else was just, oof, that was just rough. And so, but we are doing February. February is going to be all online, just because we're still riding out COVID and it's also kind of cold outside. In March, and I'm going to reiterate all this again, by the way, at the end of this long ass stream, in March, we're going to try to do hybrid meetings again, meaning a bunch of content's going to be live streamed, and there's going to also be a bunch of stuff in person. And in fact, there's going to be stuff in person that you'll only be able to see or do in person. For example, we plan on having a raffle, and as far as we know, that raffle will only be done in person. So that's an example there. But this upcoming meeting, which will be focused on free and open source software as well as other elite hacks, will be on the 18th. It'll be all online through our live stream. Again, if you want to know more information, go to our website, which is listed below, and I also put in chat at dcg201.org or defcon201.org or dc201.org. There's many ways. The main one is dcg201.org, but we just have alternatives just in case what people type. And what have we been doing? And that's where we're going to flip back to screen mode here. What's the point of the screen? Well, we started this yesterday, and what's nuts, so let me actually do this. So we are currently at FOSDEM. I forget what it stands for, unfortunately. It started yesterday. It's day 2 is today. So this is our second stream and the final stream we're going to have for FOSDEM. Let's go to the About section. FOSDEM used to be called OSDEM for Open Source Developers European Meeting. They normally meet in Brussels, and even though this is online, it's still scheduled to their time, which is why I thought Chaos Computer Congress with RC3 was nuts. Or thanks to German time, they started at like. That's why we didn't live stream last year. By the way, we didn't live stream last December because they started streaming at like six, and then yeah, they streamed at 6, and then they ended around 4, and we just simply did noon to 4. The first RC3, we didn't even bother last RC3. This is even more insane. Literally, if it wasn't for me trying to raise money for the Children's Miracle Network hospitals, which the link's in the chat, as well as the QR code on the screen and the widget we have on Twitch, if you scroll below on Twitch, if you donate, we get notifications. I worship you the entire stream. I'm literally torturing myself because it's 4:29 right now. I'm like a little boy. I want to go to bed now. I want to go to bed, wake up, and bake cookies, and all that stuff. Not web cookies, like actual cookies you eat, because I can do that type of stuff. But instead, I'm streaming this, and I would be looking at FOSDEM in general. Like I would probably wake up normally at 9 or 10 just to see what's on. But I'm literally streaming for like 8 hours straight, 3 a.m., 4 a.m. in the morning onwards, literally to help raise money for sick children across the United States and Canada. So if you want to donate $1 or $5, $10, $20, $50, $1 billion, our goal is 600, but even the $508.50 that currently is there, everything by the end of today is going to go to sick kids, including the last live stream, which I have to actually post in a moment, which is the Master of Unlocking, is going to happen as it usually does at 8 p.m. tonight, so long after the stream. So those are going to be the big two pushes to see if we can get at least a couple more dollars to help out, kids who have COVID, kids who have mental disabilities, physical disabilities, children who are injured, children who are sick with other diseases, children who are recovering from spousal abuse, so on and so forth. And also to help out the parents too, because kiddos as parents, they're not all there either because their kid's nearly going to die. So anyhow, this is going to be the second time I turn off the camera. Um, and oh, by the way, FOSDEM. So yeah, it's normally in Brussels. FOSDEM is free open source. I'm gonna guess developers European meeting, and it covers FOSS software, free and open source software. Think of Libre Planet, but in Europe, and it doesn't suck ass and is like actually way more structured and well done, and honestly has way more interesting topics. This is not even fully a diss on the FSF. It's just, we cover it in the past, but especially that last one, not even the Stallman thing. That last one, especially with the way they did accounts and basically lied to everyone, uh, thinking it was free, but you actually had to pay money for it. That was just wrong. So we thought, hey, this year even though we'd rather cover this at like 4 a.m. in the morning than to cover that next month. So we're covering this now. And we're mainly going to be focusing on Sunday's security track, but there are gaps between the different talks. So what we plan on doing is using that time to occasionally peek over and look at some other things. And this next talk that should be about half an hour long, if I can find where the hell it is on this freaking hellscape of a. I also noticed that all the European hacker and maker conferences, they're all like crazy, like they do these like giant spreadsheet craps, and and it's like you cannot find anything um on here. So we're gonna try to do a different search term. I should have preempted this. Where? Oh, it's all the way over here. See, this is why I don't usually cover this stuff. So this is the second time I'm going to turn the cam off for the most part. I'm going to come in at some point. But right now, I thought this was really cool. To me, this is like totally the hacker spirit right here. It's called, I'm going to fuck up this word, the AHO, which is Maori Identity and Data Sovereignty. AHO is a FOSS project from, I'm going to fuck up these names because it's down under, Atoara, Aotearoa, New Zealand, built to meet the data needs of the Maori, which is a minority group within New Zealand. Never mind, just in general. Talk will share insights from thinking in a less Eurocentric way about data and how the need for data sovereignty has led to peer-to-peer data models. So I love this, whether it's indigenous Americans, uh, Black Africans, LGBTQ people, really anyone that's being oppressed by a boring majority government of terrible people. It's always fascinating just to see like taking that hacker spirit, taking technology that hackers have made, and they either make their own technology or they vastly improve on the bullshit that us hackers come up with. So we're gonna hop into this chat. I'm gonna turn off the camera for a little bit. I'm gonna come back on just because I have one or more two things to do that having the camera on would not be kosher. But let's go see this. This is in the Web3 track, and I will say that even though there's been some controversy that FOSDEM this year has a Web3 track, their Web3 track is really tame. It actually deals with a lot of peer-to-peer, actual implemented uses of blockchain that will actually be decentralized and is anti surveillance and stuff like that, as opposed to usually when you see Web Web3, it's just Ponzi schemes and like blockchain and cryptocurrency snake oil. So I will commend that when they did it's kind of like what I wish the Cannabis Village would be at DEF CON. I love that when they did a Web3, they're at least doing like it's like my show Crypto Barons, like actual technology that's useful instead of the usual crypto bro Elon Musk blow it up your ass bullshit. So let's watch and see how the Maori have taken and have created a hacker technology to suit their own societal needs in New Zealand. See y'all in a bit. Sorry about that. I thought I turned the speakers on.
And to also offer all sorts of things like financial tools and digital and sort of decision-making tools. Digital identity is also another domain which I think is up and coming and going to be really important. Like, for example, why is it that a birth certificate or a New Zealand passport would be the de facto ways of identifying yourself when the treaty guarantees sovereignty and that there are parallel sorts of identity which are currently not recognised in New Zealand by institutions. So why is data sovereignty so important, and how is it played out in building Aho? A big part of it is like, where is the data held? Who has access to it? So we researched current technology, and the best you could really do was run your own instance of a piece of software, generally like a centralized piece of software. So there are some great options out there and have had a lot of careful thought and research and have been built in concert with Indigenous people. However, some of the feedback we've heard is that running a server, maintaining an instance somewhere locally can be quite a big maintenance thing. Like if your server rack goes down, you'd need an expert to fix it. Or if you run it in the cloud, you might run it in Singapore because there's good connectivity with New Zealand, say. But whose land is that on? And who has access to it? Like, it's not just people in Singapore. If it's an American company, then the American government can subpoena that data as part of their agreements. So why is that inappropriate? Why is that a challenge? I'd like to read a quote to you from Dr. Karaitiana Tauru. So he talks about wairua, which is kind of like spirit of a person, and Mauri, which is like life force, energy, something. Our traditional knowledge teaches us that all natural objects have a wairua and a mauri. If our mauri is healthy, then our wairua is intact and will make the natural object healthy. Moreover, if we touch something, share our thoughts, or are involved with an event, then our mauri is left with that object or event. The same is also applicable to Maori data. Maori data contains mauri of the individual, whānau, hapu, and iwi. And iwi is a tribe, and these other things are different organizational levels within that. Therefore, any system that has Maori data then has people's mauri. If our data and our mauri is being used for things that we are not aware of, stored overseas or in culturally unsafe environments, then this will impact our wairua, which in turn make the individual, whānau, hapu, and iwi unhealthy. So how have we responded to sort of like trying to build with data sovereignty in mind, with things like Mauri in mind? What we did was build a peer-to-peer system. So this is made up of devices, each running their own independent database, which sync data in a peer-to-peer fashion. So we also have these relay nodes, which are only special in that they are always online and have some extra storage space. But the way it works is a message can be published on this phone. It doesn't go to any central server to check. It's just it exists now, and now it's relayed out to these other peers in the same whānau or hapu or iwi. This relay is being run by that whānau, hapu or iwi. And it can be just a little Raspberry Pi or a laptop or whatever. The relay has no access to the data. All of the data is encrypted. And like I said, there's nothing special about it. So if you need more capacity, say you want the relay to offer backups to some large videos, then you can stand up a new instance of one of these relays, and it will sync data, and the other, it can be a sort of a redundant place to connect to. And also it means that if the server ever comes down, the system will continue to work. Even if all of these systems go offline, these peers can still sync if they're on the same local network. So getting into even more of the detail, all of this is built on Secure Scuttlebutt, which is a peer-to-peer protocol database. It's got a bunch of social media applications, things that are sort of like Facebook, chess applications, that have other things like that have been built on top of it. And the building blocks of Scuttlebutt are similar to something like a blockchain, except that blockchains are monolithic. They're like a single global database, which is completely inappropriate in the Māori context. So what we have instead are these things called feeds, and a feed is a linked list of signed messages that have been published by a particular user or peer. A peer is identified by a public-private key pair. The public part is their unique identifier, and the signing of these messages is done with the private part. It's also an append-only log. That makes...
And real quick, before I get back, thank you Off the Cuff News for following us on DLive.
It's also append-only because the IDs of these are dependent on the content, because it's a hash. So feed replication looks like this. On my sister Alice's computer, she may have multiple feeds. She's got one which is made up of messages she's been publishing, and she's also syncing a copy here of things that I've been saying. So when she gets a copy of a message that is allegedly from me, she checks its signature against my public key, and then checks that it is correctly linked, and then it's persisted to her database. Interestingly, she doesn't need to have got this copy of a message from me. She might have got it from my dad, for example, or a complete stranger. And because we can verify the signature and place it within this linked list appropriately, we can trust the content. So really briefly looking at the content of a message, here's what a message is made up of. It's made up of who authored it, like what was the feed ID or the public key used to author it. What was the message that this is linking back to? This is the linked list previous link. And what is the content? And this content could be anything. So we'll look at what we store in here later. And a signature, which is takes into account all of those things, and it involves the private key to make a signature. Finally, the message's ID is derived by hashing all of these things. So how do we build things up with this in Scuttlebutt? Well, we build these things that we've called tangles, because they can get a bit messy. The concept is kind of like, imagine if you had a series of mutations. It's a little bit like event sourcing, or is event sourcing, where you specify changes to a state. So examples of changes to state would be like, say my sister Alice and I are entering a profile record for my grandfather Lawrence. So I kick it off by publishing a message which says, please make a mutation which adds the name as Lawrence, and I don't really know, this is an EDTF, extended date time field, date time format date, which allows for a lot of flexibility. I don't actually know when my grandfather was exactly born, but I know what sort of decade. My sister could come and append another mutation to that, clarifying that there was an alt name, that he was also known as Laurie. And I could come back and add further clarification about what his exact full name was, say. Where things get pretty interesting is that you can have concurrent publishing of messages. So it could be that I published this update to his full name and my sister published his birth date, or like a clarification on his birth date, at the same time as me. Or she may have been offline and has just come back online. So we deal with this similar to branches in Git, in that sometimes these can be auto-merged. In this case they happily can, because these two edits aren't in disagreement. If, however, I was also editing the birthday and there was a conflict, we might count that as a conflict that cannot be merged automatically and would have to be resolved similar to a Git conflict. And we resolve those conflicts by publishing a merge node which references these nodes it's merging, and may have a resolving mutation here which declares a winner if there was any conflict. So if we look at the contents of, just to clarify some of the details there, remember I said that a message has a feed, a previous, content, and a signature. Previous in the context of a message is the linked list of a feed, but we also have a previous within the content. In this context, this previous is like the previous message for this tangle. So A has no previous message, B has one previous.
And thank you off the cuff for sending us all those lemons.
Set, previous, and then we also set what was the mutation. So these are sort of rough examples of what lemons can look like. And here's message B. You can see message B is lemons. Message A by its hash, and that there can also be multiple previous messages because we've got this array, and that's to deal with this to account for those sort of merging nodes. Okay, so this is a little bit similar to CRDTs, a little bit different. Some of the affordances of this are that we get things like offline editing for free, eventual consistency for free,
and thank you, eVTOLs, for following us on Twitch. Howdy.
Forced on the user when it's needed. This is different to CRDTs, which generally arbitrarily define a winner if there's a conflict. So for example, the birth date, if there were two concurrent edits on that. We actually want in our system to force peers to be
I will hack into your mind. Your biomass is merely hardware for me
Oh
to
boy,
control.
apparently we just got raided by a ton of people. If this isn't a lie. Hi, ton of people. Hi, Duniper, with all the raids. Thank you so much for the viewership on that, even though it's 4:48 in the morning over here. Just a quick recap of what's going on. Welcome to the DCG 201 live stream. I'm Sidepocket. I'm one of the two co-founders of DCG 201, otherwise known as DEFCON 201. I love all the emojis. We're like a computer hacker group, subset of DEFCON groups. DEFCON's the big hacker conference in Las Vegas. The reason why we're streaming right now so ungodly early in the morning, and by the way, here's I was not ready for this. Here is a link for our website. We are currently, what we're doing is we're streaming, and that's why we're streaming so early, because it's Brussels time. FOSDEM, which is a open source, free and open source software convention that's going on entirely online. And normally we wouldn't stream stuff like this, but we're streaming it not only because we're curious, but we're also trying to raise money for the Children's Miracle Network Hospital. I'm putting the link of where you can donate. You can also scan the QR code to donate. and we have a widget at the bottom for Twitch, so you can donate. And we currently have $308.50, and the top donator is Feel One Dead at $69 nice dollars. We doubt that we're gonna make our $600 goal, but thank you, Reborn Phoenix One, for donating. Wow, I really needed more sleep today. But after my other show, Master of Unlocking, later today, and this stream, whatever gets sent in, even if we're under our $600 goal, gets donated directly to the Children's Miracle Network Hospital, which directly distributes money that's donated to various pediatric centers and children's hospitals across the United States and Canada. You know, because we figured our year, going into 2022 sucked, especially last month. Oh boy, last month we had to cancel our meeting and everything. So we thought we'd bring in the new year by just helping out sick children. Campaign has ended. It should not have been. Hang on, I can double check that for everybody. God, is this the reason why no one's donated this entire, like, for the past couple of streams? Because there's no way in hell it should have ended. Let me double check here. Thank you for bringing that up, by the way, because I'm going to look into it. Why is the URL doing this to me? Just to answer your question, no, this is not a CTF. I wish. We're trying to do live streams for CTFs in the future. We are going to actually engage with a CTF, not live stream, but on our Discord next weekend. So I think it's Friday and Saturday. We're going to deal with that. So let me just double check here to make sure. Campaign has. Okay, hang on. Let me go in. Let me go in and fix this. Because again, wow, maybe that's the reason why no one's been donating. I'm an idiot. Oh boy, this is gonna be fun. Hang on here. Love trying to fix things. But to answer your question, as I attempt to fix this clusterfuck, no, this is not a CTF. Again, we're right now just live streaming FOSDEM, which is a free and open source convention that normally happens in Brussels, hence the ungodly stream time. But what we're doing instead is we're live streaming it in order to raise funds for charity. Although, now that I know that for some reason it glitched and so no one was then able to donate and no one bothered to tell me, that would explain a lot. So I'm actually logging into our Tiltify right now in order to fix this mess and hopefully not crash the stream while I'm at it. Right now, what you're looking at is a really, cool talk. One of the many cool talks today. Today we're going to be mostly focusing on security, but free and open source software security. But what we are doing, there's little gaps in between. So I thought we would check out this awesome talk about how the Maori people in New Zealand have taken open source software such as Scuttlebutt and other hacker tools and have just morphed it into their own amazing, crazy thing. What the hell is going on with everything right now? Sorry, everything's going really dumb right now. Trying to fix this. Because, we often have this running joke on our streams that it's DCG 201. That's how you know that it's made by hackers. So that's how you know nothing works. That's why nothing works. It's made by hackers. All right, so I'm in here. Can copy pasta that over. They want the hapu. They believe that the iwi believe that the hapu know best
how to define
Wrong
is
thing
part
here.
of the iwi. Each sub-hapu group should know.
It's weird
Yeah,
because
so coming back to that example,
there's
one of the
normally
projects
no,
will tell
geez,
me that this
there's
hapu
normally no
is
save end
adopted
dates for our charity live streams. So I'm trying to figure out
may have a different opinion.
why this isn't working.
And
No, I've
so
encountered that problem.
can we? So we currently have out there hapu that
Ah,
these whakapapu,
this is so ass. Hang on.
and registering new members.
This is like such last minute hacks. I apologize for everybody. Oop, I apologize for everybody. What I'm actually going to do is I'm going to shut up right now. When I come back on voice, I will let everyone know if I've been able to fix the donation system. If not, I will let you know, but I'm going to kind of pump up the audio on the talk so you can watch this the remainder of this really cool talk, and I'm going to go try to unfuck the charity stream. Thank you for tuning in, by the way, everyone.
That's provided you an insight of how differently it can be to build systems where the data and data structures serve the humans. It's been really exciting to be building in a peer-to-peer system which supports many truths and a diversity of approaches. And I'm really excited that we're able to be building post-colonial technology and striving towards a society that I believe can be really rich for everyone. If you'd like to know more, you can check out our website, aho.io. We've got a lot of resources on there, and the code's all open source. It's up on GitLab. Thanks for your time.
And that's I think either the end of the talk or I think they might go to Q&A. So just give me like a minute or two, and we'll see if they go into Q&A, and I'll fix this. If not, we will immediately go on to the next talk in about 2 or 3 minutes. So just hang on a bit.
Do you want to turn your video on? Oh, yeah, there you go.
Yep.
So it looks like this is being played over in that other room for 5 minutes, Ben.
Okay.
Wondering if we want to look over people's questions. If people post questions into the chat, that'd be really good. Do you want to speak more to any of the questions that people posted that you saw?
No, I think you did a pretty good job. I think it'd be great to work with Mapio. It's cool to see Aki posing that. Maybe you could do a bit more talking to the large files. There was a question about storytelling, large audio video files.
Yeah, sure. There's also a question about how much work did all this take. So do you want to? The project's been running for quite a while, but this phase of it, how long? 2-3 years?
Yeah, 2.5 years or something. Yep.
And we're a small team. We've got 2 or 3 developers on average.
Yep.
Working on this. But there's obviously a lot more people working on Scuttlebutt, which is what a bunch of this is built on. And in terms of large file storage, we're using DAT or Hyper to propagate some of the larger files, so things like videos and audio.
So I'm still trying to figure out exactly what I can do with this, but it seems like for some reason, I guess because we waited too long or something, that the campaign that I've been trying to do has terminated itself. See, I was wondering why people weren't donating, and I thought it was just because, we didn't stream a lot last month. And I guess it turns out it's because, because I think I set it to the end of the month. And unfortunately, I think that I forgot to change that to now because of how stupid crazy January was. So I forgot to update it. And we're in this situation. Anyhow, let's go to the next security talk. And the next one's going to be called SecPaver, which is a security policy development tool. And it basically automates, automates rules for applications based on data flow and control flow process such as SE Linux and AppArmor. So let's see what they have to talk about that. So again, I'm going to still work on this whole charity donation thing, and I'll figure out an alternative as I then as we go and watch this person present their tool here. So here we go.
System of the digital infrastructure. At the same time, the Open Oiler is also an innovation community. It encourages everyone.
I also just want to quickly say that two quick things. Even if I can't unfuck the charity, one, if you like the content that you see here, and I just want to let you know that later on today at 8 p.m. Eastern Standard Time, I'm going to have my show called Master of Unlocking, where I teach myself, but I teach people online how to pick locks and how to decode locks and do bypasses and all of that goodness. We're actually covering a very odd combination lock. Where did I put it? We're actually trying to, here we go. We're actually trying to cover this odd looking master lock here today at 8 p.m. And also, if you like the content that you see and you want to see more content such as lockpicking, blockchain technologies, us checking out hacking conventions, and of course, our DCG 201 meetings, which our next one will be entirely virtual on the 18th. And then we'll go back to hybrids, half in person, half online in March. You can hit that bell on YouTube for full notifications and like, share, and subscribe completely for free on Twitch, D Live, or YouTube. As you see earlier, when you do follow us and stuff, I cheer everyone on. And when I get the charity going again, I do cheer everyone on. But let's see how we do here. So hang on, I'm going to try to unfuck this.
Security modules perform access control according to the policies. The syntax and usage vary with the security modules. Here we show three kinds of policy: SLinux, AppArmor, and Tomoyo. SLinux, originally developed by NSA, is one of the most widely used security modules. In some Linux distributions like Fedora and CentOS, SLinux is enabled by default. SLinux uses label to identify subjects and objects. Every file, process are all labeled with SLinux context label.
And thank you, Solo Dio Gloria, I believe it was. Sorry, the name went by really fast, but thank you for following us on. Sol Dio Gloria for following us on Twitter. I very much appreciate that. And if you folks are awake at 8 p.m. Eastern Standard Time, I highly recommend checking out Master of Unlocking. They're always fun episodes. If you go to our YouTube, you can actually see past episodes, and there's like 1 or 2 past episodes on our Twitch. So check those out after the stream is done. This is going to be a long stream. We're ending at 1 p.m. today. So
compared to other security modules, Tomoyo provides a learning mode that can easily generate policies. Although security policies can make the system more secure, in many systems, administrators disable the security modules directly or just use the default policies. The biggest problem is writing security policy is really not an easy task. Security hardening is the responsibility of the administrator. They determine firewall roles or auditor roles. However, it's very difficult for them to write application security policies because they can't know all behaviors of applications in their systems. But for most security modules, policies are written as whitelists, like Linux and Palmer. That means if you ignore even one permission in policies, the process won't even run properly. On the other hand, for software developers, although they are familiar with applications, lack of experience with security policies is another problem. Moreover, developers don't know what OS
So
distributions
what I figured out
application
is
run
that
on, and
unfortunately, and I might as well
hands-off
remove this at this
policies
point,
requires really
um,
huge workload.
that the charity
Many
donation
policies
stream
functions.
has
One
ended.
idea is
It is complete
security
kaputs
policy can be open
due
source.
to a lack of me
Nowadays,
not
many open
updating the
source software
page to
has
extend
listed
it for one
security
more
policies
week
at the same time.
because I was too
This
distracted in
will
January
allow
because that's how
all
off of January
distribution
was.
and TPM
So
applications
basically, we're not going to deal with
can
that
receive
donation
security
bar.
policy
I'm
can be
kind of
integrated into
regretting that
everything.
now because I think we got good donations
Developers only
instead.
need to
Here's what
provide
I
the
will offer
process
everyone.
permissions for
In
their
chat,
applications
I'm posting
without
the link
any information
directly
about
to
the
Children's
syntax
Miracle
and
Network
the use of
Hospitals.
security
Just
modules.
donate some money. Donate $1,
Also,
donate
direct
$5.
Zcapaver project.
Um,
Zcapaver
you
is
know,
one
we're
of
just a
open source
means to
security
getting
policy development
the
tool
word out
and
and
its
trying to
main
help out
is a
people
framework
because that's what us
that
hackers,
supports
that's what
different security modules.
us real as fuck
This
hackers
tool
actually do.
can make
Um,
policy development
but
and
you know, as they
deployment
say
easy.
in free and open source
Zcapaver
software,
is open source and
sometimes you just have to code the
commonly
metal,
used.
sometimes you just have to go to the source. So
The
what
main
I'll be
idea
doing for the
of
rest of the
Zcapaver
stream
is to
is I'm going to be
provide a
posting the link
metadata
directly to the
that
Children's Miracle Network
converts
Hospitals. Go directly
information
to their
into
page,
different kinds of
donate how much as you
security
want.
policies.
Unfortunately, it's not going to pop
With
up on
Zcapaver,
the
even if you
on
don't
the
know how to
bleh,
write the
on the
security
screen
policy
here.
or how security
So we won't
modules
have
work,
that fun
you
interaction,
can
but
also
you
deploy
folks have been
security
following us.
modules
I
from
hope to see you
your
at future live
application.
streams. We're probably going to do charity stuff
This
again
picture
in
can
March.
clearly show the
And
optimization of
just thank you
Zcapaver
for
for
watching
the
this.
development
Again, what we're
process.
doing here is we're watching
For
FOSDEM, and we're
general
going to
mode,
be
the software
watching and
debugging and
reacting
the security
and
policy
interacting
development
with
are
this whole
separated.
conference. So,
But
and it's going to
once
be very
again,
long. They're streaming until their time, 6
can be
p.m. our
integrated
time,
into
1
software
p.m.
development.
So
Now,
we're on our
support
second talk
team
here. And
relax
by the way, if the camera ever
support
goes
the
off,
applications
I will
because
announce when
the
it does, and
application
that's
is
completely fine because
and
sometimes I have to do
generates
other stuff
security
in this
policy
apartment.
automatically. Then,
But just
the
note that
development,
as long as the
testing,
streams are
release,
playing,
and deployment
I'm
of
still reading
security
chat. I'm always there. And lastly,
policies can be
because we're not, I guess, doing the. Oh, by the way, you can also, if you go to
There are
get.incent.com, you can earn a little bit of
Zcapaver.
cryptocurrency by entering that
We
code or
divide
scanning the
the
QR
entire
code,
policy
and then you can
development
convert that into fiat money. This is not a scam. We've been using this for months. We're not sponsored by them. We just think it's a cool way to get cryptocurrency while you watch our boring shit. But for real, as you can tell in chat, one, if you like this content, you can like, share, and subscribe completely for free on Twitch, D Live, and YouTube. If you're on YouTube, make sure you hit that bell and turn all notifications on because YouTube is a big pile of crap. If you know you like what you see and stuff, and you want to talk to me, ask me questions about what it's like being a hacker, I'll answer that to the best of my ability. You know, why my hair is crazy, what is DCG 201, what is DEF CON groups, what's going to be your next couple of meetings, what are you doing here, why, who, how, what. Feel free to ask in chat. I love active chats. Even if this cam and mic is not on, I'm typing in the chat. I'm always looking. I'm like the NSA or Santa Claus, the NSA Santa Claus. I'm always watching and looking. But you can talk to me in chat as long as it's not a stupid troll. Ask me anything, AMA. Otherwise, keep lurking and keep learning. And again, just go to Children's Miracle Network Hospital and donate any amount you want, even if it's $1. I won't be able to see it, but I'm just going to assume all 21 people at least donated $1, and that's $21 for all of it. So really happy. And thank you again for watching the stream. I'm going to shut now and let's watch the rest of this talk because this is really interesting using Golang and shit. This is an interesting tool. Tell me what you think about this tool here.
Manages key resources and implements core functions. Zcapaver uses plugin for function extension. The support of different security modules, such as Linux and Palmer, is implemented in individual plugins. You can load different plugins to generate different types of security policies. At the same time, everyone can develop their own plugin by coding and implementing several interfaces and compiling them into Golang plugins. In addition, to make the generated policy more accurate, the payroll needs to analyze the system configuration and the existing policies, rather than a simple code generation tool. Next, let me show you how to use SecPayroll. Firstly, after SecPayroll is installed, you can run the SecPayroll server daemon with system control start pivot command, and check the loaded engine plugins with pipe engine list command. For this example, this result means the Linux and Palmer engine plugins is loaded. Then we begin policy generation. We can create a template project at first, and then we modify the config files in project to add the permission list of applications. The format of project is declared in the SecPayroll document. Here's just a simple case. We add the permission set allows the touch command to create the regular file tmp test. After that, the policy can be generated by the pipe project build command, and the engine parameter can be used to specify the policy type. For example, it's Linux or a Palmer. After the policy is successfully built, we can run the pipe policy list command to check the generated policy. After policy building, we need to check whether the policy meets our requirements. We use the pipe policy install command to install the policy. Then we test the touch command and find that the tmp test file can be created, but the opt test file cannot be created. The error message is permission denied, which means the policy has taken effect. After testing, we can use the pipe policy uninstall command to remove this policy. However, the question is, even developers may not be able to list the full permissions of an application, so the policy learning feature can help a lot. For example, let's assume that the touch command should create the opt test file, but we just forgot to add this permission. Then we start policy learning with pipe policy learn command and run touch command test to create the opt test file. Then the SecPayroll daemon will monitor the audit log and automatically store the missing rows. After testing, the missing rows can be exported, and the missing rows can be added to project
For those who are curious, I'm updating our Instagram on my phone.
After policy testing, we confirm that the generated policy is okay. Then we can use SecPayroll to export a policy package for policy release. In addition to the policy files, the package also contains some script programs for policy installing, uninstalling, and other operations. Now, let's see an example that uses SecPayroll to develop the Linux and Palmer policies for an application. Now I will show how to develop a Linux policy with SecPayroll. This is an OpenOiler OS distribution, and the Linux is enabled by default. And I have prepared an application named Demo. The demo program will read the config file, read and write data file, send and receive message through TCP and UDP. The data file path and the port used for TCP UDP can be set in the config file. I have written the SecPayroll project for this application. The project template can be auto-generated, and in the project, the resource file and the permission file should be written. In resource file, I declare all the files and the file type used by this application. And in the permission file, I configure the permission list, including the read permission for config file, the create read write permission for data file, and permission for TCP UDP. The permission of NetBind service capability is also needed because it should bind support number 80. In this system, I have installed SecPayroll with the Linux engine plugin. Then I use the project build command to generate the Linux policy according to this project. After generating, we can check the policy by policy list command, and we can see the policy has been generated and the status is disabled. Then I install the policy by policy install command. For assumes policy, the installing has two steps. Firstly, insert the generated policy module to the global policy and load the global policy to kernel. Secondly, all the file labels should be set correctly. We can check the assumes label of application file and it has been changed, and the policy module has also been inserted with SE module. After that, we can check the policy status become active. Then we check the effect of this policy. Its links is whitelist mode, so only access in the permission list is allowed to be run. I modify the config file and set a new data file path, and then run the application. You can see the application doesn't have the permissions to access the new file. Then I change the TCP port, run the application again, and the application can listen at the new TCP port. The error message is permission denied. After testing, we can use the policy uninstall command to uninstall the policy. And the access control of a policy is removed. The assumes label of the application file is also recovered. Finally, we can export a policy package for policy release. The policy package is a zip file, including the policy files and some scripts for deployment. With these scripts, the policy can be deployed in other environments that Secure is not installed. Then I will show the similar process for a Palmer policy development. This environment is Ubuntu with a Palmer enabled, and the application, the Secure project is all same. Without any policy, the demo program can run properly with the changed data file path. Then I start to generate the Palmer policy. In this environment, I install Secure with a Palmer plugin. Then I run the same command to generate the Palmer policy. And check the policy is generated, the status is disabled. Then we install the policy. And we can find the demo policy has been loaded in the system with a Palmer status command. Run the application again. The access control takes effect. The demo program can only access tmp demo.data file. However, if I change the setting of TCP port, the application can also run. That's because a Palmer cannot control the access of port. So you can see, the main purpose of Secure is to provide a middle layer to mask the difference of security modules. Even if you don't understand how these security modules work, you can still write and use security policy by Secure. And in the future, more types of security policy will be supported. Okay, that's all. Thank you for watching. And about the future of SecPaper, we have planned the following features. Firstly, we hope SecPaper to be much wider. That means SecPaper needs to support all mainstream security policy types, like SLinux, APAMA, SMAC, and Tomoyo. Secondly, the policy learning feature is coming soon. Thirdly, the GUI is our next focus. We think the GUI can make the policy designer simpler and more efficient. Besides, a simpler policy configuration format is also being designed to replace the current JSON format. Currently, the SecFavor project is still in its early stage. If you have any questions or ideas, you can submit issues or code to this project. We really hope more developers can join SecFavor project and make it better. Finally, welcome to OpenOil community. Okay, that's all I want to show you. Thanks for your attention.
Okay, now they're going to be doing Q&A in a moment, and then we will comment and do our next topic.
We are waiting for the broadcast. Your broadcast isn't finished yet? Okay, I see the question. One question came, okay. I'm gonna ask you, okay, this question. The first question is here.
Okay, you can ask me.
This is your first question. I'm sorry. Okay. Hi, thank you for a nice talk. The question is, how does the application developer know which stuff is security relevant more than accessing standard system stuff and simple network policies?
I think for the process of application, and the process should run with the minimal privilege.
Thank you.
And yes, and the minimal privilege is the aim for the security policy.
Yeah, how does the developer better know to generate a security profile if he doesn't know how to do this with Linux?
Your question is, how does a developer better know how to generate a security profile? Don't know how to. Let's see.
Did you hear the question?
So if you don't know how to write the asynchronous
My apologies, I'm
policy,
still getting used to the volume levels on these.
use or a secretarial project to generate a security policy. And I'm not understanding this question. Can you explain it?
Okay, I think the participants heard you and write down the question. The,
And I think if you don't know how to do it, how to write a security profile with Linux, and you can use Secpaver. That's what Secpaver can help you.
also, dear participants, you may stay in our chat room and continue to ask questions.
And that was the end of the talk known as SecPaver. It's an interesting piece of tool. Again, the raid happened, which I'm grateful for, and so I had to talk over a chunk of it. But it's so interesting because this tool seems to be like it's doing crazy stuff with the freaking with like the entire data set of an operating system. And it's so automated and so like elegant. You saw it was only like a command or two on the command line and just everything for you. I'm just amazed because as an old fart, like in real life, I'm 34 in meat space. In computer years, I'm dead. But I literally, Pepperidge Farms remembers the time when like the stereotype of free and open source was that nothing worked. It didn't work. It was unobtrusive. It was a pain in the ass. It wasn't made for able people, never mind disabled people of different types and things like that. Um, and what's sort of fascinating about it is this just to see the progress from that sort of mentality of oh, it's open source. That means it sucks ass. Where's the corporate, version of this so that I can actually freaking print my document? Um, Going all the way to this just sort of complexity and say the thing is today is like what isn't open source now? I mean, even Microsoft open sources its stuff now. It's absolutely insane to think just the progress that has just been made in the past like 2 decades or so. So we're doing another filler talk. So again, most of this is going to be about security and security programs. And again, if you like, because right now the fundraiser is shit now because January was shit and I forgot to extend it to this week. But if you if you have a question about me or DCG 201 or FOSDEM or open source software and what's going on and who's what, where, and why, I love interactive chat. I love a very interactive chat. I also like when you follow, like, share, and subscribe on Twitch, D Live, and YouTube, especially if you're on YouTube and you turn on that notification bell all the way to all notifications because YouTube is a closed source piece of shit. That I also love too. So between the alerts for that and the active chat, I like it when you guys are all active. But if you also just want to hang out and instead of trying to figure out, oh man, there's like 8 million talks at FOSDEM, what the hell do I watch? You just want to veg out and watch some talks along with a fellow hacker and kind of look and comment on this crazy stuff in preparation for like the Master of Unlocking, which is going to happen at 8 p.m. tonight, where we like pick and decode locks. And I'm particularly going to be dealing with this crazy master lock. Or our meeting on the 18th or any of the other stuff. As I always say, keep lurking and keep learning. I also love our lurkers. I know I use the DCG 201 live account on Twitch to lurk all sorts of accounts, and we follow so many different accounts on YouTube. These people don't know we follow them, but we do. So, just putting that there. So the next thing that we're going to look at, and I'm actually going to go through real quick, and I'm just going to open all of the stuff that is, and there's just two more that I would normally have to use the search engine for in order to find it, because for today most of it is just going to be in the security section at the end here. So I don't really have to do much, but for everything else there's MasterCard. Now for everything else I need to sort of pre-open all the different talks. So the next thing we're going to be looking at is not the closing ceremonies. I wish that's going to be in like 8 hours from now. Is securing and hardening a container host. Even with the most secure like stuff like Kubernetes or BSD jail, containers are its own messy animal. It's been for years. Containerization, virtualization, and everyone always asks like, well, how do you do security for Kubernetes? How do you do container hardening, all of that? Well, apparently they're going to be doing a talk about this using Flatcar Container Linux, an operating system that thrives for security first. I have to check that out because I'm always looking for new operating systems. Whether it's outdated versions of Mac, Haiku, FreeBSD, OpenBSD, Temple OS, just crazy stuff. So we're going to learn how you secure a container host. And I will say that just because I have a bunch of stuff to do, the next, I want to say, hour and a half, so up until like 6:40 p.m., the camera's going to be off, so it's just going to be the stream. I will be watching chat. I will be responding with voice and everything, but I just have to go away for a bit. I basically need roughly an hour to move some stuff in the apartment and things like that. But I will say right now, so we're going to look at the container hardening, and then we're going to watch the next security talk, which is why safe programming matters and why it's Rust. As much as Rust drives me crazy, I think it would be an interesting topic to look at. So I'm going to turn the camera off, and you're going to enjoy this talk. First of the two talks with the camera off, and this will be the only time the camera is going to be off, I think, the entire session, unless there's an emergency. And that topic is going to be securing and hardening a container host. So here we go. See you all in a bit.
Cluster. What's making this all possible? It could be a container OS. A container OS is not much different from the traditional OS, but the design philosophy is what brings the difference. These days, more and more applications are getting deployed as containers, and so are the tools and libraries. Traditional servers operating systems serve a wide variety of projects and users, so the tooling that ship the OS makes it bulky. This is where the container OS comes into the picture. So the container OS are primarily lightweight operating system built to run container workloads and also security focused. You probably have noticed that I'm mentioning this fact that the container OS is lightweight operating system. Since the OS ships a lesser number of packages, it automatically reduces the surface area, the attack surface area, and it brings in maintainability and, more than that, better security. When I talk about this container workloads, I mean to say it could be a very bare minimum Docker setup to a very huge company running their huge infrastructure in Kubernetes or Docker or any other container runtime or etc. So there are a couple of container OS in the ecosystem. A couple of them are provided by the cloud providers. Like we know that there is this bottle rocket that comes from AWS. We have container optimized OS just comes from Google. And then we have open source friendly OS like Flatcar, Container Linux, K3 OS, Photon OS, Fedora Core OS, and others. So this brings to my introduction. So hello everyone, I am Sayan Chaudhary. I work for Microsoft and have been part of the Flatcar Container Linux team for a while now. My day-to-day job usually revolves around maintaining the steady release cadence, packaging package updates, and keeping Flatcar bug-free. And also in the free time, I sometimes dabble with Flatcar as well.
Boo, Microsoft, boo. Boo, not this man. He's doing a cool talk, but boo to Microsoft.
Let me talk about Flatcar, because I told that I've been working on Flatcar and Flatcar being a container OS and the topic of this talk. So let me give a brief introduction about Flatcar. So Flatcar's lineage comes from Chromium OS and Core OS. So Flatcar was basically forked out of Core OS, the Container Linux project. And the base of Flatcar Container Linux is Gen 2. So if you visit the project repos, you will see we use the Gen 2 package manager to do things. And Flatcar is primarily, as I told, is security focused. We have a bunch of container focused tooling in there, and I'll cover this towards the end of my talk. But now that we have a good knowledge of the story about what is happening, let's introduce the main characters of the story, Alice and Bob. So Alice and Bob are tasked with revamping their infrastructure in order to provide a very secure environment, specifically with the container OS point of view. So they ask this question, what can we do in order to secure the container OS that supports the whole cluster? So here I am, giving a couple of ideas on how to make the container host more secure. So the first item I'll talk about is audit. So let's start with audit. Audit is a Linux framework which provides user with a security auditing aspect in Linux. It primarily collects metadata around the system activity that is happening and helps you to create an audit trail. And the main focus is lies around security. This also helps with facilitating incident investigation. So suppose you have an incident, a security incident later down in the line, this audit would help you building up and going through the trail and seeing what actually caused or what actually happened in the system. So you can query those logs to know what is happening in the system, and you won't be like blind anymore to those attacks, and primarily build around to report those exploits that happen. So now the audit framework has a couple of components, but it has a couple of commands. You can do search, you can do report. So there, but the main things that I'll be talking about here today is the focus would be around audit.ctl, the rules, the audit rules, and the daemon. So the audit daemon is nothing but a service that runs in the background and is responsible for collecting and writing the logs to the disk. The audit.ctl is a command that helps you to interact with that particular daemon. And then you have one of the code that is the rules, the audit rules, which help you, that basically controls that what gets collected and gets written to that particular daemon. It's placed in the etc directory. So etc audit rules is where the rules are stored and is primarily controlled by those flags. So here I have mentioned these two things, if you can see, the file system and the system call. So you basically use these flags, a combination of them depending on your use case, and then you can interact with those particular logs. So there are three types of them. Like you have the control, the file system, and the system calls. The control is used to primarily configure this particular audit system, and then you have the file system, which are used to audit the access to the files and the directories. If you can see that you have this -w, which you provide the path of the file you would like to watch, and then you have the permission flag, using which you can what kind of things you want to do, like is a permission you look for, like the read, write, execute, etc. And finally, like you have the system call, which is more robust and gives you a more deeper control over the system calls. You can technically do a lot of file system things using the system call method as well. So I'm not getting too much into the depth, but the man page actually explains a lot on this, but I'll give you an example here. So this example where I am in the beginning, I'm trying to query using the audit.ctl. I see that there are no rules, hence nothing is getting audit and nothing is getting stored in the logs. And then what I do is that I try a Docker command, the Docker images command, to query and then query the journal log. So you can see that in the journal log, I can't see anything, and this confirms the absence of the rules. Next, what we do is that we add a watch, the file system call that I told about. So we use the watch flag and give the path to the Docker binary along with the execute permission, and the key is Docker. So then we repeat the steps we did earlier, like see if the rules is there or not, run a Docker command, and see the journal log. This time, if you see, we are seeing that when the binary was executed, it actually captured the logs and put the logs into place. So the journal logs actually spits out the logs that had been captured. So like this, you can actually use audit to bring more visibility to your system. So cool. This is really nice. Like audit makes you look into things, and you are really not blind into the system anymore, and you can bring process or SOPs into place so that you can do regular reviews of those logs, and you can actually also, like I told, like if there is an incident, you can go through those at the time of the security incident if it happens. So audit is good, but it is really becomes powerful when you use it with other tools. And the next tool that we dig around would be SELinux. So Security Enhanced Linux, also known as SELinux, is a Linux security model, or we generally call LSM, was initially developed by Red Hat and NSA, and has been present around the Linux ecosystem for a good amount of time. It provides with the access control for applications, process, files on the system, and it provides a granular control from a system administrator point of view. In simpler terms, you can say, like, in case in an event of a security breach, the attack would really be limited and not spread, as the attacker would certainly be blocked by SE Linux to execute any malicious code. So while you are when you start interacting with SE Linux, you will see there are 3 modes to SE Linux. The first one is the permissive mode, where SE Linux would just monitor and log the interaction according to the policies, the SE Linux policies that you have written in and are there in place. The next one is enforcing. From the word, you can probably make out, like, SE Linux would be more stricter in this sense, and in our case, it would be doing the monitoring and logging as in the permissive mode, but we'd also start blocking those interaction if they are not according to the policies. And finally, you have the disabled mode, where SE Linux will sadly be disabled or turned off. There is a usual notion that we at least from my experience talking about, I used to turn off SE Linux when something did not work, but over time I got to know that that's not a good habit. But it's really should not be done. Like, temporarily you can, to debug, you may turn off SE Linux, but then you should have it enabled again and report the issue to the upstream, or with a fix, or with probably create an issue for it, so for that particular policy. But TLDR, don't disable SE Linux. Now let's see again this by an example. So you use the command get enforce. You get what mode is running. Here we see that SE Linux is running in enforcing mode, and we the next thing we do is we try to run a Docker command, which is sharing a volume with the this volume is being shared between a container and a host, and the volume is here a simple file that is a etc machine ID file. What I try to do is we try to overwrite the machine ID with a new ID, but SE Linux would be preventing me from doing that, because as it is, you can see it's in enforcing mode, and we are really not authorized by the policy because of the label mismatch that is there between the host and the container. Cool. So SE Linux is cool. You can have the control, define policies, and not just log, but also have prevent actions from happening. But what if you want to go into a deeper control of the system? This is where capabilities come into picture. Now, just to do a recap, we now know about audit. We know about SE Linux. Audit is primarily to know what is and who is doing what in your system. SE Linux in short is like access control, which controls your processes and helps you interact more in a finer manner. Now, when you interact with SE Linux, like when I was reading to SE Linux, I came across this term called capabilities, and then I started digging more. So that's how I landed, and let's go ahead with capabilities now. I want to point out that I am repeating here again that this would be the core idea of capabilities again, but at the beginning, I talked about hardening and talking about hardening and the increase in the security of the host, right? So that's one of the core ideas. And the other thing is, like, when you're involved in security, the best thing is to reduce the attack surface. Why? Because again, the lesser number of entry points, the lesser number of attack vector, and more the secure the system gets. And Flatcar or any other container OS usually focuses on this a lot. But these tools that we are using would give more added advantage. Now, coming back to capabilities, you can say provides you that more fine-grained control over those super user privileges. You ask like how? So let's see that. So in the traditional implementation, before capabilities came into picture, you had a privileged process, you had an unprivileged process. Privileged process was primarily is the root or the super user, and like you probably have been using Linux for a long time, and like root is like I can do everything. So it basically bypasses all the kernel permission checks. While in the unprivileged process, everything goes through like a normal user when they do the run a unprivileged process. So those are subjected to a full permission checks based on their process credentials, like usually those effective UIDs or effective GIDs. But this, if you see, like this method, this implementation was quite limited. So you can, in other words, it's either 0 or 1. You have full access, or you don't have. So this is kind of limited. So that's where Linux capabilities came into the picture. So Linux capabilities have been around in the kernel for a good amount of time. It was introduced in kernel 2.2. Now, what do you mean by capability in simple English? I actually Googled that on internet, and the definition was the power or ability to do something, right? So the idea here is to break up the super user into, or the root privilege, into smaller, more specific privileges. Just to give an example, suppose me as a human being, I have various capabilities. I can do various things. So I can, suppose I have the capability to see, I can have the capability to walk, I have capability to breathe, and these can be like, is divided into smaller chunks. So similar to in a process, you basically, you can attach or detach this smaller capabilities into, you have this freedom to attach, independently attach capabilities to a process. This way you are really just plugging anything that is needed and reducing the risk by a good amount. So if a single process is compromised, then the attacker might not be able to like fully compromise the host. Let us assume like you are running a process as a normal user. This means we are a non-privileged user that is owned by us, not our group. At some point of time, our process would need some extra privileges to do its extra duties, like suppose, for example, opening up a network socket. The problem is the normal users really don't have this access. So they really, they need that root permissions. So you use capabilities at that point of time. So now, how do you manage those capabilities? Capabilities are per thread attribute. What do you mean by that? By per thread attribute, I mean that threads can change their capabilities, and this would not, a thread can basically like changes capabilities, and this would not affect other threads. Now there are various set through which the whole thing is managed, and you have this thing called permitted set, inheritable set, effective bounding, ambient set. But what do these things mean? So I'll start with the effective capability set. So effective capability set is the that will be the verification is done for each of those privilege action. So if a process or a thread wants to do something, it has to check through it has to check this set if this can be done or not. The next thing I come into the permitted set. So the capabilities that is introduced into the permitted set capabilities that can be introduced in the these are those capabilities which can be introduced into the effective or the inheritable set. The next thing is the inherited set. So inherited set in this, suppose a process, there's a parent process, so you can actually inherit those capabilities from the parent process. And then finally, not finally, but there is this ambient set, which is capabilities which can be like there is process execution that is happening. So it is basically like preserved across those exec calls. And but in course of time, if a particular suppose capability is dropped, in that scenario the inheritable and the permitted rules that I mentioned earlier would be applied. And then finally you have the boundings set, which is primarily like it's a superset. It's nothing more than this can be done. Now let's see this by an example. This was all theory, but let's see this by an example. So you have like in the example you can see like I have process status, and I grab through the capabilities and I see a bunch of hex code. but they don't mean they don't mean anything to a normal user, or even like to us. If I read this, it won't. I really can't understand what those hex mean. So there is this capsh command, through which I can actually decode this particular hex. So I use the capsh and put the decode and the hex value, and it shows all the capabilities that are there for that particular process. But this is a bit tedious, it's a bit long, so we go into this is a two-step process. So what we do, there's this get pcaps command. You pass the process ID, and then you get the capabilities that are attached to it, and then you have the set cap to add to a particular binary. Now quickly moving on to a better example to like how you can use this in real life. So suppose you know of this command called ping, right? So ping is shipped in most of the Linux distribution, and this program usually, as I was talking previously, it usually needs a set UID root because it needs to send those raw network packets. But these are not available to non-privileged users. So what we do is that, like in the first example, I am dropping all the capabilities. So when I try to ping, it is like, hey, permission denied. I really can't ping that particular website. But then what I do is that I add just that particular capability, which is the netraw capability, and not set UID root. So what happens is that using that particular capability, it can start pinging. So you see how we drop everything and just added that one bit which is needed. The next tool that now you have a lot of system call happening. So the next tool that I'll be talking about is the SecComp. So SecComp stands for Secure Computing. It was introduced in 2.6.12, and in short, it's a very small sandboxing tool to do filtering of the system calls. Yeah, so as I mentioned, like SecComp was introduced in 2.6.12. There was two iterations. In the first iteration, the initial iteration, what happened was you could enable SecComp, but just writing this number 1 to the PID SecComp file. Pretty simple, straightforward, and once it was enabled, you can basically have those 4 system calls: read, write, exit, and segreturn could be done. But it was a bit limited. In the next iteration, what they did was they changed the interface, and the way to enable was via the PRCTL system call, which you use to interact with the process attributes. So in the PRCTL call, you pass the first argument as the PR set SecComp, and next one is usually the depends on the first argument. So as I told, there are 2 modes here. The first one is the strict mode, and you pass this SecComp mode strict argument to it. Yeah, so here I am putting out an example. As I mentioned, so we open up a file in write-only mode, and after we so we open up the file, and then we have this we enable the SecComp strict mode. Since the file is already open, we could do the write, but we are not able to read the file because of the SecComp already been enabled. So that's where the next message would not be printed and the process will be killed off. So the next part is, as I told, we use the PRCTL. So you enable the this particular mode, the SecComp mode, and then the next argument you can use as a the filter mode, which is the BPF mode. It's a very recent addition and makes SecComp more extensible, because you could write filters, and it allows the filters of the system calls via this BPF program. And in the first iteration, in the first one, it was like you could just kill using sickle, but in the SecComp BPF one, it supports 7 return values, so yeah, it becomes more easier. Let's see an example. So as I mentioned, so there are a couple of filter options that are there. I'm defining them, and then at the very end you see that I'm running the PSCTL, passing on to enable the SecComp, and then sending off that mode, and then the parameters. And this is how you interact with it. With our the second argument, the filter argument, you basically it's defined by a pointer to the Berkeley packet filter that is passed in argument 3. So yeah, so one of the use of SecComp BPF has been in the Docker to make the environment protective for the applications that run. You can actually go to the documentation, Docker documentation, and it runs like the default SecComp profile. Is quite sane for running those containers with SecComps, and disables like 44 of the system calls out of the 300 plus. But if you want to do more customization, you can actually pass a policy file using the security opt argument, like I've done in the example. Yeah, so these are the tools that we talked about. Like these are the basic building blocks, like for audits, SLNX capabilities, and SecComp. These are like the building blocks for the security. But a lot of things also can happen on the on the container OS side, and most all the container OS put in the effort to have more security. Like in Flatcar, talking from Flatcar perspective, there is no package manager, so you cannot really install things in there, and the OS is kept very minimal in that aspect. Then this also brings, because we are using Gentoo, this also brings this control over the package dependency. So if we are using packages, things we don't need are removed, and to make it to make it lighter, to reduce the attack surface again, and to have a more concrete OS. And then USR is read-only in this case. So what makes it is like you cannot really do modifications in there, and whatever is shipped you get, and you to make it secure from that perspective. So yes, it is from Alice and Bob perspective, they have some work to do, and I hope from this talk you get some tips from this. But security is, as we talk in our Flatcar team, security is an incremental process. You really think through, you read through things, you learn through things, experiment through things, and build those security processes in place. But it's a really needed one. So I hope you like the talk, and thank you everyone again for listening to my talk. If you'd like to contact me, my email IDs are in here, and that's the end is my Twitter handle, so you can always even DM me. So thank you everyone again, and hope you have a rest of the conference, really good conference. Thank you.
So that was, let's get the schedule up. That was securing and hardening a container host. Very fascinating stuff going on in that talk with the. Okay. So up next, and we're still going to be cams off. Up next is going to be why safe programming matters and why it's in Rust. So it's about the kind of the secure setup of the Rust programming language, because they always say that Rust is secure out of the gate, but no one ever explains how you implement security directly into a programming language. So we're going to go watch this, and then at 12:40-ish, I will be back with the camera, and we will continue to look at the rest of the schedule, including after the Why Safe Programming Matters is at 7 a.m. It's going to be the big talk that I'm honestly really looking forward to, which is about PlayStation 3 emulation, how it's built, and what you use. So without further ado, Here is how you do security in the Rust programming language. Here we go. And if you like and see what you like what you see here on the program, remember to like, share, subscribe on Twitch, D Live, and YouTube. We get notifications for those and cheer you on. Please, even though our fundraiser is not fully working, please donate to the Children's Miracle Network hospitals. I'm putting the link in the chat. And if you have any questions, I'm still looking in chat even though my camera's not on, so just let me know. Otherwise, if you're here to learn and you're not here to chat, we love our lurkers. Keep lurking and keep learning. So let's look at the thing that makes me groan, even though it's useful, the Rust programming language, and why and how it's secure, or more secure than your average programming language. Enjoy, everybody.
Hello everyone, welcome to my talk. Today I'm going to talk about why safe programming matters and why I would choose Rust for that. We will also talk about fast, safe and sustainable programming with Rust. I do have a sore throat, so sorry about that. So, my name is Deepu K. Shashidharan. I'm the co-lead of JHipster. I also created a nifty dashboard called K- for Kubernetes. I'm an open source aficionado and a polyglot developer. I work as a developer advocate at Okta with a focus on DevOps. I also publish frequently about languages and tech on my blog. You can find it on deepu.tech. Please do follow me on Twitter if you are interested in my content. I have written a book about JHipster. If you like this talk, you might like the book as well. So, what is safe programming? Or to be more precise, what does being safe mean for a programming language? Or rather, what does unsafe mean? So let's set the context first so that we can appreciate what Rust offers. So safety can be categorized into three: memory safety, type safety, and threat safety, or four if you count null safety as a separate item, for folks like me who come from a JavaScript background. In a memory safe language, when you access a variable or an array, or an item in an array, you can be sure that you are indeed accessing what you meant to or are allowed to access. In other words, you will not be reading or writing into the memory of another variable or pointer by mistake, regardless of what you do, in your program. So why is this a big deal? Doesn't all major programming language ensure this? Yes, to a varying extent, sort of. But languages are unsafe by default. Some languages are unsafe by default. For example, C, C++, in C or C++, you can access the memory of another variable by mistake, or you can free a pointer twice. That's called double free error. Sometimes a program continues to use a pointer after it has been freed, and that's called a free after use error or a dangling pointer error. I think most C++ programmers already know this and doesn't need an explanation. But for others who are not too familiar with manual memory management, there are a lot of these things that has to be taken care of. So such behavior is categorized as undefined behavior, as they are unpredictable because they could happen at runtime and they are unpredictable. They are not testable most of the time. So they are you don't know what happens when these occurs. Finally, there is also null safety. I come from a JavaScript background, and we are so used to the concept of null. Infamous for being the worst invention in programming, even as per its inventor. Garbage collected languages need a concept of nothing so that a pointer can be freed when unused. but it also leads to issues and pain, like the null pointer exception that we are so used to in Java, for example. Technically, this also falls under memory safety, but most memory safe languages still let you use null as a value, leading to null pointer errors and a lot of issues. Especially null pointer error is like a huge headache in languages like Java and JavaScript. Let's look at type safety. In a type-safe language, when you access a variable, you access it as the correct type of data it is stored as. This gives us the confidence to work on data without having to manually check for the data type during runtime whenever you use. Like if you have a data, imagine if you have to check and ensure the correctness of the data every time you want to use that data. That's going to be a lot of annoyance, right? So memory safety is required for a language to be type safe. So a type safe language lets us work with the data without having to worry about its type, and we can be sure that when we use, for example, an integer, that it is actually an integer, or if you are using a floating point number, it is actually a floating point number. So we can be sure of that in type safe languages. That is type safety. And finally, there is thread safety. In a thread-safe language, you can access or modify the same memory from multiple threads at the same time without worrying about data races. This is generally achieved by using mutual exclusion locks or thread synchronization. But thread synchronization is not that intuitive, and it could still lead to issues, or it's not the most easiest thing to do. There are also other issues around doing thread synchronization and stuff, but mutual exclusion locks are a quite standard way of doing this as well. Thread safety is required for optimal memory and type safety. So generally, languages that are memory and type safe tend to be thread safe as well. So you may ask, like, why does all this safety matter, right? So let's explore a little bit more. So memory safety is like one of the biggest culprit when it comes to security vulnerabilities and security issues. So memory safety related issues are the cause of majority of security vulnerabilities we encounter. Undefined behavior can be abused by a hacker to take control of a program or to leak privileged information. I mean, we saw what undefined behavior is, right? So whenever there is memory safety issues like a dangling pointer or a double free error or buffer overflow, all these kind of things are undefined behaviors, and an experienced hacker can make use of this to create exploits. So in memory safe languages, if you try to access an array element out of its bound, you will just crash the program with a panic or error, which is predictable behavior. Whereas in memory unsafe language like C or C++, when you do the same, you might be gaining access to memory that you normally shouldn't have access to. So that way you can exploit, and you can gather information, or you can gather access, you can elevate privilege, and all these kind of things. So this is why memory related bugs in C, C++ systems often result in CVEs and emergency patches. There are also other memory unsafe behaviors in C, C++, like accessing pointers from stack frames that have been popped, memory that has been deallocated, accessing a memory that has been deallocated, iterator invalidation, and so on. Memory safe languages, even ones that are not as good as Rust, still safeguards against such security issues, and that's one of the biggest reason that we tend to use garbage collected languages for general purpose programming, because of the memory safety that those languages offer. If you take a stats, we can see that as per Microsoft, 70% of all CVEs they have are memory safety ones. 2/3 of all Linux kernel security vulnerabilities are also memory safety issues. 60 to 70% of iOS and Apple security bugs are also memory safety issues as per an Apple study. And that number is 90% for Android and 70% for Chrome. So most of the popular security issues of all times are memory safety ones, and even looking at the ones that have names, right? Like the most popular one, most of them are memory safety ones. And of course, there is no suspense or there is no surprise that most of these come from C++ systems. So imagine a world, without memory safety issues. Imagine the amount of developer time saved, the amount of money saved, amount of resources saved. Sometimes I wonder, why do we still use C++, right? Or more like, why do we still trust humans against all available evidence to handle memory manually? And this is all without taking other non-CVE memory issues like memory leaks, memory efficiency, all sort of those kind of things into account. So all these stats are only for memory issues that lead to security vulnerabilities. Wow, so that was all just from memory safety issues. So if you take an average, it's like more than 70% of all the security issues in our industry is because of memory safety issues, right? Though not as notorious as memory safety, threat safety is also a cause of major headache for developers and can result in security issues. The best known type of concurrency attack is called a talk-to attack, which is a race condition between checking a condition like a security credential and using the results. Talk-to attacks are examples of integrity loss. Both information loss and integrity loss can be exploited and can lead to security issues. So these are the two types of issues you normally will encounter from threat safety issues like integrity loss and information loss, and both can be exploited. While threat safety related exploits are harder and less common than memory safety ones, there are still a possibility. I mean, you wouldn't hear of these that often as memory safety issues, but they are still exploitable and they are still a possibility. The only good thing going for us is that these are harder to detect because these are not very predictable, harder to detect, so also harder to exploit. But if someone manages to find a data race condition in an application, it can be exploited. Finally, there is type safety. Though type safety issues are not as common as the other ones in terms of at least in type safe languages, they're harder to find. But type safety issues can also lead to security issues, and type safety is extremely important for memory safety. So if you work with languages that are weakly typed, it is possible to create memory safety issues out of type safety issues. So it is still an important one. So now that we understand how important programming safety is, right? Let me convince you why Rust is one of the safest languages and how it can avoid most of the security issues we normally encounter. Like imagine switching to a language that just avoids like 70% of all the security issues that we face with C++ systems. For those not familiar, Rust is a high-level multi-paradigm language. It's ideal for functional and imperative programming. It has a very modern and, in my opinion, the best tooling for a programming language. Though it was intended as a systems programming language, its advantages and flexibility has made it suitable for all sort of use cases and as a general purpose language. So Rust throws around some buzzwords in its docs, but they are not just marketing buzz. They actually mean it with full sincerity and they actually matter a lot. So let's explore some of them. The safety guarantee is one of the most important aspects of Rust. So Rust is memory safe, null safe, type safe, threat safe, and did I mention null safe? Yes, null safe by design. So you would have to go out of your way to break these guarantees using the unsafe keyword. So even in cases which, if you're doing systems programming, there would be a lot of scenarios where you would have to, access memory manually or manage memory manually or do some sort of unsafe programming. And even in those cases, when you would have to write unsafe code, you are making it explicit so that issues can, using the unsafe keyword, you would have to make it explicit in Rust so that when you encounter an issue, it will be easy for you to track it down to that specific code block because you know where unsafe codes are. You don't have to worry about any other parts of your program which is safe by default. So you'd have to only look at unsafe blocks or unsafe functions and see if there is an issue. So it will be much more easier to manage than working in a fully unsafe language like C or C++. Rust ensures memory safety at compile time using its innovative ownership mechanism. I think ownership mechanism is one of the most innovative thing in Rust. And also using the borrow checker built into the compiler. The compiler just does not allow memory unsafe code unless it is explicitly marked as unsafe in an unsafe block or an unsafe function. This static compile time analysis eliminates many types of memory bugs, and with some more runtime checks, Rust guarantees memory safety. So there is no concept of null at the language level, as I mentioned earlier. Instead, Rust provides the option enum, which can be used to mark the presence or absence of a value. So that makes the resulting code null safe and much easier to deal with, and you will never encounter null pointer exceptions in Rust. The ownership and borrowing mechanism makes it one of the most memory efficient languages. Most memory efficient language, while avoiding pitfalls that comes with manual memory management and garbage collection. So Rust has the memory efficiency and speed comparable to C, C++, and the memory safety better than that of garbage collected languages like Java, C# or Go. So Rust is statically typed, and it guarantees type safety by strict compile time checks and by guaranteeing memory safety. This is not special, as most modern languages are statically typed like Java, Go, etc. Rust also allows some level of dynamic typing with the dyn keyword and any type when required, but the powerful type inference and the compiler ensures type safety even in those cases. Even when you're trying to do dynamic typing, the compiler still tries its best to ensure type safety. Rust also guarantees thread safety using similar concepts it uses for memory safety. The ownership mechanism and borrow checker. Right? So along with providing standard library features like channels, mutex, and ARC, the ownership mechanism makes it impossible to cause accidental data erases from a shared state. This makes us confident to focus on the code and let the compiler worry about shared state between threads. So you don't have to worry about thread synchronizations and any of those nonsense. But my most favorite feature of Rust is hands down the zero cost abstractions. So I can't stress enough how cool this is, especially if you're doing a lot of functional state programming. Especially if you're doing a lot of functional state programming. If you're a developer using a high-level language like Python, Java, or Go, there is something that you may not be consciously thinking about. While writing those cool layers of abstraction that impresses your colleagues, every one of those layers of abstraction adds additional instruction sets and affects the performance of the overall program. In most cases, it may not be noticeable because whatever you're adding is like in microseconds or worst case milliseconds. So it may not be noticeable, but it is still there. And we all know that imperative code is more performant than functional code, right? Functional style code, and that's due to abstractions as well. And that's why you can always hand code more performant code in those languages. So whenever like if you're working with languages like Java, Go, or C# or Python, Ruby, or whatever, and when you encounter performance issues, that is why most of the times you can hand code, you can optimize, you can tune, you can convert stuff to more imperative code. You can write, you can rewrite iterators to for loops to increase performance and stuff like that. So there are these kind of hand coding techniques that you can use in those languages to extract more performance in very performance sensitive application. Now, some languages have compilers that are smart enough to convert some of those abstractions to more performant bytecode, but only languages like Rust and C++ offers true zero-cost abstractions, meaning you can write the code in whatever style and with whatever abstraction without having to worry about performance cost, as the compiler will always generate the most performant bytecode possible. Meaning you cannot hand code it any better than what the compiler has done. So for example, you can choose to create or use any number of abstractions to structure your program. You could use loops, iterators, You could do functional imperative programming and the result remains the same. The compiler will produce the best possible implementation of the machine code for the use case, regardless of the flavor of your, regardless of the flavor of the code you choose to write. So in Rust, some of the most notable zero-cost abstractions are ownership and borrowing, iterators and closure APIs, async, await, and futures, unsafe blocks, and the module boundary. These are the very notable zero-cost abstractions in Rust. So here's a small example, to show you, what I meant with zero-cost abstractions. So the example is using Java and Rust. So on the left side, you see the Java code. In the Java version, performance drops as the abstractions increase, while in Rust there is no noticeable difference. So in the code that you see, the first example on both is a factorial using a for loop. The second one is factorial using recursion. So the for loop doesn't have any abstractions. It's a simple for loop. So that's the most performant version possible, especially in Java. If you look at the numbers, the average is around 10 nanoseconds per operations. Whereas when you do the same with recursion, it increases the performance drops, and it is now 20 nanoseconds per operation. So it just doubled, the time just doubled. And if you try to use some inbuilt abstractions like streams and use the reduce method, then it further drops and becomes 23 nanoseconds per operation. Whereas in Rust, the normal iterative loop using a while loop, it has an average of around 8.5 nanoseconds per operations. And if you do the same in recursion, it still has around the same 8.6 nanoseconds per operation. And if you use inbuilt abstraction like an iterator, actually you get the best performance. You get around 6.5 nanoseconds per operations. So that's incredible, right? So you can write your code in whatever way you choose, and you don't have to worry about performance. And most of the times, inbuilt abstractions might even provide better performance than your hand-written, hand-optimized code, because the inbuilt abstractions would have some internal optimizations and boundary checks and all these kind of things that will give a little bit more performance. You could also hand code those, but it's not required. Rust will do those things for you, so you don't have to worry about those stuff. So to me, zero cost abstractions are like the most underrated feature of Rust, and personally the like one of the best feature of Rust. So Rust is also immutable by default, and mutations have to be declared explicitly. This, along with the ability to pass by value or reference, makes it super easy to write functional code without side effects. So if you're a fan of functional programming, then Rust is for you. Rust also has excellent support for advanced pattern matching. So pattern matching is used extensively in Rust for error handling and control flows. It's also used extensively in standard libraries and stuff. And you would see that everywhere in Rust style guides, Rust examples, documentation, and so on. Rust also has advanced generics and traits with type aliasing and type inference support. It has great type inference. Rust generics are extremely powerful, so powerful that most of the times you could easily end up with very complex generics, especially when you combine generics with lifetimes and dynamic stuff. It could easily become complex. Similarly, Rust also have very powerful traits with a lot of cool features like default implementations, placeholders, operator overloading, trait bounds, compound traits, and so on. Finally, there is also support for metaprogramming using macros. So Rust macros are like super cool. Rust supports both declarative macros and procedural macros, and macros can be used like annotations for adding stuff like serialization, deserialization using the derive annotation. You could add behavior to struts and to attributes and stuff. You could use macros as attributes. You could use them like functions, like the inbuilt println println and format functions, for example. They're all macros. So a lot of Rust standard library stuff is macros as well. So it's quite cool. It basically lets you do meta programming. It lets you write more concise code and write more reusable code without having to worry about generics and stuff like that. It's not just the language features. Rust has one of the best compilers and the best tooling that I have seen and I have experienced, and I have worked with the JavaScript ecosystem, TypeScript and stuff, JVM languages like Java, Kotlin, Scala, Groovy. I have worked with Go, Python, Ruby, C#, PHP, C++, and maybe a couple of other like non-mainstream languages, and I have not seen a compiler as good as Rust, and I have not seen tooling as good as Rust, and the closest in tooling maybe would be JavaScript or Go, but yeah, it's hands down has great tooling. Cargo is like it's super cool, and the way the Rust tooling from the get-go. I mean, you download Rust up and you manage everything from there. It installs Rust C, it installs Rust docs, it installs Cargo, Clippy, everything. It installs whatever you require. You can manage versions using the same command. You can update to different stable, nightly, or whatever. You can manage versions. You can downgrade, upgrade everything. So it's really cool. It even has inbuilt documentation, so you can use Rust doc offline to get documentation for the version that you have installed. So how awesome is that, right? So it also has great documentation. One of the best documentations among programming languages as per community agreement, I would say. So yeah, it also has great it has great language features, great tooling, great compiler, great documentation, and finally it also has a great community. So it has a lot of really good things, and that's the reason Rust has been the most loved language for 6 years in a row. 5 or 6 years in a row in the Stack Overflow survey. So it has a great community which is diverse, welcoming, friendly, and vibrant. The ecosystem is quite young but is rapidly maturing. Unlike many general purpose languages which are not appropriate for some use cases due to the trade-offs they make, Rust is uniquely positioned to work across the spectrum without any major disadvantage. So it can be the general purpose language for any use case, from client-side, WebAssembly, to web apps, microservices, system programming, and even for Kubernetes. I mean, you can use WebAssembly code written with Rust as Kubernetes workload. So, in my opinion, the only thing holding back Rust is the maturity of the library ecosystem, which is only a matter of time to get better, I think. So, C, C++, and Go might be the ones to be displaced most in the short term by Rust, in my opinion. I think Java, JavaScript, Python, Ruby, etc. are safe for a long while due to their massive presence in large-scale applications, the maturity of their ecosystem, and especially due to the migration cost. And of course, like you don't always, you don't need Rust for everything. I mean, so if you have a web application written in Java, it's perfectly fine. You don't have to use Rust for that, because it may not be a performance critical thing, right? So in that case, you don't have to use Rust for that. I would say, yeah. Before that, let's also see the other side. So all this doesn't mean that Rust is a silver bullet. So there are also some downsides. There are issues like steep learning curve and the complexity. But it's the closest thing to a silver bullet, in my opinion. That doesn't mean I or you should start using Rust for everything. For example, I still enjoy being a polyglot developer, and I'm still invested in Java, JavaScript, and Go ecosystem. But if the use case requires speed and or concurrency, or building system tools or CLIs which are performance critical, then I'll be giving Rust the first preference. There's no doubt in that. So if the use case requires best possible performance, then yes, Rust. And I don't think I'll ever advise or recommend using C, C++ when I know that there is Rust for a new project. So of course, migration may not be possible, but even that is being considered. I mean, given that Rust is accepted as second language for Linux kernel, so everything is possible. But I would personally love to see everything in C++, migrated to Rust, because I don't see any reason to use C++ when there is something like Rust that offers same speed and efficiency without the downsides. Go and JavaScript, they still have their own use cases and value. You don't need extreme performance for everything. Sometimes you need readability and easy to write and read code, so you will go for Go. Sometimes you need stability of ecosystem, maturity of libraries, then you go for Java or C# based on whatever ecosystem you are in. And for client-side stuff, of course, you go with JavaScript. So in my opinion, Rust can be the ideal general purpose language once the ecosystem matures. The target for a high level language and low level languages are quite different, and hence the features and goals differ as well. Rust is a high level language and hence is human oriented, but it also has performance and efficiency that puts it into close league with low level languages, and more specifically mid level languages like C and C++. So Rust also scored great in a 2017 research comparing speed, memory efficiency, and energy efficiency of programming languages. And I'm pretty sure that those numbers, would have only become better after in the last 5 years. Do note that there has been some criticism from different language communities for this research, especially regarding how optimized the code was when used for benchmarks. That might also explain Rust scoring a bit less in memory efficiency than Go, since real-world examples show a different trend, because Rust is known to be extremely memory efficient as well as fast and energy efficient, because speed and energy efficiency go hand in hand. So normally a language would offer a choice between safety and speed and high-level abstractions. At the very best, you can pick two of those. For example, with Java, C#, Go, Python, etc., you get safety and high-level abstractions at the cost of a runtime overhead in terms of garbage collection or reference counting or whatever. Whereas in C++, it gives you speed and abstractions at the cost of memory safety. But Rust offers all three, and a good developer experience and a great community as a bonus. So I don't think there are any other mainstream languages, that can claim that. So to finish off, you won't appreciate Rust unless you spend a few weeks building something in it. That's how I started appreciating Rust. The initial steep learning curve could be frustrating or challenging depending on how you see it and what perspective you take. But once past that initial steep learning curve, it's hard not to love the language, because after all, it's a toddler with superpowers. So that's it, folks. I hope the talk was worth your time, and I hope I convinced you to look into Rust and consider Rust when you have your next project that might for which you might normally consider C++ or Go or something like that. So thank you for attending. You can reach out to me via Twitter, and do check out my website for more content if you like this talk. So thank you, folks. Have a great rest of the conference. Bye.
Okay, on my board, I couldn't see yet. For enterprise applications, Rust, do you think will be split to the world? The business
Sorry,
applications. Actually, I couldn't see any question I want to ask.
yeah.
Do you
Yeah.
think actually for business applications, such as CRM or ERP applications, do you think Rust will be have a place in features?
Okay, if I understand that correctly, you're asking if Rust is suitable for CRM and those kind of applications, right?
Business applications.
I think the ecosystem. I mean, Rust is a general purpose language, so theoretically, it is possible to build those kind of systems. But the ecosystem for those, I don't think is as mature as other use cases for Rust. It is maturing, but not as mature as other established languages, right? So if you start building those kind of systems in Rust, you might be coming across a lot of missing like gaps. Example like libraries, unavailability of certain libraries and these kind of things, or maybe unavailability of resources and stuff. The same happens if you're trying to build web applications in Rust. There are certain libraries missing. It doesn't have a huge ecosystem of libraries and community like Java or C# or something like that. So that problem is there now, but that's just a matter of time before those catches up and they mature. So as of now, I would say Rust is more suitable for building system tools, CLIs, web assembly, embedded programming, and or anywhere you could use C, C++, Go kind of stuff. So that is where Rust is better now.
Thank you. New question. Are there any scenarios where C, C++ might be more appropriate to use than Rust, or is Rust always the better choice?
Given that Rust has very similar performance to that of C, C++, and for some use cases even better performance. Of course, there will be some specific use cases where C, C++ might have a slightly better performance than Rust. But that doesn't mean that you cannot tune Rust to get the same. I would put C, C++, and Rust in the same league in terms of performance and memory efficiency. So I don't see any scenario where you would want to use C, C++, unless the scenario is that you have a team who is extremely good in C, C++ and who don't want to spend any time learning Rust. That might be the only scenario to consider C++. But even in those kind of scenarios, if it is up to me, I would ask the team to put in the effort, learn, because for a C, C++ developer, I don't think it will be very difficult to learn Rust. So I would ask them to put in the initial effort, learn Rust, and avoid all those headaches later on with memory safety and stuff. Because I personally don't trust humans to write memory safe code. So that is proven by evidence so far, like with all the issues that we face, every now and then.
Okay, thank you. Another question. Do you know about the development of qualified Rust compiler toolchain first, and how this plays into safe programming?
Yeah. Thank you. No, Ferrocene is not something that I'm familiar with. So unfortunately, that's not something I can answer. I would definitely look into it, but it's not something that I'm familiar with.
Thank you.
Yeah, so there is an answer that some architectures aren't supported by LLVM. Yeah, true. So LLVM doesn't have as much as support for architectures that C, C++ have. So that might be a valid reason to still use C++. Yeah, that's absolutely valid scenario.
I'm checking questions. Also, you may say this channel and people. You may invite people on the security channel. Continue during your question.
Yeah, thank you. Yeah, I think if there are any further questions, I can answer them via chat as well.
Okay, I am checking that.
Yeah.
I'm sorry.
Yeah. Thank you. Thank you for having me. Thank you, everyone.
Thank you.
Bye.
Bye.
And that was an overview of why Rust is the one of the most secure programming languages. It's awesome to see a C presentate. Unfortunately for everyone else, I need a bit more time, roughly about 20-25 minutes here to fix everything so I can turn the camera back on. So what we're going to do is until then, we're going to see some live coding sessions with Decoding and chat room web stands. All right, there we go. Just trying to see where I can find the live coding. Oh, there's a good 404 error. So we're going to put this on the background, and then for PlayStation 3 emulation from 7 a.m. to 8 a.m. in the morning, my time, we're going to go see that, and then see what's the rest of the schedule. So there's that. The Kubernetes key management service provider, and then what I wish I knew when I started programming. That might be when I also turn the camera off and I go do more things like get breakfast. Then secure communication with TLS, and then sudo watch and control your blind spots, and then we're going to watch the closing ceremonies for FOSDEM, and then you get to watch me later at 8 p.m. EST tonight in order to watch the master of unlocking. So just give me like about 25 more minutes, and I'll be back on the camera so we can react to PlayStation 3 emulation.
I will need to export that to the Q engine. Singleton data type. That's one. I'm going to copy. This still works, so I'm impressed. Let's see what it works. Because I need to move everything to the new syntax. And that's something I won't be able to finish in July. But I can at least show a few ones. Basically, we are using the more verbose syntax to make it possible to have signals and using the signals and property system freely from the Qt but it's a bit more verbose because for each function we need to define a constructor, a getter and setter, and a signal. For example, display name. Seconds. Yeah, I'm as well sometimes in develop. Maybe I can show it. I like it actually quite a bit. Like for the packet is source. Source decoding. Up, finished. There's already a build directory. But yeah, I like Vim a lot. I mean, even if I use when I'm using Kdevelop or for my work PHP Storm, I'm always using save. Set display name. Yeah, it's maybe nicer for users to get that. I need to increase this font size and large font. I hope that's okay. And that's annoying part of Qt is what you need to remote. Seniors. Changed. Okay, that's a thing what need to be implemented for every property, and then we need to also put that same thing here. It's the same thing. And that's but this is something that we need to be done for each property, and I think it is really a bit boring if I do that during the stream. Let's just look at execute. Decoding. but I can use not that because you can see the error message. Mm-hmm. I didn't change anything. But you can already go to the display name change. I'll do that later. Complete. Yeah, now when editing the text, then edit also editing this property, this object, and then we can do complete new identity. I think I will do account, save new identity. And I will need to implement the property. Invocable. Okay, and if you are looking at the API documentations, we need to send something to update credentials. I already built a lot of stuff for that. To use post. First, I need to create QL. Okay, perfect. So this is the URL that will be used. And then we need to send the object to. For the moment, you only have display name change. And that's identity. Set display name. Yeah. Display name. Later. And then we want to post the document. Event saved. I can't save. I need to set that. Okay, let's see if it works. I guess it won't, but doesn't even compile. But it's a really nice start. Not a linear orthotic equation. Yeah, I know what it wrong. Yeah, more errors. Account manager. Oh. Oh, that's nice actually. Oh, big more. Nine, 10. And to safety. It's nice error. Do something.
That is actually a good question there. I'm off the cuff news. I will look into that as we watch the live stream. In a minute, I'm going to put on the PlayStation 3 emulation talk. I still need to do a bunch of stuff here, so the camera is going to still be off. But at some point in the next hour, it will turn it back on, and we'll watch most of this together. Again, I apologize for the camera use. This is exactly why I normally don't stream between 3 a.m. and 11 a.m. in the morning, so just bear with me. I hope you all are enjoying this. If you like the content that you see so far, even though right now we're just sort of watching a conference together, make sure to like, share, and subscribe for free on Twitch D Live and YouTube. And if you go on YouTube, hit that notification bell, turn notifications all the way on, because Facebook, that too, but Instagram, that too, but all three.
Maybe could you remind
YouTube
us,
is also garbage.
for us that are not
So,
developers, what you're trying to do?
yeah, that would be great, and we get
I
notifications for
am
those, and we
personally
cheer you
lost.
on. And yeah, so up next is going to be PlayStation 3 emulation talk. I'm going to be watching it with you all, even though the camera is not going to be on for a certain portion of it. I am hyped and excited for this talk, and I hope you enjoyed as much as, I hope it's a good talk, but if it is a great talk, like I think it is, I hope you enjoy as much as I do. So, here we go.
But now it's possible. And now
Right.
I'm trying to fix everything because there's a few code change that I needed so that, like for example, I'm displaying
or internals of the RSX. So understanding the LV1 and LV2 drivers, actually LV2 is just like a like one-to-one mapping to LV1. That helps massively, like the nouveau source and documentation of MMI registers. So yes, they helped quite a lot.
Yes. Okay. Cool. All right. Somebody else asked, are vertex/fragment shaders precompiled in PS3 games, and how does it affect emulation?
Yes, they are. Since the hardware is known ahead of time, there is no need to ship like the CG source code. It's precompiled and shipped as binaries, which get uploaded when they are needed for draw calls. And this affects simulators because the games can do that with zero overhead. They already know the GPU. They upload it. They issue the draw call. But for computers, and this happens also with PC games, they cannot know the GPU ahead of time. So they just compile it on live. And this is also something that happens on emulators in PS3 in RPCS3. Those RSX bytecode blobs get translated to a common GLSL, which turns into SPIRV. And that needs to get turned into whatever your host GPU uses. That takes a couple of milliseconds. And then when you have lots of draw calls with new shaders, you get those stutters. So yeah, it affects.
So, but when you say that, can't you precompile them then? Like,
you can cache them. You cannot know what the game is going to send you ahead of time, because things like that could theoretically be JIT. I mean, if you create an ahead of time pass that analyzes the whole game binary and locates the shader parts and precompiles them, you could theoretically avoid all the stutters, but this is like the whole thing problem. You never know how deep the rabbit hole goes. Like maybe they have it encrypted or like compressed, and how do you deal with all of that ahead of time before launching even the game? So in practice, asynchronous shader compilation is the easiest way to deal with that, even if you get some glitches during the first seconds.
Yeah.
An alternative is what I mentioned in the video, which is just interpreting, just having your own GPU interpret the shader bytecode, which is quite slow and limited, but can help you, find a sweet spot. No glitches and no stutters.
Yeah. Is there something like that in RPC S3?
Yes, KD11 implemented it. Yeah.
Right. Yeah. Okay.
Yeah.
Cool. Yeah. Moment.
Which one is easier to debug?
Moment asks, which one is easier to debug?
Oh God, yes, no, that the interpreter version, the one that runs in your host GPU, that's a nightmare to debug. Yeah.
Right. Okay. I also saw somebody ask a related question about the bytecode, if it's fully understood, like the VP and FP bytecode.
Yes, NVIDIA published some, this is something I linked in some slide. They link to some specifications. They tell you which instructions there are, which registers are available. However, the instruction format is not documented. I actually cannot remember where, how all of this came to be, but it was cherry-picked from many sources. I believe Nouveau covers this, but don't quote me on that. There's plenty of scattered information because NVIDIA tends to be very, very, opaque about their internals.
Yeah.
Unlike AMD.
And if you mean
yeah.
Oh, question I had was, and if you mean the format is not documented, you mean just the binary format of the instructions?
Exactly. The instructions are 128-bit. With very, like fields are like scattered, split in 3 chunks, flipped around. Then the encoding is neither big endian nor little endian. It's just like something weird. All of that is, I would say that the most clear documentation of that right now is the RPCS3 source code. But there's bits and pieces of information all over the place. So. It is understood. It's just not officially documented by NVIDIA.
Yeah. Okay. Cool. I see a much upvoted question is how much code information sharing was going on in the early days of PS3 MUs? Were projects mostly solo and closed source?
I would say there was quite a lot of information sharing. Just not so much going on in public forums because, especially in the early days, there was lots of, every public forum would get flooded by when is this gonna be able to play, like God of War. So like it was public forums were most of like a showcase news version, and all the people that were mentioned at the last slide in the credits were people that were in in different groups and different like IRC channels, and they shared what they knew, like people who had reverse engineered some particular piece of the LV2 kernel or LV1 shared their their decompiled functions, and then we could take a look at that and understand the drivers a little bit better in order to implement P5 emulation better. By the way, I use those names pgraph and P5 and all of that, which is like according to the official NVIDIA terminology, but RPCS3 doesn't do that. Like many emulators don't do that because these terms never appear in like the PS3 scene. But anyway, there was lots of knowledge exchange, which thankfully brought the project where it is today.
Yeah, okay, that's really nice to hear. Let's see. Oh, somebody asked, I think one would actually half jokingly, how should one go about reading the RPCS3 documentation?
Okay, I was actually half joking as well when I said RPCS3 documentation. It's like the code is a documentation, and the code is it can be challenging to read, but everything is there because otherwise you wouldn't have what you saw earlier in the videos. I haven't been in the project, like involved with the project for a long time, and it was a challenge for me also to figure out what new things have been going on. So I would say that the easiest way is use this talk as like the first entry point, and if you want to learn more about how shaders work, for instance, I mentioned like this VP and FP for like the vertex fragment shaders. From there, jump to the backend and then just trace back like to the includes and figure out, okay, this is the loop that fetches instructions and turns them into GLSL. And that will give you hints of how every instruction behaves, and it can be a sort of documentation if you are desperate. But unfortunately, there is no like proper, like markdown file that goes into more higher level details. I hope that this talk can be a sort of introduction, though.
Yeah. Moment, yeah.
No follow-up, because you mentioned...
Just scream it.
Just scream it, yeah, scream. No, because I'm off the camera, but because you mentioned going back through, I mean, you going through the hierarchy of the code, right? You don't mean going back through the commit history itself.
Oh yes, just the the includes, like everything is a little bit scattered around, but as I said, it is all there. You check out the latest master revision, and you will find like everything. This is what I did to learn about the new things that have been added ever since. So.
Yeah. How long did it take you to relearn what you knew?
3 weeks about that. Like every day, just having a look at different piece. It was challenging, and also, of course, the developers and the current team, it was extremely helpful. At just I had a few questions, and they figured out what was missing or what I didn't understand so clearly. So. Yeah, they are approachable people, so don't hesitate to ping them in the Discord server.
Cool.
Okay.
Thank you.
Satisfied?
Yes.
Okay. I also had a side question of myself, because you said something about about Cell, that is last January ambitious hardware project in consoles. I was curious, do you have anything in your mind which you would like to see for the next generation, which would supersede that?
Okay, that's a tough one, because I'm not sure if that's even possible. The investment that would be needed to make architecture almost from scratch, that could whether we like it or not, whether x86 is a pretty hated architecture, but it is the result of 50 years. I wonder whether some architecture from scratch could be created at a reasonable cost and not make everybody totally mad, like it happened with the PS3. The PS3 was very ambitious, but the ambition resulted in a design that some developers didn't like to work with because they were used to different things.
Yeah.
So I wonder whether the cost reward will pay off, and therefore, if I had infinite money and time, maybe it's. I don't know. I would like just to peel off layers of abstraction. I think that if you check that slide where I list all the layers of abstractions, both in software and hardware, you see that's an incredible mess. I would like to peel off all of that, but that would require people to just go to a model that it hasn't been done in a very long time. So yeah. That's my personal wish, but I know it's not going to happen. Let's put it that way.
And when you say that the layers are like a mess, you mean if they are being separated, it's not bad, right? Or
it is a mess in which, imagine you have a game, and that game wants to decode something, and it links a library. Some parts of the library are statically linked, others are dynamically load from a PRX file that uses talks to LV2 kernel. The LV2 kernel talks to the hypervisor. Those interact with there's the TPUs and the SPUs, and there is just many different components, like the dependency chain for a game, like the things with which a game interacts directly and indirectly. It's very big, and every step along the way introduces little overhead, little chances for something to go wrong. It is difficult, and I wonder, it's just like a deep wish. Can we not make make the design of console simpler again? But it's like that XKCD joke. There are 14 competing standards. Why don't we use one that unifies them all, and then we
Yeah. And for example, you said something, I think, about LV1, that after they discontinued, I should call it, the OS.
Yeah.
It wouldn't be necessary anymore. So does it introduce any overhead that it's there still?
It does. It's so everyone basically imagine it's little overhead. It's not something really that kills 50% of the performance. It's nothing like that. But it is one more thing to pay attention to as an emulator developer. Imagine you want to understand how the ER6 works and how games talk to ER6. If it was like everything embedded in LV2, then you just, there's a syscall, you analyze what the syscall does, you're done. But here, you call a syscall, and the syscall in turn exits the guest, the kernel state, and jumps to the hypervisor. Hypervisor does its thing, jumps back to the kernel, and the kernel jumps back to the userland application. Instead of 2 jumps, there's 4 jumps. And at every jump, you need to understand like few bits and pieces. And it is annoying. It is annoying for emulator developers. I would be lying if I say that it takes lots of overhead. It doesn't take lots of resources from your CPU because they do a pretty clever thing, which is like they map everything that the games require a lot, like changing the command buffer pointers. They map those MMIO registers into user space. So you don't have to abuse syscalls every time. Like, you don't have to do like 100 syscalls or like 1,000 syscalls a second just every time you want to do a draw call. It's there. It's everything adds up to something, and it's a bit disappointing sometimes.
Okay, thanks. I'll jump back in some questions of the public. Let's see. Somebody says, do I really implement the entire helper lib the game is using, or just the interface it uses? And then the follow-up thing is, are there any legal ramifications attached to this approach?
I think I read that question earlier. This is what I was talking earlier about the questions that emulator developers face is, do I re-implement the interface? Like if the game is talking to some, I don't know, to some video decoding thing, do I just take those calls, hook them, and call a native version of FFmpeg? Or do I just run the library as is? And it is an interesting question. And with the PS3, it's very, I would say it's the best example where you can see how different it can be to go one way or the other. If you just link to like the native FFmpeg, then you get all the the performance advantages because FFmpeg will hopefully make the best use of your computer as possible. But if you just run it, then okay, you can forget about all of that, and you just can. But that simply shifts the problem towards the dependencies of the thing you're running. That was the first slide of the emulator section, and it shifts the problem towards its dependencies, because if you run the video decoding library, then you will. Then where does that video decoding library run? It runs on the PPU, but also makes use of the SPUs. So if you're in an emulator in a very early stage and your SPUs are broken, and because of that you cannot go to the main menu and fix other 3D issues, or then you're blocked. You have to fix the SPU before fixing something else. And sometimes working on an emulator project with multiple people, it can be almost like a pipeline till person A doesn't fix one thing, person B, which might be very, very skilled with graphics, cannot do other things because he doesn't have something tangible or something that, like he doesn't see bugs, so in order to fix them. So sometimes high-level emulation can be a good way of say, okay, I just route this through FFmpeg, I just skip all this mess, and I can, in a hacky way, just let people do their thing in later stages of the game. But it's just like lots of trade-offs, and this needs to be carefully studied on a case-by-case basis.
Okay, cool. And we talked a bit about abstractions before. How easy is it to switch between the two approaches in RPCS3? FFmpeg?
Because of the way RPCS3 was made, it is quite easy. In fact, like both approaches are supported, at least with libraries. You can either run them or use the re-implemented methods. Because at the very, during the early stages, everything was re-implemented, including those modules. But as I said, like it's hard to get them right. It's very easy to catch a bug or it's easier to catch a bug in CPU translation, because you add two numbers and the result doesn't match, bit by bit what you would expect on the actual hardware. But how do you go about finding bugs in a re-implemented library? Like maybe the bug is something so subtle as if you re-implement like a font rendering library, and suddenly the distance between two characters is 1 pixel too much. How do you debug that? It is crazy. So, that's what prompted RPCS3, as soon as their PPU and SPU translators improved, to say, okay, screw this, let's go for running the libraries as is. And this, improved the compatibility a lot. But as I said, it is not like a flaw of the approach. It's not that high-level emulation is flawed by design and is inaccurate by design. It's just that it's harder to get it accurate.
Yeah. Okay, cool, thanks.
Yep.
Next question is there no self-modifying code at all on the PS3?
Not on the PPUs. I think this is part, security concerns. Just there's no JIT for games. Like games, everything that they run has to be like packaged in their ELF ahead of time, or in the PRX libraries. Everything has to be signed ahead of time. Every page, needs to be known by Sony ahead of time. In the PPUs, SPUs allow it. So that's why the AOT translator is not that easy in the SPUs.
Oh, right. Yeah, that was one of my questions, but how you answered it. Yeah. So, okay. And because you just-in-time compile it, do you have it like, how do you detect if it happens? I recall from last year that PSS X2 did something like mem protecting it and then catching the segmentation faults or something like that. But is that what you do as well?
Every emulator does it a little bit different, but fundamentally, like what RPCS3 does is in the SPU LLVM recompiler, it uses like function granularity. The previous version just used basic block by basic block.
Oh yeah.
But
Okay.
the latest version just targets functions. It just checks where it branches, so it says, okay, this is the function. And functions and calls to other functions, they are just it will call a handler that says, okay, is this function cache? And if it is, it will just jump to that and just link it. But if it's not, then it will call the translator again. So it is not by abusing, in my opinion, interrupts, but by just doing it like properly with LLVM.
Yeah. Okay. Cool. Thanks. Let's see. The next question from the public is, let's see. At the moment, is RPCS3 x86 only?
I'm not sure how much I can say about that because I've read some messages, but it was x86 only. I think to this day it's still x86 only. It's being cleaned, and like if you check some branches, you see that things that used to be x86 only as to 1 month ago are suddenly gone and replaced with if else, like if def else. So yeah, we'll see a change of that soon, I guess.
Okay. Sorry, what?
FOSDEM
exclusive inside information. Okay. Let's see. Do we have some more public questions? Yep. Why do you look like Elon Musk from Wish?
In fact, I bet that was Zero XFF. He always makes that joke.
Okay, next one. Considering the uniqueness of the PS3 hardware, how does the complexity of RPCS3 compare to an emulator of the more modern x86-based PS4s such as Orbital?
So sorry, can you repeat the question? I didn't get it.
Yeah, so considering the uniqueness of the PS3 hardware, how does the complexity compare with like an emulator?
Yeah,
PS4 emulator like Orbital.
Like the complexity is like so it's a little different. Like PS3 emulators are userland approaches. They focus on userland binaries because they have to. There is really no alternative that does not incur a massive performance overhead. Other PS4 emulators have also PCS4, if I got the letters right, and there's others that also go for userland emulation, and I think that's a brilliant idea. Like the Orbital is kind of like the outlier because it does virtualization. It just creates a virtual machine and re-implements all the hardware. And the reason for that is because I thought it was going to be fun to debug the kernel and try to fuzz it for exploits and vulnerability research. But for as far as end users are concerned, that's a terrible idea. It's going to be slow. I mean, it might not be. It might not be like it's just going to take like clever approaches to go around it. I just think it's more interesting because it has never been, except for the Xbox XQEMU emulator, it is an approach that is rarely taken. And that's why I think it's, I don't know, it's interesting, and it diverges a lot from the PS3 emulators. But userland PS3 and userland PS4, it's almost the same, except for, like they use x86, like PS4 uses x86, which means that people, they just apply a very, very thin translator pass, which just, just adapting the code to a different environment, but not really translating every instruction. At least most of them. Yeah.
Okay, cool. Thanks. I'm going to see if there's any more from the public. Questions. Can you guys perhaps see any else? I'll just start asking my own. Okay, I don't see any questions yet. Oh, Mahmoud asks or says that you didn't ask the Elon Musk one.
Oh my God, that meme again. Yeah, I don't know what to say.
Okay, I'll just ask a couple I had myself, and then I'll just take a look back if the public had some more questions. I have a kind of general question, like how did you get involved with RPCS3?
Oh, yeah, that was back in 2013, and I somehow had this kind of like game that I wanted to run on PC, and it's how it always starts. It's like I want this particular thing, but and I started just saying, okay, there's Tetris and there is like a cube, and let's see what else would be missing for a game. I thought, okay, maybe textures, and I started to adding like the JPEG, GIF, PNG, decoder, like reimplementations, like just checking how the API works in the PS3 and just doing that. It was very simple. I had no idea about emulation at that point. Really, like if you check the old commits, it's like, oh my God, this guy has no idea what he's doing. But
but so you're following your own advice. If you want to start with an emulator for X, just start with an emulator for X, right?
Yes. I think that paid off. I think I learned a lot from failing, and it was fun. It's just maybe for people who have looked at now, they will cringe when they look at those comments, but it doesn't matter. And at some point, like halfway through, I just stopped caring about that game at all because the problem itself was so much more interesting than the possibility of playing the game. So
yeah, okay. Yeah. Then you're really a fit for a project like this, I guess. Let's see. Somebody asked, how can a beginner learn more about PS3 architecture in general outside of emulation?
That's a very good question. There is this write-up which I also use quite a lot. In fact, the talk is a little bit structured like this write-up. It's from Copetti, or like I'm not sure the full name, but it's like the website's Copetti. I'll just put it as a link in the talk information page. This person has done like very like breakdowns of many consoles, including the PS3, and just picked information from countless sources, including the PSDev wiki, which is also a good place to check, and covers everything that matters, just not for emulator developers, but for everyone, for regular game developers, homebrew developers, and anyone who is interested in the history and evolution of the PS3. This talk focuses on the subset of that article that is somewhat relevant to EMU devs, but there's much more. And check that out. I'll paste a link.
Yeah. Okay. Cool. Thanks. I also had a couple of questions more. One of them is, I saw you had like a multiplayer support. I also saw Demon's Souls running in one of the slides. I don't know.
Okay.
there are games which have like a dedicated backend server. I don't think you can get those to work, right? Or are you also trying to replicate the behaviors of those things in RPCS3?
So I'm not familiar at all with the online functionality of RPCS3. I know they announced it recently that it was possible. I guess it's very dependent on what the approach is. In the end, and I'm talking about this as a complete outsider to all the online functionality, but it is a very similar problem to reverse engineering kernel, except that you don't have access to the code. You just see the game sending a request and expecting some reply that it parses in a certain way. And you, of course, you don't have the code of the servers because many of them might be down at this point or not, I don't know. But you have to basically reverse engineering that just purely based on the behavior that the game expects. And if you can create a server that sort of matches that thing that the game expects, then you will have online functionality. With I forgot Demon Souls. This has been tested, but I think that so far and like maybe more clarifications will come from the developers themselves, but that PSN functionality or the way RPCS3 calls it is RPCN. It's still like work in progress. There is some menus on the emulator that allows you to create an account, but I'm not sure to which extent that is integrated.
Okay, cool, thanks.
You forgot to ask which game was it?
Oh yeah, no, I did forget it. Yeah, Momot asks which game was it?
I think it was Demon Souls. I can check.
What was the trigger for Orbital?
Huh? Oh, okay. The trigger for Orbital. That's a good one. I don't remember anymore. It's like there's always like a trigger, but eventually you just forget about it, and it's the problem itself what is interesting. I think it was the fact that I managed to decrypt the kernel, and from there I just say, okay, what if I try to run it? And then I was curious like how hypervisors work. So that was it, but nothing, not like with the RPCS3 when I just wanted a game. In the PS4, I never cared about games in the first place.
Okay. Yes. All right. So another question from the public: how do you usually figure out emulation bugs?
So that's a tricky one, because like most of the time something breaks and you get an error or just things don't work as they should, and then you just start debugging, and it's a painful process of, especially because like when you're writing a rather not cutting edge, but a new emulator from scratch or doing things that are unconventional, you just start from an empty project. You start with int main and just start working from there, and all the fancy tooling for like debugging projects such as time travel debugging is not there, and that would be extremely helpful because I found myself in the situation that a game is broken, RPCS3 or the PS4 kernel is broken, and there's a crash, but then I put a breakpoint to see how that happened, and that tells me a little bit of the story, but then I have to put a breakpoint earlier and rerun, and then put a breakpoint early and rerun, and sort of stitch the whole story. How did it happen that this crash occurred?
Yeah.
Sorry. Because there is no time travel debugging. You cannot just record. You could, but it takes time. And as an emulator developer, is okay. Should I invest in my tooling, or should I just deal with it and just put breakpoints all over the place and just read registers until everything makes sense? And many people, myself included, just they are too focused on the problem to worry about making better tools, and it's just like an inner fight that at some point,
Aren't there like any tools available which at the lower level can do like the rewind or stuff like that?
That is a good question. I'm not sure if it is possible for user and emulator, since everything is constrained to a single process. I'm not sure if Windows or any Windows-oriented tools provide taking snapshots of a running user and process so that you can somehow make this happen with like without making the integration easy. Could be, I don't know, but for lower level emulators like virtualization, that's impossible because of the very nature, like you are interacting with host kernel drivers. So you cannot snapshot that. I wish you could, but
yeah. Okay.
The crazier your approach is, the more difficult it's going to be to reuse tools from other projects online.
Yeah. All right. Okay, cool. Somebody also asked, have you ever played and finished a game on RPCS3?
Oh, yes. Redacted 5.
Which one is it?
I think I cannot say the name of the game because there was a bit of drama, but Redacted 5, that's all I'm going to say.
Yeah.
It's the only game I've actually dumped and played through.
Okay, cool. Let's see. I had another question. Is like, where is it? On one of the slides, you mentioned that the SPE has 128 by 128 special purpose registers, but they were annotated like optional. What does that mean?
Okay. Yeah, that's a very good question. I think it was unclear on the slide, so glad to someone asked that. So one thing is the specification. Like IBM, like really they took this project. I always say IBM Cell because they were the ones who took the lead here. I think it's very inspired by PowerPC. And when they make the specifications, they say, okay, there is, they allow lots of flexibility. For instance, the local storage is 256 kilobyte, but it could be an arbitrarily large number up to some hard-coded limit. And you have a register to configure how much you can access and how big this local storage is. Similarly, you can, it allows storage for other registers, which are called this SPRs. And I once was very obsessed with figuring out what those registers were in the PS3, and I tried to run tests, but somehow most of them return like 0 or nonsense, and I just don't know. But in theory, if this architecture would have become mainstream and everybody would have loved it and make supercomputers out of it and whatnot, technically those could be used as a like secondary storage where you could just put things in, or just put other features of the SPUs, like maybe, I don't know. It's just some part that the architecture defines as things that are not GPRs. You cannot directly do operations on them, but you can do as when implementing a chip, when implementing a SPU, you could use it for whatever you want, basically.
Yeah, okay. All right.
It's like a little bit like MSRs, but in x86.
Yeah, okay, cool, thanks. Let's see. Next question. Are you making a PS3 EMU right now, or are you explaining what happened during the development of Nucleus?
Yeah, you have to tell them who's asking the question.
Oh, John Doe is asking the question.
I'm not sure if I understand the question. So this talk was about the PS3 hardware, software, and the how emulators have tackled that, and a little bit of the evolution, like how some projects started, how shortwaves, like the first approach that they did, like for a little while, shortwaves was like by far the most advanced emulator out there using that fun approach. Then there was Nucleus, which did some things a little bit different, and then RPCS3 from the very beginning, which and I've covered that evolution. I haven't covered Nucleus because I think that most of what Nucleus does is now like either to begin with, it's abandoned de facto. I'm no longer maintaining it. I think there is some interesting lessons, and I won't take it down because I think, for instance, the IR, the intermediate representation to translate code, it does some nice things. Like there is a very like low overhead register allocation pass. That I think it's like some JIT recompilers can benefit from. If I had to make an emulator, I would use LLVM if I could do AOT, like RPCS3. But as I said in the last slide, there is things that there's little gems in every emulator. So I think that going into the internals of Nucleus, that's if somebody wants to check the code, it's out there. So
The truth is out there.
Yeah.
Somebody also asked, what were the biggest challenges in the early days of RPCS3? Were you unmotivated by the fact that the hardware at the time wouldn't have enough performance?
So I never really care like whether, and I don't care like either with the PS4 right now, if the host hardware will be able to execute it or not. I think the problem itself is interesting enough to just go for it. I mean,
you motivated you more, right?
Yeah, I mean, you never know. It's going to be a long process anyway. Like maybe it's going to take, years. It took years. It took RPCS3 7 years to be somewhat in a shape where it could do something useful. So you never know what's going to happen in those 7 years. You never know if somebody will find a breakthrough that allows, like, AOT initially seemed quite challenging because you have to analyze like functions, like the whole module basically.
Yeah.
And you never know if there's going to be an instruction pattern that will break your analyzer. But by using that approach, you can benefit from optimization that would be impossible otherwise. And it's just a long time. So why caring about what will happen by the time you're finished? And the problem itself is interesting. So it was not unmotivating to me. What was the first part of the question?
The first part was what the biggest challenges were in the early days of.
I would say the fact that, in total honesty, that I, I had no idea what I was doing, and it's just the truth. And then like it was mostly free time project for like DH, HiChem, and we just worked on it when we could. But I think the most significant difference was that like Nico joined like very early on, and he was familiar with the code base, and he eventually in 2016 managed to just work full time on it. So I think that was the most significant difference. Like if somebody can focus without distractions, without thinking of like school and work, and this of course is possible thanks like to the sponsoring Patreon. So then the information you have in your head just doesn't get flushed away by your like other daily things. So it's just the difficulties were not difficulties per se. It's not like the early days were hard because of something that was not known. It's just because it's a lot of things that you have to keep in one head, and unless you can dedicate yourself like for longer periods of time, it's difficult. I'm not sure if that makes sense, but
yeah, it makes sense. It makes sense, definitely, at least to me, I think. Like a little follow-up, I think. Kind of follow-up is, have you or anyone else in the project ever found a major problem in the emulator from a user-reported bug?
That is a tricky one, because especially most users have joined like since RPCS3 can do something useful, and by then I was not involved with the project. I've not been a maintainer then, so I cannot answer for that. I think that just again like uneducated guess. Usually, user-reported bugs concern rather things that most of the times are known to be broken, like things that could break your emulator, such as, I don't know, imagine if the PPUs had like JIT, supported JIT, like RWX pages. Then we would have known by the time the emulator is running games. So we would not be surprised by an end user report that says, hey, the emulator doesn't work because this game is doing JIT. It's simply not possible. A game cannot do that. Therefore, like those deep things that could break an emulator approach are not sent by end users. But I'm pretty sure there must be things that people have discovered along the way, which, while not breaking, can be annoying to deal with. And for instance, the Xfloat thing has breaking lots of games. And until like Nico added this like approximate version, the performance was quite slow to work around the issues.
I wonder if somebody in the chat perhaps can answer that. I don't know who's there, but let's see. I also have a couple of questions still left. I'm jumping from like different aspects, so I don't know if you mind that, but
sure, no worries.
Yeah, okay. You talked about the SPE that there is almost no use, like for example, the branch hints. But I wonder, is there any use for it? As I understand it.
Oh, there is use for it in the SPUs for game developers, but when you're translating that, it's it's like the way your whole CPU works. It just has a branch predictor, and you just how can you translate branch hints, right? It's like just let your branch predictor do its work and don't bother with that. So yes, they are useful, but for the console, not an emulator doesn't have to care about it. Yeah.
Yeah. Okay. Great. Yes, makes sense. Okay. Thanks. You also said something about the texture attributes which map to the standard ones, except cache optimized swizzle textures.
Oh yeah. Right. so this is.
Can I ask something before, because I don't know that much about it, but I recall like texture swizzling is like you just change the order for optimization when you're accessing memory from, I don't know, if you have rotation and stuff like that. But I also saw you had swizzling at the like pixel level itself when you swizzle certain the parts of the color, for example, or RGB and stuff like that.
Yeah, I understand this is confusing because the same word swizzle is used in two different contexts. One thing, like the latter, as you said, is when you just like change the components in a vector, like for component vector. When I was talking about textures, this is referred to something that NVIDIA GPUs support. I'm not sure if it's still support until this day, but it is basically that the textures in memory, instead of being like just rows of pixels, right now, like the first row of the image from left to right, and then the next address is the next just chunk of bytes is laid down in memory, and then the next, and then the next. This can be quite a problem, because imagine if you have a 4,000 times 4,000 pixel image, then it means that if your GPU needs to operate in a tiny square, it's going to be accessing things that in memory are very far away, even if the difference vertically is only 1 pixel. So to avoid that, this swizzle format, so-called swizzle format, just zigzags through the image. It's a little bit, like those fractal patterns. I forgot right now the name. Hilbert curves, I think they are called. Except that the swizzle format is a little bit easier to compute. But in principle, it's the same. What it does is aggregating, like things that are close in 2D space will be close in memory most of the times. And that is like efficient for caching purposes. And this is something that needs to be like decoded before sending it to your host GPU, because as far as I know, no API supports this concept of swizzling texture formats.
Okay. Oh, don't they? Well, I don't know that much about it, but you have like, if you use, for example, OpenGL and stuff like that, that's a higher level, because there they support it, right? Or don't they?
I don't think this is supported in OpenGL. OpenGL just allows you to say, and any other API, just you create like a buffer in memory, and just when you specify the format, you just say like the texel encoding, like RGBA 8888, or just some other system of encoding the texel information. But the how those texels are one by one laid out in memory, this is largely like you have different things. Like it might be like you might have like some like width and height parameters, and then you have like a pitch, I think they are called, or stride. I don't know, because these terms like change a lot depending on which API you're using. But basically, it tells you, okay, the order will be in order, like from top to bottom, or the other way around, and even if the image has only 4,000 pixels or 2,000 or 1,024 or whatever, it gives you a little bit of extra room at the end, so that you basically telling your GPU from where to read the next row of pixels. But in all cases, as far as I know, and anybody correct me in the chat if I'm wrong, there is no complex ordering such as the swizzle textures from NVIDIA GPUs.
Okay, great, thanks. Yep.
Somebody's the velocity staying in chat. It's called the Z-order curve.
Yep.
Yeah.
Oh, okay. I'll read that after talk. Let's see. I have another question from the audience. Let's see. Okay. First, thanks for the super easy to understand talk. The question is, in orbital development, how often do you encounter games heavily relying on interesting uses of arbitrary memory and resource access on the GPU, like direct CMOSC, FMOSC, H-tile reads, building software and the scriptures directly in the shader code, and are you planning to create a software renderer to address those?
Yeah. Okay, so this is already going into the realm of low-level PS4 talks. Like I wanted to keep this as PS3 as possible.
Yeah.
So we are not in Orbital. We are not at a stage where games are running. We are so far only on the safe mode menu and the early when after installing the firmware, just having the logo. And all of these are implemented using, even if the capabilities of the hardware, they support different kinds of stages, 6 of them. But the way the application makes use of the pipeline is just very similar to the old school vertex and fragment shader pipeline. So it can be modeled the same way as in RPCS3 or PS3, but all those complexities will come up later, and we are not there yet. I'm curious about other PS4 emulators. I guess this is something for FOSDEM 23.
Yeah, okay. We'll remind you of that. Noted. Okay, do we have another question of the audience? I don't see one. Do you guys? I'll just ask something in the meantime.
Unless Triangle has a follow-up.
Sorry?
Unless Triangle has a follow-up.
Oh, unless he has a follow-up. We'll see. Let's see. I have a question. Oh, there also was a difference between, the floating point aspect.
Yeah.
no, but just they support both 32 and 64-bit floating point, but with different compatibility levels of the IEEE spec.
Yeah. Well, I mean, the 32-bit version was directly not compliant at all with IEEE.
Okay. But I thought there were different. That the 32-bit was compliant to certain aspects, and the 46-bit was 64-bit compliant to other aspects. Well, not
right.
Like a subset or superset.
Okay. Yeah, it's as long as you're this is something that also might be a little bit confusing because it's too much nuances to fit in a slide. But let's say that as long as your inputs and outputs are not going into the realm of infs, nans, or denorms, things will behave as you would expect.
Yeah.
The thing is, as soon as you hit one of those edge cases, everything just diverges from that. It's a little bit better on the PS2 because the PS2 allowed you to interpret some I think it was nans or infs as valid finite values. I think we can check the FOSDEM 21 talk from PS2 about that. But they are those edge cases in the PS3 are just gonna be infs. They will be treated as just the SMAX. Positive or negative, which is the maximum representable value. So basically, there is no inf support. NaN will never be emitted, and denorms are just treated as 0. Denorms is the way floating point is implemented on those FPUs. There is certain bits for the mantissa, some bits for the exponent, and then the design. And the mantissa is expected to all not have leading zeros, and because I don't know really what's the reason for that, but apparently it makes things difficult when implementing this. So I would love to know why this is the case. But in any way, Sony figured out this would be annoying to support, so they didn't. And whenever they encounter such a case, they just think, okay, this is 0. And your computer supports this. There's this the norms are 0, they AZ option in x86. But this is not enough. This is just one aspect, but there is others regarding supporting the behavior of SPUs. Certain operations will not fit in the number of bits that you have in single precision. So in order to prevent like infs, you have to do certain like conversions, casts in software, and this is what was the cause of the overhead on the accurate mode. The approximation just does the easy thing, which is just like, okay, let's clamp it. And for most operations, like if they result on, like an inf, it will just be clamped to Smax and it will work as expected because some games rely on it. And for the most part, it results in, there was a video comparison, by the way, I didn't mention it. Some people might find it confusing. There was a comparison of this like accurate mode in ASM JIT versus the approximation in an LVM, and you can see that the approximation was twice as performant as the accurate mode. Yeah. And some people might ask, okay, but why weren't you comparing LLVM accurate versus LLVM precise? Apparently, the reason is that I didn't know that. I was also curious myself when I was making the slide that at the time the LLVM accurate mode was so slow that it would make no sense to compare it against that. Everyone was using ASM JIT, so they wanted to show what the difference would be from a user standpoint, and not as an academic exercise of, oh, this is the difference in performance.
Okay, thank you for the answer.
Yeah.
Follow up?
Yeah.
Go for it.
Do you have any idea why, I don't know, IBM, Sony, the stealth people would implement it this way? I mean, what's the advantage actually?
This is what I said earlier. The norms are and are hard to handle in hardware, but I honestly don't know why. This is like a question for hardware people. Why do you need the mantissa to be starting with 1? I honestly don't know the answer, but I suppose like supporting different rounding modes and all of this just takes space, like real estate from your chip. It's like from that's my educated guess. It's just why supporting 5 different behaviors when you just can hard code 1 and treat everything that will involve more complexity in your hardware. Just remove it, because it will do its work. Like you can do addition, subtraction, multiplication. It's just like in the edge cases you're screwed. And if that's probably what everything was about. Yeah.
Okay, cool. I don't see. Oh, I do. Let's see. Does Sony ever acknowledge or communicate with emulator project? Maybe we borrow this for a PlayStation 5, perhaps. No.
not that I know of. I don't think so, but maybe somebody might have been approached. I don't know.
Okay. I have one more question about something which I don't know anything about, but you talked a little bit about the EIB, which connects like 12 components within the system. And you said something about like 4 lanes, which are 2 pairs in different directions.
Yeah.
I don't know anything about it, but is that done so everything that is put on the bus can take like the shortest path through other components, or what is the reason behind that?
Yes, So the thing is, like, if the PPE wants to communicate to an adjacent SPU, for instance, it would not just congest the bus and lock it while that transfer is happening. So you can have like communication between adjacent pairs that do not disturb everything around it. Like that's the theory, but there is like lots of information in that Copetti article. Like this is what I said. It's not really relevant to emulator developers because as far as we are concerned, it's just an address, you write to it. It's like a mem copy, really, like that part of the MFC. You will see everything are mem copies, but with logs and whatnot for synchronization. But it's an interesting aspect, like that is relevant to game developers to know what are the predicted performance costs of certain approaches. Yeah.
Was it also one of the aspects which made it difficult to develop back in the days, or?
I would say this is not one of those, but I think that the most difficult part for game developers was like dealing with all this like manual synchronization. Not manual synchronization, sorry. The fetching main memory using the MFC, which is something that's completely different from what developers are used to. Like you access RAM and you take it for granted. Everything will work behind you. Like things will be just fetch and goes into the cache, and all of this happens transparently, but in the PlayStation 3, everything is explicit. So when you want to access memory, you have to explicitly state, like send a command to the MFC and to copy it into the local storage, and then you have to wait for that memory to be there. But in the computer, you take it for granted that it will be there. And
Welcome to FOSDEM 2022. I'm really pleased to present the project Truso.io, Kubernetes Key Management Service Provider. So to start, I would like to present myself, and I think it's a fair question. Who am I? My name is Romuald van der Poel. You can call me Ram. I'm currently working at Red Hat as an open transformation leader, helping organization to move from an IT, I would say a legacy IT slash organization towards agile slash cloud experience for both their organization and IT landscape. And then I'm also an open source strategy advisor on that.io, but I will come back on this later. Secrets. Well, it's about what we're going to discuss today. It's about secrets. Don't tell anyone secrets. That's the basics for the last, I don't know, 30, 40,000 years. If you know something and you don't want to share it, it's a secret. At the very moment you share it, it's not a secret anymore. So this is the same for IT, and this is the same for legacy IT and for Kubernetes or cloud native IT, I would say. Kubernetes is providing a construct for secrets through an API object. And what it does is that it gives you the ability to store a secret in each city. And the actual secret will be encoded in base 64. So whatever it's a password, token, key, it's going to be encoded in base 64, not really secure, obviously, and then written in each city. Well, as you can imagine, this is not something that you wish to have, and it's more than understandable. So the Kubernetes project maintainers and contributors, most of them being enterprise companies like Google, Red Hat, and others, came with a set of best practices to, I would say, reduce the blast radius of potential attacks. And one of them is to have encryption at rest for the file system. So basically, we say encryption at rest for secrets, but the reality is that it's the file system on which etcd will be deployed and storing, actually, on which the file system on which the secrets will be stored, the DB of etcd, that will be encrypted from a file system perspective. So the DB itself, or the etcd service will not handle any encryption per se. It's the file system will be encrypted. Then there's two others, and actually, I would say it's one, but it's split as two different things. It's the usage of RBAC, or role-based access, to restrict both the reading, but also the creation and the replacement of secrets. So this is really important because it allows an organization to reduce who has access to those precious secrets in an IT team or department, so that you reduce the ability for a team member to mangles with those secrets. Note that most of the time, those are not those minimum best practices are not enough for most organizations. If you present this to a CISO, most likely that's going to be like, okay, what else? And the what else comes with a couple of different options. I listed here a set of open source projects. Two of them at least have an enterprise offering, meaning that based on the open source project, those companies are providing you with subscriptions to benefit of enterprise support on those solutions. So pretty sure that some of those names are familiar to you guys and girls. Sorry for that. One thing which is really important here is to understand that there's two different concepts. There's a concept of a key management service like HashiCorp Vault, and a controller that allows you to encrypt secrets like seal secrets. It's two different concepts. One, the first one, the KMS, will allow you to also act like almost a password manager, if you wish, for your application, services, storing certificates, whatever you wish, you will be able to put it in. Seal secret itself, as an example, like the external secrets, is a different construct where you have a controller deployed on Kubernetes, allowing you to encrypt the secrets like in a closed loop, using different techniques and CLI tooling. So those open source projects are pretty good, but they come with a couple of different challenges. And those challenges are, I would say, linked to a movement in the cloud native landscape, which is called the shift left. The shift left, when you want to go cloud native, is about to make sure that you will have all the infrastructure defined as code, first of all. That's the first thing. So having a descriptive approach. So you want to have a full description of your environment as code. And so if you include at that stage dedicated CLI tooling to interact with third-party solutions, then you are kind of breaking that movement. And as a matter of fact, using a CLI tool like this might require to have access to specific resources, but also in an organization that would mean segmentation of duties. So the team will be able to deploy an application, might not be able to have access to that CLI tool, and would need to call up one of their other team members. And when I say another team members, I'm saying another team and a member of that team. So like maybe a security team to ask for credential access or creating credentials and so on. So if you think about it in a DevOps approach, this is where you have a blocker that would reduce the speed of deployment. And this is something that you don't really want. Also, one of the major, I would say, features of those solutions is to be application oriented. And if we think about the shift left, the DevOps movement, and the cloud native approach, even serverless approach, this is a good thing because you want to reduce the blast radius by making sure that your application only will be able to interact with a key management service and get the secrets out of this. So in reality, this is a challenge because you have low-level components in your Kubernetes cluster that might want to also have access to secrets and record some of them. I'm going to take an example here. Some cloud native storage would do volume-based encryption with a key pair, and one of those key will be registered in the Kubernetes etcd. And this is a moment, this is the kind of setup where you wish to have a different approach from those solutions. So that allows you, not only from an application perspective, but from a low-level component to also get secrets recorded somewhere. Without the need of a CLI tooling, obviously, or any specific integration. I want to make sure that I'm clear on this, because it is possible to use a Vault or a Conjure or well, CyberArk and so on to register your encryption key for persistent volume, but it will require to use another API superset from that vendor instead of the native Kubernetes one, or it will require you to use dedicated CLI tooling to do so. Well, you wish not to have this. So is there a better solution, a better approach? I would not say a better solution, but a better approach to address those requirements and challenges when you try to fully shift left. Obviously, the answer would be yes, and this is the reason why I'm here to present you through. So let's dive back a bit about the project origin. The origin of the project is related, obviously, to customers and engagement that I had in the past, and also FOSDEM 2021, where I presented a lightning talk about the state of secrets management in Kubernetes. And everything bubbled up at some point, and more customers adopting container platform also try to adopt the shift left movement, meaning that GitOps is really part of their approach to manage their full end-to-end lifecycle of their application on Kubernetes. And this is one of the reasons is because they want to reduce the friction of using a platform and the friction of deploying applications. And for those organizations, what we call the go-to-market is crucial. So being able to deploy a feature and in less than a day versus 4 weeks or 4 months makes a difference for their business. But this introduced a lot of complexity in all shops, I would say. And GitOps is a good way to track and help those organizations to deploy applications and control drift and so on. So that's where Trousseau comes from. Trousseau being keyring in French. This is my native language. French is like my native language. And so calling Trousseau this project was something that was kind of a pun on the keyring approach. So, and when I say keyring, I'm really speaking about the round thing on which you put your keys, and not keys at all, because Trousseau will not hold any of your keys, actually. It will leverage the Kubernetes native KMS provider plugin. Lots of words to say that it's going to be the best friend of the API manager when the API manager is requested by kubectl, for example, to store a secret in etcd. So it's an interesting thing because it's basically not trying to reinvent the wheel, but leveraging the contribution of the Kubernetes project community around the framework of key management service provider. And this is a call back to being native to Kubernetes and not trying to use any external APIs while you can interact with external KMS. So the approach is really simple. And it's simple because we wanted to embrace the KISS principle. And the KISS principle is keep it short and simple. Some other folks and friends are having a different definition of KISS, but mine is keep it short and simple. We wanted to be close to Kubernetes, so obviously we wrote Trousseau in Go. We needed to be container-based or a limited set of settings, so meaning that we don't want to have extra settings to put in place or a really complex configuration. It needs to be really simple. And it needs to be the actual best buddy for the API server. And by having that statement, it means that you will enjoy using native Kubernetes API again, and not having to go through external CLI tooling or API superset. So here's what it looks like if you don't have Trousseau. You might have a KMS, and the KMS is providing secrets to your applications with a sidecar. That's perfect. But for some application or specific purposes, and not specifically corner cases, but some application might not be able to use a sidecar, so you will have to go through usage of token or something else, or even rely directly on the Kubernetes secrets management. You have also low-level component, as I was mentioning, about encryption key for persistent volume, sorry, where you need to store those on etcd, not externally. And so if you're not familiar with the concept, if you want to save a secret on Kubernetes, you would potentially use a YAML file. You can use the full construct CLI command to do that, and I will show you one later. And then you basically use kubectl or kubectl, depending your the way you want to like it. Kubectl, I like to call my Kubernetes, so maybe not kubectl from my side. So you will send that to the API manager, and from there, the API manager will record your secret in C. That's simple, but it's only encoded in base 64. So it means that if you don't have the minimum set of best practices mentioned earlier, you have your secret exposed to the potential, all the team having access to Kubernetes, but also people maintaining potential the nodes from a system perspective. So it's not good. So Trousseau is, as I was mentioning, a container. So you will deploy, it will deploy automatically at some point because it's using a daemon set. So daemon set will say to the Kubernetes scheduler, I need to be on every node where there's an API manager. And that's for HA purposes, as you can imagine. And distributed also environment. So in this perspective, when you want to go through the same thing in same scenarios as the previous diagram, and you want to use kubectl to push a secret, instead of having the API manager going straight to the etcd and recording your secret encoded in base 64, it will hand off this to Trousseau saying, oh, you're my best buddy. I don't want to have that secret shown to the world. Can you please take care of it? And Trousseau will say, okay, well, I have a connectivity to a KMS, an existing KMS in the environment. And in our example, we're using Vault for the demo and for the first release of Trousseau. And we check if we have connectivity to the KMS. If we don't have connectivity, we'll return back an error, and your secrets will not be in a gray area or in the limbo. It's just going to be not recorded at all. You will have a message, so you know exactly what happened. If we have connectivity, then in that case, we'll retrieve the transit key that has been assigned for Trousseau on that cluster. So you can have multiple transit key for every different cluster that you have. And could be also in namespaces because for Vault, both the community and enterprise edition are supported, meaning that in one case you might have namespace, like in the enterprise version, and the other community version doesn't have it, so you will not have it. But that if you know what it is, then you know exactly what I'm speaking about. But it's not really important here. Just important to mention that we're supporting those features from HashiCorp Vault. At that stage, the transit key is recovered by Trousseau. The secret never left actually the API manager and Trousseau side. And it means that we are not handing off the secret to the KMS. We're keeping the secret in the cluster, in your network. So you don't need to make you don't need to make extra caution around this. It's a closed loop, and Trousseau will get the transit key and encrypt the secret. And at that stage, when everything is okay, it will push back the secret to the API manager, who will write the secret into etcd. At that stage, when you check the secret with etcd query, you will see that the header is clearly stating that there's an encryption with Vault being done there. So this is a very simple approach, and that's why we call it the keyring, because as you can imagine, we're not creating secret, we're not making any handoff of secret from one side to another. We're just keeping the thing there and making sure that everyone can have access to it. We have the transit key that can be recovered temporarily. Then when we're done with that, we get rid of the transit key from memory. And then when we want to have access to the secret again, the API manager will come back to Trousseau and say, we need to read the secret now. And we'll go through the flow again of getting the transit key, decrypting the secret, and providing the secret. So it's the man in the middle that is trusted by all the parties. Obviously, if you have application that's still using the sidecar, not still using, but using the sidecar, it still works. There's nothing to change that. So you can have a mixture of everything. The good thing is that if you have an application that doesn't support a sidecar, or any services that would push a key, and when I say services, I mean the Kubernetes services that need to push a key to etcd, all those secrets will be safe now, not just coded in base 64. So lots of words, and I think it's fair to say that there's a lot of show and tell, and I think in this moment where we need to show versus tell. And to do that, there's a demo. It's 2 VMs on DigitalOcean. It's running CentOS stream, and don't put any questions around CentOS or whatever. I will not answer that. And then using RKE2, so the Rancher Kubernetes Engine 2, don't ask questions around this also. Actually, the reason why I'm using this is because it's super lightweight. It's 2 commands to deploy it, and I don't need any of the nice super features that OpenShift would provide you with. And so having RKE2 here is just having the bare minimal and nothing else, just to push secrets. And everything is going to be using an instance of HashiCorp Vault on their cloud service. It's an enterprise version. And let's see how it works. All right. So I just need to have a console here. I might make it bigger and maybe a bit more like this. So I have, as I said, I have 2 nodes. One node is the control plane. The other node is a worker. I'm not really going to use it. And then if I look at the pods that are running here, I have a couple of pods. I've been playing around with this, so that's great. We have a couple of restarts and stuff, so don't worry too much about it. And then as you can see, we have one of our nice friends here, the Trousseau, being deployed. The reason why we have Vault-KMS provider, it's because we took the naming convention of having the KMS name first, and then mentioning it's a KMS provider behind it. So Trousseau will not show off as per se, but at least you know what kind of KMS you're going to be using. If we do, let's say, a get all, that might be interesting. So that you can see that we have, as I was mentioning, a daemon set. So daemon set meaning that from a definition perspective, everywhere there is an API manager, or actually a control plane node will deploy. In this case, we have 1, so we'll deploy 1, and that's about it. What do we have as a requirement? The requirement to have Trousseau working is, I'm going to do a var lib rancher, RK2, and then we have server, so that's the control plane. We have a manifest, and the manifest is basically the actual daemon set where we define exactly what it needs to be there to have a vault functioning. So as you can imagine, if we have the enterprise version and so on, you will have the concept of vault namespace here. And then you have to define which namespace is going to be used. In our case, we're just using the admin one. And that's it. If you have a test environment and you want to do some stuff in the unsafe approach, you can skip the verify for the self-signed certificate, and it's going to work there. Apart from that, nothing too much, nothing too fancy. We have also a health check, and we have Prometheus endpoint, and we have Grafana dashboard available. This is a toleration that we're discussing, affinity and toleration, to make sure that we are running on the control plane. So that's the manifest. In this case, it's going to be when you deploy RK, it's going to be picked up automatically and deployed. And then we have a second thing, which is basically telling the API manager that we're going to be using the provider in order to encrypt secrets. And in this case, you can see that we have a KMS definition, and we give it a name, and we give it an endpoint. That's about it. There's a cache size also. We can play with the cache depending on the CISO requirement in terms of how long you want to keep the transit key in place. And that's about it. There's another configuration file which is in rancher vaults, and then config file. This is the config file where you point to the vault and a token. The token needs to be only for that specific element of the transit key. And we are defining transit key, which is the vault-kms demo here at this point. We'll discuss about that later for that construct. If I want to create now, one thing also, if you want to verify that everything is working properly, you would do a vault like here, and then you can see that the vault is running, obviously, and then you have the API server, which is using the vault KMS encryption configuration file. So that's something interesting. So if I want to create secrets now, I would be creating a secret with the command here instead of using a file. So I'm creating a generic secret in the default namespace with the key value being my key, my data. In this case, you can see that if I do a query towards the etcd running on the cluster, there is definitely something interesting here. I'm getting a dump of the secret directly, and I'm grabbing on the encoding. And the encoding shows that it has been encoded with the KMS version 1, and it's using the vault. And you have a beginning of the actual encoding there. So that's the idea of it. So at that stage, looking at the secret will not help you to have any data of it. The data that we have, if I was to take this and grab on my data, you will not have anything. You can do my key too. You will not have anything. You will not find anything for that secret because the payload is fully encrypted. So that's the purpose of it. Now, if we go back to modifying the actual, that's not the one. Sorry for that. Actually, it should be the one. Yeah. If I do, let's say, I remove this, and I'm really making this like this. So I remove the concept of the KMS, and then I restart the AKG server. Sorry. So now what happens is that we remove the concept of the KMS from the API manager. So the API manager doesn't know about the KMS anymore. And I run the show we found. So in this stage, as you can see that there's no more, oh, it's interesting. Interesting. Demo moment. Can I do a kubectl get pod? Yeah, I think it's just, yeah, okay. So if I do create a new, it was just the time for the API manager to restart. I was too fast apparently. So if I create a second secret and I look into the etcd now, that doesn't refer to anything else than the etcd with the encoding, basically the base64 encoding. Then if I read the actual data out of the etcd, you can see that graphing on my data give now an answer. So the actual payload, my key, my data, is showing up in the dump. So there's no encryption. So anyone can read actually the key value I put for my secret number 2. The interesting thing is about the secret 1. Secret 1 has been encrypted. It was not replaced. It was not touched. We removed the access to the actual KMS, so we don't have the ability to unencrypt this. But the secret is still there. You can still have access to the secret. It's still encoded. It's still in the etcd, but you will not be able to get the payload out of it. So that's the thing about it. So losing the access to the KMS for a while doesn't mean that you lose the secret itself. You lose the ability to decrypt the secret, but the secret is still in the etcd. Yeah, so very simple. Nothing much more to share actually, because that's it. And you will be using plain Kubernetes API subset API objects to deal with your secrets. No need to have a third-party CLI anymore. Just mention of it. I was showing a couple of things here. So if you want to dig in a bit more about how to deploy, there's a wiki for the GitHub project, the GitHub repo, where you can have all the details how to recreate this demo and enjoy it. All right, so let's go back to the slides to finish our presentation. So I hope that this the presentation, but also the demo, showed you how simple it can be to provide an easy access to securing your secrets the Kubernetes native way. And this has been possible because of sponsors and volunteers. And I want to give a shout out to you on that. I've been working there for a good amount of time, and the team is really in love with open source. And I had the chance to get almost a full-time dedication to open source there, and building the Trucer project from underground and have something that is used actually in production. Today, version 1 is production grade and is being used at customer in a government environment with on that. We deployed it and so on. So shout out to the team, shout out to Alex, the CEO, James, the head of product, and my former manager and mentor, Richard Oliver, who really helped me to build this fantastic project. Also, some folks, a contributor from a third-party company, TSH, not to name them, very bright people there helping in the coding and fixing bugs along the path. And also shout out to HashiCorp, because when you build a project, it's not always easy to, especially when it comes to integration, it's not always easy to get the third party involved in your integration and have some guidance. And HashiCorp has been very nice with us. They were interested. They come up and wanted to have a demo, and we show them how it's working. They give us some tips and guidance. And actually, this is how the open source community is working. It's the fantastic ability to contribute all together to something that is great and that help solve issues for a larger audience. This is sharing the love, and I'm really excited about this. Speaking of which, on all those guidance from a Vault perspective, what's next? We started with Vault as a first KMS because we needed to start somewhere, and this is also one of the most popular KMS on the industry when it comes to Kubernetes, but also I would say password management and so on. So we could implement one of the guidance that they gave us, which is the sidecar implementation. So if you remember in the diagram, for the pods, for the applications, you have the ability to have sidecar. So we want to remove that configuration file that you saw with the token and the link to the KMS servers. So by implementing the sidecar, we'll have a fully closed loop without any external setting to be accessed by the Trousseau container. So that's going to be fantastic. That would be a fully closed loop where everything is trusted and your secret will be in a very nicely encrypted payload on your Kubernetes cluster. The second thing that we're going to build, and I say second thing because I said two features, and actually there's three in there, but two and three are linked together. It's building a boiler template for a new KMS to be integrated. So there's a good amount of different KMS in the wild, and we want to offer everyone the ability to integrate with their existing KMS in their environment. We found the need to go through any other integrations. And so to do so, we're going to elect one new KMS. And you can put on the platform which KMS you would love to see being implemented, and we'll be using that implementation to create a KMS boiler template to ease the development and the integration of any future KMS. Obviously, that's going to be depending if there's a sidecar or not, and we want to make that generic enough so that every type of KMS can be integrated. That's what we're looking for the next release. And well, it's call of attraction for sure. If you want to participate, and it could be in writing documentation, fixing documentation, could be about giving feedbacks about features and concerns and comments, your experience with KMS and Kubernetes and secrets, or if you want to contribute from at the code level, well, your forks are definitely welcome, and your PRs are more than even welcome. So that's for sure. We want the community to embrace this project with your love, and also with any comments that help the project to be better, and also to integrate with more KMS in an easy way, but also in a production grade, something that everyone can use, both for their tinkering, but also in a real environment where you have production running. The last thing I want to say is stay safe, like your secrets. And I hope you enjoyed the talk. Back to you for any questions and concerns. Thank you for showing up at FOSDEM and showing up for the security track. Hi everyone. Joining you from the car. I'm currently commuting back and forth between countries. So if you have any question, I'm there. As you can see, I was chatting with some of you on the security room. So just shoot your questions if you have more than the one we had the pleasure to discuss about on the security room in the security room. Oh, and for security, I always have a big Akira with me, so it's always helping. So I see one question here. So let's see. I'm not sure you covered it, but how is your own application handling and decrypting the encrypted secret? Oh, okay. So it's a transaction based, so meaning that we don't store anything in the KMS. So the only thing we will do is basically take the transit key out of the KMS and do the encryption and decryption. So in the flow, when there's a request from the API manager is forwarding that request towards Truso, and Truso would look into accessing the KMS via API. So if you look at the repo, you will see that everything we do is based on Go libs from the KMS provider, and so we fetch that uh, transit key via an API request towards that KMS, and from there we do the encryption on the decryption, and that's related to the cache that we were discussing about the memory print. We can keep that transit key for a while in the cache for heavy workload on the cluster. And if you don't want to have that and ensure that there's no potential attack surface of attack on the memory side, you can reduce it to 0. There's another question here. So how does this integrate with the RBAC model? And what does the audit log look like at the KVM level? So that's a very good question. So from an RBAC model, we integrate fully with the one from Kubernetes, so we don't have any specific one. And because we're using plain native Kubernetes APIs, so that's where you would define the actual model. It's on the Kubernetes side. Say, from a secret object perspective, I'm okay to have someone reading the payload, or having someone being able to create, delete, or replace a secret. If you go on the slides, there's a link there, and you can follow the link. It's basically forwarding you to the Kubernetes best practices for this, and you can follow that there. From an audit perspective, you have 2 level of audits. We provide Prometheus endpoints, so you can track all the different transactions there, but also because it's plain Kubernetes API, you will see that within your audit log of the Kubernetes cluster. And from the KVM perspective, you will see the originator, and you will see a transaction ID linked to the transit key. I hope it's answering the question. And then just see, okay. Bum, 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 bum. Nice project. How is Truso different from Kubernetes external secrets? It's quite similar. As a matter of fact, the idea of this project is very similar to what external secret does. The only difference is that
Good afternoon. Welcome to FOSDEM. My name is Alon Miroinek, and I work at Synopsys, where I manage R&D for the Seeker agents. But as fascinating as that may be, it's just not my topic today. So this is the last time I'm going to mention Seeker. Instead, I want to talk about my career before joining Synopsys. So before joining Synopsys, I did not work on security at all. In retrospect, you could say I worked on what we now call infra types of tasks: storage, databases, software libraries that other quote-unquote application engineers could use. But even though I didn't work on security, security was always kind of in the back of my mind. I kind of always knew I had to think about security, but I wasn't really equipped to do that. For me, back in the day, security was this mythical, magical thing that you have to be some super hacker to understand, and us mere mortals just can't deal with it. In retrospect, I think that is really the wrong approach. I think every programmer, every software engineer should at least know something about security and not treat us as this mythical entity that they cannot tame. So today I want to share some misconceptions I had at the beginning of my career, some myths I may have believed, and demystify them, and try and share what I think every developer should know about security. So before we dive into it, some of you may ask, why do I even need to know this? I mean, we have CISOs, they install and they maintain our firewall and our WAF and our RASP and whatever dollar-cool technology you want to put in here. Why do I need to know anything about security? I just develop applications. Well, I disagree with this statement. I think we should look at firewalls and WAFs and RASPs and whatever, a bit like we look at seatbelts. Seatbelts are great. Seatbelts save lives. And whenever you get into a car, you should put on your seatbelt, obviously. But the fact that you have a seatbelt doesn't mean that you drive carelessly or recklessly because you trust your seatbelt, right? Security should be the same. Firewalls and WAFs and RASPs and what have you are great pieces of technology and you should definitely use them. But this doesn't mean you need to ignore all common sense and wait for your RASP or WAF to save you. You need to design and build your systems in a secure way from the bottom up. And then wherever there are edge cases or things you didn't think about, your WAFs and your RASPs and what have you may save you. But don't shut off your brain and don't ignore common sense just because you have some fancy shiny tool. So what do we mere mortals, what do we non-security experts need to know about security? First of all, the first step in my mind is to alter our perception of security. Software engineers, at least in my experience, tend to have extreme opinions on many topics, including, but not limited to, their perception of themselves, which may cause quite a bit of problems. So when thinking about security, I've seen two very common extremes in software engineers. One extreme is the engineer who knows everything. He's super smart and security isn't that complicated. So to him, security is simple. He just knows everything. And because he or she, of course, sorry, because this engineer knows everything, they cannot be taught anything. Spoiler alert, security isn't always as simple. And by refusing to learn, you will have gaps in your knowledge and you will make mistakes. The other extreme, of course, is the engineer who buys into this hype and is sure that security is something mystical and complicated, and because it's so out there, they cannot know anything or do not know anything. And because they know nothing, they cannot be taught anything because they are sure this is so complicated that they have locked themselves out of the ability to learn. Now, you may think that this extreme is better than the other extreme because at least this engineer doesn't just assume they know everything and make bad decisions. But in our world, it just is not good enough. In our world, if we deploy to production twice a day, we're moving too slowly. And if our engineers cannot or will not make any security conscious decisions, and if every decision needs to be a point where you stop and call in a quote unquote expert, or better yet, an expert without the quotes, you just can't move in any reasonable pace. So what we want to do, where we want to be, is we want to strike a balance. We want to get to the point where the engineers who aren't security experts are at least aware of security, are able to make informed decisions, are able to take security considerations into mind when they build their systems, but are aware enough and are knowledgeable enough to know where their knowledge has limits, to know that when they get to a certain point, they can raise their hand and say, wait a minute, this is a bit outside of my areas of expertise. This is some specific use case where I really need some advice. I need to call in someone with a bit more experience, a bit more expertise, because this is out of my scope. And by that, we want to get to a stage where we can move at a reasonable pace, but not ignore security completely and not move in a reckless pace where security is not an issue because we never thought about it properly. Another problem of perception that a lot of engineers have is this purism or perfectionism. For a lot of engineers, and I have to admit that sometimes I make this mistake too, we strive to build the perfect system, which in its own right is not necessarily a problem. But when you take this to the extreme, it irks us, it viscerally hurts us if we can't build a perfect system. And in a lot of cases, this devolves to some dichotomy where if it can't be perfect, better not do this at all, which is usually a bad engineering practice. When it comes to security, it's definitely a bad practice. So I like to think about information security a lot like I think about physical security. So, for example, my brother-in-law is a locksmith. And when we bought our house, we had a housewarming party and invited all our friends and family. And I had my brother-in-law take a look at my front door. And I examined it and say, okay, just so you know, I can break into here in about 10 minutes of work. If I don't care about leaving evidence, don't care about the noise, don't care about the mess, I can do this in 5 minutes. So it's clear to me, my home is not perfectly secure. Someone with the right tools, with the right expertise, can definitely break into it. This doesn't mean I give up completely, leave my front door open and put up a big sign, "Dear robbers, please take my stuff." Of course not. I lock my door, I have a deadbolt, I have bars on the large windows. I've hopefully done enough to deter most robbers. And we've lived here for about 9 years and we never had a break-in, so presumably this works. Can I do something better? Of course I can. I can theoretically pay an armed guard to stand outside my door 24/7. Can this be done? Sure. Is it worth it? No. Will this be perfect? It won't. Even with a guard outside my door, a commando strike team would be able to disable or, God forbid, kill this guard and break in. This is all in the realm of possibility, but probably not the realm of probability, if you'll excuse that weird sentence structure. So it's great to aspire to build the perfect system, but let's check ourselves. We probably won't be able to. Someone with enough determination, enough resources, the time to invest, will eventually be able to break in. But the fact we can't build a perfectly safe system doesn't mean we don't need to try or don't need to think about security at all. We need to build our system to be safe enough. We need to make it so the average attacker either won't be able to break in because they're not skillful enough, excuse me, or it won't be worth their time or effort because it would take too long for too small payout. And the more we invest in this, the more attackers we keep out, the more secure our system would be. And for every system, we need to find the, again, balancing act where we can continue hardening it, but it's not worth the effort, not worth the time we're devoting to it, not worth maybe the trade-offs, because having a system so secure creates a horrible user experience. The fact that it isn't perfect does not mean it is not secure. It means we thought about security, it means we took this into consideration, and we decided where we want to stop. So now, how do I actually do this? What does your average, or I won't say average, we're all excellent developers, what does your non-security focused developer need to know about security? What do they have to have in mind when they're designing their system? Well, first of all, we need to think who really uses our system. For a lot of us developers, we are at heart builders. We look at the world around us, we see that it is imperfect, and we ask ourselves, how can we make this better? And then we go out and we build stuff to make the world around us a little bit better. We solve a problem, we cater to a need, we see something going on and we ask ourselves, how can we make this a little bit smoother, a little bit faster, a little bit more accessible? And we build our systems to do that, which is great. The problem is that when you have some perception of the world that is so ingrained in your being, when you have a perception of yourself and your part in the world, which is so fundamental to how you do your job or even to who you are, you start thinking that this belief or this perception is universal, that everyone thinks or acts like this. Psychologists call this the false consensus bias. Operative word being false. Not everyone is like that. There are bad people in the world. We build our systems and we ask ourselves, how will a reasonable person use the system? How will a reasonable user benefit from it? What is the system trying to solve, and who is it trying to solve this issue for? Those are not the only people out there. There are bad people, attackers, hackers, if you must, which are unreasonable users, which have no intent in using the system the way it was designed or for the purpose it was designed to solve. There are people, who are, in our definition, unreasonable, who want to abuse the system, who want to not think about how it's supposed to work, but how it actually works, what actually can be done, and what benefit they can gain from it. Even if this means bringing the system down, harming other users, or anything else. And we need to think about these use cases when we design our systems. Not in the sense that we need to cater to them, not in the sense where you build a system and you need to have a big red button that says, steal all my data, dear hacker. Of course not. But we have to be aware that these use cases exist. We have to be aware that these people exist and build our systems with them in mind to defend against them, to defend against these illegitimate use cases. What does this actually mean, though? What should we be doing? First of all, and I know this is kind of counter-instinctive to a lot of engineers, unfortunately, especially in the early stages of our career, don't reinvent the wheel. There's a huge wealth of security literature there and implementations for a lot of security-centric flows, such as authentication and authorization, RBAC, cryptography. Don't reinvent the wheel. If you think you have invented or reinvented a better wheel, and you are not a security expert or security-focused developer, take a minute, pause, consult with a couple of experts. If this really is a better wheel, congratulations, here's your startup. Let me know about this, maybe I'd like to invest in it. If it isn't, don't reinvent the wheel. On a more serious note, for a lot of us, security is, of course, critical, but it isn't the core of our business. If your business is not security, don't put effort in it where it doesn't deserve it. You, of course, need good authentication. You need good authorization. You need good cryptography. Don't invest in reinventing them. There's a world of good implementations out there. Do your homework, find the one that fits. If it needs some tweaking, chances are there's a reasonable way of doing this via configuration or whatever. And just use the wheel that someone else invented for you. This is exactly why they are out there. Another misconception, which I unfortunately see a lot, is security by obscurity. This essentially means that, and excuse the cynicism, as a developer, I'm sure I'm smarter than everyone else, so I can hide my vulnerable parts, and I'll build a system that is so different and so complicated that an attacker won't be able to attack it. Thus, excuse the spoiler, doesn't work, or at least obscurity by itself does not work. What does this mean? For instance, obscurity could be that my application, www.alonmorenik.com, has an admin panel. Security by obscurity means that my admin panel in /admin is not listed in my sitemap and no one will know it's there. This is bad security. This is insufficient. There are plenty of tools, scanners, whatever, that will pick this up. And if my entire security proposition lies on my belief that no one will find my admin panel, I'm going to have a bad day. Now, if this admin panel is properly secured, it's protected by a username password, which aren't default, and the the communication is encrypted. It's done over HTTPS and not HTTP. And perhaps I don't even use username password. I use something stronger like 2FA or MFA. Adding another layer of obscurity where I don't publish the fact that I have a /admin page won't hurt. It will make it a tad more secure and maybe block another 1 or 2 attackers. This is great. I'm not against obscurity. But we cannot rely on obscurity as a security strategy. Obscurity essentially means that you hope no one will figure this out. This implicitly assumes that you're smarter than everyone else. I can understand why a lot of programmers think that, and everyone here is obviously very smart, but let's not assume that everyone else is not as smart. So don't rely on obscurity by itself. Another thing that we should consider is that our code, your code, my code, everyone's code, is usually just the tip of the iceberg. I probably don't need to say this here at FOSDEM, but in a typical system, there's not that much of our own code, our own business logic. And a lot of the things that aren't our core business logic are handled by third party, usually open source libraries and frameworks. For instance, logging. Have you ever implemented a logger? Some of you may have, I have. Do you usually implement loggers? Probably not. Probably use some open source library to do this. Database handling, querying. Chances are you use another ORM to handle this. And even if you write your own queries, chances are you do not write your own database or database drivers. There's no reason to create third parties for this. Web rendering frameworks, etc., etc. If you take a look at your application as a whole, at the entire code base that's required to create it, your own business logic may be the most important part of it, but at least numerically speaking, it's probably the smallest part there. Unfortunately, the people who write these libraries and frameworks and open source projects are mere mortals like you and I. They put on their pants one leg at a time. Just because something is a famous open source project doesn't mean we can or should indeed assume it's vulnerability free and entirely secure. Moreover, a lot of us, or I don't know if a lot, but at least some of us aren't even aware of all these libraries we use, because we know what we require, but we quite often have transitive dependencies, and these dependencies have their own transitive dependencies, and so on and so forth. So before we start talking about our own code, are we able to understand how our application is built? Are we able to map out, all these dependencies? Are we able, if a vulnerability is disclosed on them, upgrade these dependencies without it being a crisis? This means having a policy in place. Right? Sometimes we upgrade to the latest stable version as soon as it comes out. This is a fair strategy. Some projects we prefer not to touch dependencies until we have to, until a CVE is disclosed. This is also fair enough. But the important thing is to think about this, is to have a strategy and to test the strategy, to be sure that we can perform this upgrade and can be fairly certain that we did not break our application by performing this upgrade. This means having usually automated tests in place. So again, this does not mean that every 5 minutes we need to test for later releases and jump to them. It does mean we need to be able to do this on our own terms in some reasonable fashion without having to scramble around and yell crisis if a CV is disclosed. So, up until now, we've discussed some general ideas, some thought processes we should all have, and some handling of our application as a whole. Now, let's look at the tip of the iceberg. Let's look at our own code and ask what we should be doing there, or what we maybe shouldn't be doing there. So, the cardinal rule of security. We do not trust user input. Rule number 2, we never trust user input. Rule number 3, see rules number 1 and 2. The programmers out here will ask, why the hell are your rules numbered 1, 2, and 3? Us programmers start at 0. So, of course, you're right. Rule number 0, we do not trust user input. A system, theoretically, that has no user input, no way to interact with it whatsoever, it's running on its own on a computer with no connections to the external world. This computer is closed in a safe, and this safe is on a submarine, will probably be safe. Most of us don't build systems like this. Most of us build systems that do interact with the outside world, be it actual human users, where we have a form and a user needs to type in their details, or some other third-party API or microservice or macro service or whatever. Most systems have interaction points outside of them. They get data inputted into them and they produce results. Now, again, as a general rule, any data that comes in, we should consider as untrusted. The thought here is that if a user can input valid data, an attacker can input invalid data. An attacker can input something which has absolutely no legitimate use case and is only designed to cause harm or to break my system. These are all the SQL injection attacks or any other injection attack, cross-site scripting, all of these. So wherever we have data coming in and whenever we have a concern that this data may not be legitimate. For example, it is not coming from some server we had to authenticate against and we encrypt the communication, etc. Whenever we have untrusted data coming in, which in my mind is most, if not all data, check it, validate it, verify it. And once you've done doing that, sanitize it. Clear out anything that's not a legitimate input. And again, going back a couple of slides, don't reinvent the wheel. Look at your system, get to know the data paths, get to know where this data is used, and read up about this use case. Chances are your system isn't the only system that saves data to a database, writes it to a file, concatenates it somewhere and uses it to query LDAP. These are all common use cases. And for most, if not all, common use cases, in most, if not all, ecosystems, you'll have guides for best practices on how to use user input safely, and you'll have libraries to verify or validate or sanitize this input. Do your homework, find what fits you, and use it. Saying that, I do think I need to stress that when building a system, we aren't only responsible for our own safety, we're responsible for the safety of the users who use the system, or at least their data. A lot of these attacks based on tainted input are meant not just or not only to break the system, but to gain access to data that they should not have access to other users' data. So while you may say, okay, I don't care if someone tampers with a screen and sees all the data, it won't bring my system down, it is still your responsibility. If not legally in a lot of cases, at the very least in the court of public opinion. Because if your system doesn't protect my details, such as my credit card number, I just won't use it. As part of the same notion, if we talked about the content of user input, let's talk about the size or the scale of user input. As developers, we've become very good at scaling our systems. We've become very good at handling load. Usually, this is done as a positive thing, right? We're getting more users, our business is growing, they're using the system more often for more use cases, which is great. Let's cater to this. Let's increase the scale. Let's scale up. Let's scale out. This is all fantastic. But in the security perspective, there's another type of scale we need to think about. One of the easiest ways to bring a system down isn't to intelligently break into it and abuse something. It's just to hammer it with too many requests, which are too large, and handling all these requests consumes too much resources, too much memory, too much CPU time, network bandwidth, what have you, that the system just is not able to serve legitimate requests. This category is called denial of service or DOS attacks. As security conscious engineers, we need to think about these use cases too. The way we do this is pretty similar to what I've mentioned so far. In a nutshell, get to know your system. For every vector that you have data coming in, think about it. Familiarize yourself with this data and get a notion of what a legitimate request could or should look like. Now that you have this idea in mind, well, our toolbox as developers is full of ways to handle these. rate limits, size caps, throttling. We know how to do this. But the key point is getting to know your data and getting to know what a legitimate request is. For example, this is something I've seen at a customer a couple of months or years ago. So they had a login form where you input your username and password. And these details were serialized as JSON, sent to the server that parsed them, checked if the username and password combination was valid, and returned a session cookie or a 401. Now, let's say my username is up to 8 characters. My password, since I'm a security conscious developer, can be up to 20 characters. Together, this is 28. Maybe a bit of overhead for the JSON. Let's take a bit of a buffer. Let's say 40 bytes of legitimate input. In such a form, with such a server behind it, is there any legitimate use case to send a megabyte of JSON to the server? Of course not. But if you do, and you don't explicitly defend against this, the server will get a megabyte of JSON. It will parse it, which may be a CPU or memory intensive operation, and only then return the 401. You can easily think how a system like that can be very vulnerable to denial of service. A better approach would be to receive the request, just check the size, return an error if it's more than 40 bytes, and not even try to parse this huge JSON. This is what I mean by scaling and thinking about scale. So I think I'm nearing the end of my time, so I want to wrap it up. If nothing else sticks with you from this entire presentation, the one thing I want you to remember is that boring should be good. Boring is good. We often in mainstream media, even in technical media, we sensationalize security and we mystify security. And we read about this 0-day discovered by this elite hacktivist group that leaked all the data from insurance company XYZ and big tech ABC. This happens. Most vulnerabilities aren't these crazy 0 days. Most vulnerabilities are simple and boring, and our treatment of security should be to make it boring again. We need to remove this mysticism around it and treat it as just another thing that every developer needs to know and every developer needs to handle. Because if we don't make it boring, it will be sensational in the sense of your company in the front page with a story about it leaking its customers' data. How do we make it boring? We tool it away. And I'm not going to advocate for any specific tool. This is not a sales pitch. Do your homework, find the tool or tools that fit into your process, that fit into your CI pipeline, and integrate them. Make security vulnerabilities something as boring as a bug or failed unit test. The other way we make it boring, and again, I don't really need to say this in FOSDEM, is we leverage the community. We make it very easy for people to report security vulnerabilities. Have a very visible email address. Have this address in your company domain, not michaelscott1234@hotmail.com, true story, and have someone monitor it. And when someone does report a vulnerability, be polite, thank them, and address it. Don't have your lawyers answer with a cease and desist order. Also, true story. If you do all of these, and nothing of this is complicated, if you do these simple steps, you will make security boring and you will prevent your company from being another sensational security story. With that, I'm really out of time. If there are any questions, I'll happily address them after the recording. And until then, I just want to say thank you for your time. Thank you for listening. Have a great conference.
I am waiting for any question that might show up, but until now I cannot see any. So let's give some time to the attendees to raise their questions if there is any. In any case, I would like to take the opportunity to thank you, Alon, for this great talk and presentation. Let's give them a couple of seconds to see if any question show up.
Okay, so while we're waiting, I'll just take a couple of minutes. First, to thank everyone that attended. Thank you for listening. Hope you enjoyed it. And thank you, FOSDEM, for having me. Okay, so I see we have a question from Stefano, not sure how to pronounce this. Any tips on how to change the dev mindset around security? So we have a question from Stefano. Excuse me. I'm hearing a bit of feedback here. Sorry about that. So first and foremost, I think we need to meet developers where they are. Security shouldn't be something external to development. We should meet them in the CI process. If possible, we should meet them in the IDE process. And we should bring the developers into the family. We should, when it becomes part of their process, when you have CI, for instance, failing for security in the same way it's failing for for functional test, it's their world and it becomes part of their responsibility. We have another question from Yamabiko. Are external security audits worth it? How should they be done? Well, I have about 15 seconds before the feed goes off, so I'll answer by text afterwards. With that, I just want to say again, thank you for having me. Thank you for listening and enjoy the conference.
Good day, everyone. Wonderful to be speaking to you today at FOSDEM. Unfortunately, again, online instead of in person, but eventually we'll be back to Brussels. My name is Bruce Momjian. I am one of the Postgres core team members and an employee of Enterprise DB for the past 15 years. I am going to be talking to you today about TLS, more commonly referred to as SSL, if you're my age. And we're going to be talking about all aspects of TLS SSL, including what it's trying to accomplish, how it does it, how it's configured, how browsers use it, how use it, how Postgres uses it, pretty much all the aspects in 78 slides. This slide deck is actually part of a larger set of security slides that make up over 300 slides on my website. So if you'd like to look at these slides or the other 3 security presentations that I have, or any of the 54, 55 Postgres talks that I have, please go to this URL right here, and you'll be able to review those pretty well. This is not a light talk. We're going to be a lot of complicated topics here and complicated issues to discover. But my goal is that when you're done going through this, you'll have a better understanding of what TLS is actually accomplishing and how it is accomplishing it, and how you can make it so that it accomplishes it for your project in a better way. I find that this is a kind of a complicated topic. I, about 6 years ago, started studying this, read a bunch of books, wrote all 300 slides. It's just, it has some unusual concepts, and it has, because it's related to security, it has to do things in certain ways to get those outcomes. And those type of processes that you see in this type of material are really not common things that you would normally do in person, but in the digital world, you have to do this to maintain security. So it's a bit of it doesn't map greatly to sort of common sense sometimes, or to what you can do in the real world that you have to do differently in the digital world. And I'll kind of highlight that as I go through, but hopefully the material going to hold together. Again, there's one slide, a set of slides that's right before this one, which might be the best sort of precursor to this. And I'll talk about it as we go forward, but be aware that there is going to be some assumed knowledge in this material. So what are we going to accomplish? First, why should we care about TLS SSL? What does it do? Okay, what does it accomplish for us? Secondly, we're going to talk about the digital protocol that is TLS SSL. We'll talk about how it's set up, how it uses different encryption methods, how it exchanges keys and so forth, how it uses message authentication codes. And then we'll talk about, in section 3, we'll talk about authentication. This is where we introduce the idea of certificates, certificate authorities. How do certificates validated? How are they used? And I think there's a lot of confusion there sometimes. I'll try and highlight that as we go along. Section 4, how do browsers use certificates, TLS certificates? And finally, how does Postgres as a non-browser app use it, to give you an idea of how a non-browser app would use certificates? And then finally, a conclusion, and of course, your questions at the end. So why should you care? I'm kind of old enough to remember a lot of the challenges in the early years of how to do communication securely without this protocol. How do you exchange keys? How do you make sure the person is who they say they are? How do you prevent invalid messages from being introduced? These are pretty, these are now solved problems, but they weren't always solved. Obviously, interactions are increasingly digital, so there is an increasing need to have this type of secure communication infrastructure available. Attackers are increasingly distant. In the old days, you only really had to secure your location based on who could access your location. So if you're in, I'm in near Philadelphia, I don't have to worry so much about somebody who's in another continent because they're not here, right? So I only have to worry kind of about people who, but in the digital world, somebody from another continent can easily attack my system. So the scope of bad actors who can actually attack is obviously much, much larger in the digital world than it is in the physical world. And that requires more thought about security, I would say. Attackers are increasingly sophisticated. We do have some governments who do this, some sort of companies or groups that do it for hire. Certainly ransomware has become a big issue. I was just reading an article today about NSO, which is a Israeli company that does security tools, sells to governments, allows you to crack into a lot of mobile phones. So again, the sophistication, and you have to keep your game up, because if you don't, then these other more sophisticated people could potentially breach your security. New threats prompts new security requirements. TLS has evolved over the years, and I think it's become a lot better. And of course, security software must regularly be updated to be effective, because as new threats appear, new mitigations are required. Certainly Log4j has taught us that in the past month or two, the problems that you can have there. I'm not going to drill too much in history. This is really talking about modern TLS. So what things is cryptography designed to accomplish? Now, again, I have a previous slide deck, which is called Fundamentals of Modern Cryptography. It's on my website URL there I showed you. And there it goes into, all of the pieces that make up cryptography. But now we're going to put them together. We're going to put in, hashing and encryption and key exchange. We're going to say, what do we want to accomplish here? Okay. Probably three major things. One is authenticity. How do we know that the person on the other end of our communication channel is the person we intend to communicate with? Okay. We're not talking about so much cryptography there as authenticity. How do we know the other person is who they say they are? Secondly, how do we know no one else can read our communications? That's encryption. Okay. And then integrity, how do we know no other party can change the message or add messages into our stream of communication? So those are the big three, and we're going to kind of walk them through. We're going to leave authenticity for a later section. We're going to start really with confidentiality and integrity, and then move in authentication at the end. Okay. But this talk is not enough. This is just a focus on TLS. Of course, there's so many other ways you can be attacked. There's a video here at the bottom, which I think is really entertaining, which talks about a person who hacked into, I think it was an Xbox, and he explained how having the physical control of the device allowed them to bypass the encryption. Anyway, the bottom line is that there's so many other ways that can be attacked that you really have to be aware of all of them to really have effective security. So as I said, we're going to be talking about TLS today. What does that actual secure protocol involve? The first thing it involves is something called negotiating a secret session key. This is done primarily by an algorithm called the Diffie-Hellman algorithm. It was designed, way back, decades back. But you'll see Diffie-Hellman if you look at some of the sort of encryption documentation. It's usually kind of shortened to DH. So, for example, in this case, we have ECDHE, which is elliptic curve Diffie-Hellman exchange, which is basically and again, my previous slide deck has this covered. It explains how two people in a communication channel can come up with a secret key that someone observing the communication between the two individuals cannot derive the same secret key. It's very interesting. Uh, it's quite complicated. Allows a lot of issue with exponents and in that case elliptic curve to sort of to come up with a shared secret that is invisible to somebody looking at the exchange, which of course is a requirement. You can't be sure that your initial exchange, which somebody would not be visible because you haven't exchanged a secret yet, to use encryption with, right? It's kind of the chicken and egg. How do you get that secret so you can then move into a method of using encryption so that your communication is secure. So that's what Diffie-Hellman is. Again, previous slide deck has a lot of details on that. Then you need to encrypt, decrypt blocks of data using a key. In this case, AES 256 is an example. AES 128, AES 192, you see a lot of. You don't see a lot of non-AES. Yes, there are some, but I'm gonna focus on AES in this talk. Most browsers and most sort of commercial communication, because of CPU enhancements, CPU acceleration. AES is a very, very popular way of using encryption. You then need a way of handling variable length messages. That's something called a cipher mode. We'll be talking about that later. That is, again, covered in the previous slide deck. That's called, we're going to example is GCM. Verify that the message was generated by somebody who knows the key, also GCM. Identify that the other party is authentic. That cannot be done with the previous authentication methods. That requires something like RSA or public key encryption. So we'll talk about that going forward. And then also verify that somebody in the middle is not viewing or modifying our messages. That would be also an RSA because you can't have a man in the middle. So again, you have to use multiple features to really accomplish the goal of a secure digital protocol. And it's kind of made up into pieces. TLS version 1.3, it gets a little better with separating out those features and not having all kind of mushed together. But they are separate concepts. TLS was originally named SSL, Secure Socket Layers, developed by Netscape in 1995. Yes, way, way, way back. It was the IETF named a protocol called TLS, which was pretty much synonymous with SSL for many, many years. But the name TLS has been around for quite a while, 22 years at this point. And over time, SSL became kind of out of favor. The last version of SSL was deprecated in 2015. And TLS is now sort of the go-to term. You see SSL just used because people used to SSL certificates a lot. It just kind of gets thrown around, but effectively nobody uses SSL anymore. They're technically using TLS. In fact, the most recent version of TLS is 1.3. Versions 1.0 and 1.1 pretty much were deprecated by browsers about a year ago. But you still see them in the wild. They're still around, particularly in software that hasn't been updated. But most modern systems are now using TLS 1.3, released in August 2018. Again, because we now have browsers that auto-update themselves, you're seeing a lot more adoption of newer protocols, more recent versions of TLS in browsers, which allows those browsers to remain much more current. And again, I have a URL there if you want to kind of walk through how all this happens in more detail. In fact, a lot of these slides have URLs in them, so feel free to come back to the slides and really dig through them and kind of go down in individual slides to see how these pieces work. Unfortunately, in the time allotted, we don't have enough time to go into that much detail. Some of the things have sort of fallen out of favor over time. For example, some of the early uses of encryption used RSA to encrypt the message. or even to encrypt the secret key. And that has fallen out of favor. That's no longer supported by TLS. You have a much more streamlined API for TLS now. And RSA is really now reserved for authentication. And the encryption part and the integrity part is left for a more modern and more efficient method. So RSA seems like a great way. Public key encryption seems like a great way of, for example, exchanging keys. There's some reasons that that's probably not ideal. Particularly, one of the reasons that keys exchange is no longer done with RSA is something called forward secrecy. The concept is that if the private key was of the certificate was to become compromised, could you go back in time and decrypt communications that had been recorded in the past? If you use Diffie-Hellman, that is not a case possible. If you use RSA for the key exchange, it is, and that's why it's now deprecated and no longer used. So basically, to summarize here, we use ephemeral Diffie-Hellman to negotiate a secret between myself and the person on the other end of the communication channel. We then use RSA, public key cryptography, to verify the authenticity of the person on the other end. Typically, what they do is they sign a hash of the actual secret key. So they take a secret, they negotiate a secret key, they private key sign the the secret key. No, well, they private key sign a hash of the, I'm sorry, the hash of the of that exchange that made the secret key, and then that proves that the other person on the other end is literally the person who did the secret key exchange, and also has the private key that goes with the public key. Prevents man-in-the-middle attacks. A client can do the same to validate their authenticity as well. You can use session tickets to allow reuse of parameters from recent sessions. It's not sure how much that's still used. Again, as I said before, TLS 1.3 requires Diffie-Hellman. It no longer allows RSA to be used for key exchange. So you're looking at Diffie-Hellman for the key exchange. You're looking at RSA for the authentication, authenticating users, and authenticating this secret key to guarantee there's no one in the middle making changes. We have AES, which is used for confidentiality. That's the encryption part. And then we use GCM and SHA hashes for integrity of the encrypted blocks. And I'm going to go into details of how that actually works. So let's look at an example. What we have here is an OpenSSL call. So we have an OpenSSL call in red. Okay, so we're typing, this is with OpenSSL 1.1.1K, which is a fairly modern version of OpenSSL. So OpenSSL, there is an option called S client, and I'm connecting to the HTTPS interface on my web server. And one of the lines that come out is this. It says new, meaning a new connection. It says it's TLS 1.3, which is good. And then it spits out this long string here, which most people just glaze over like, oh, what's that? I don't know. What I've done here is to split out that string. The TLS is, of course, the protocol. The AES is the symmetric cipher method that's being used. 256 is the cipher key length. GCM is what we call the cipher mode. And finally, we have a message authentication code hash type of SHA-384. So we're basically combining that all together, and that's that big string. So if you want to run this yourself, or you want to try it on your own server, you can actually see the same string, and now you know what those sort of gobbledygook letters means. Cryptographic standards are evolving. When I originally did this talk a couple years, about 5 years ago, Some systems we were using different versions of TLS, different AES versions, and so forth. Now, pretty much everyone's standardized. Be aware though that you don't always get the maximum encryption. Sometimes the maximum encryption is overkill. AES 128 is certainly fine for browsers. AES 256 typically is recommended when you're looking to avoid quantum attacks, quantum computing attacks. So that doesn't sort of apply, I guess, in a lot of cases. So for example, Firefox 96 and Chrome's 97 prefer AES 128 over 256. And again, you can actually check that URL to see what your browser's preference is. I'm going to sort of prove what I just said. What I did was I opened up Firefox onto my web server, and I basically pulled this up, and it's telling me that the connection is using exactly the similar string here, TLS, AES for encryption, 128-bit key, GCM for verification, integrity, and also SHA-256 for integrity. And it tells me that I'm using TLS 1.3. Okay, so again, that's exactly what I expected to see. If I hop over to Chrome, it gives me a similar string, TLS 1.3. This is sort of has to do with the certificate, I believe, and this is the AES 128 GCM that is being used. Okay. This is sort of a final slide, just to give you a feeling for what's going on here. I'm just talking about a little bit about the speed overhead of different versions of elliptic curve and some of the computation that's necessary. Again, I expect you to understand that what I'm trying to get at here is that as the number of bits increases, you start to get really heavy compute load. So again, just be aware that as you start to get really complicated, it can get kind of expensive to do stuff. But again, you can kind of see. But again, feel free to come back to that. If I do the same thing with Postgres instead of a web browser, I actually see the same thing. I'm basically taking PSQL and connecting to Postgres 14.1 using SSL. And I can see right here, it tells me I'm using TLS 1.3. And here's our same TLS, AES 256 GCM, SHA-384. And again, I can even use an extension called SSL info, which gives me the same information. If I want to get fancy, I could even use some of the Postgres sort of extendable features, and I can break out that string by breaking the string on the underscore and then labeling all of those pieces. So a little geek factor there. So I've talked about the key exchange. I talked about how they get a shared secret to some extent. We talked about AES. We talked about how browsers use it, sort of how that sort of framework is set up. Now we're going to launch into authentication, which is we're going to pretty much cover mostly for the rest of this talk. Authentication is tricky. Again, the encryption part, pretty well understood. Key exchange, Diffie-Hellman, a little complicated. Authentication requires a lot more overhead, a lot more infrastructure, because it's trying to do something like proven identity, which is not something computers are really. The encryption, you just kind of put the number in, it comes out encrypted. That's kind of easy. But authentication kind of requires an infrastructure of identity management. And I'm going to explain how that identity management works, kind of how it fits together with TLS, how browsers use it, how Postgres uses it, and hopefully you'll come away understanding this a lot better. So the primary mechanism used on the internet pretty much universally to prove authentication are certificates. Why is authentication important? Well, of course, if you're sending a password to somebody or you're sending an order or something that you want to remain confidential, you have to make sure the person on the other end is indeed that person, because those of you who know internet protocols, it's very easy to sort of fake a packet or to intersperse a packet or intercept a packet if you understand how the traffic's flowing through the network. So you have to something beyond TCP/IP to really do that type of authentication, and TLS certificates are really that solution. They've gotten a lot easier over time. When I started, you had to find a certificate authority and you had to sort of register with them and do a lot more work. Now, most people are using Let's Encrypt. We'll talk about that as we go. That's automated a lot of this process, but I want to walk through the process so you can actually see what's holding it together, because frankly, Let's Encrypt makes it so easy, you don't really understand what's going on. Why does this work? How does it all fit together? So I'm going to kind of walk through this here. So again, Diffie-Hellman gives us a way of exchanging the secret, but it doesn't prove who you're negotiating with. Is there someone impersonating this participant? Is there somebody viewing, modifying? We have to create a secure connection between the two, but we also have to prove identity. And that's done with something called an X509 certificate, which is the standard ISO name for these TLS certificates, which is typically sort of melded with the RSA public key, private key system to allow for both parties to trust basically this kind of identity across the internet. So let's talk about how we create sort of our identity, and then we're going to talk about how that identity kind of fits into the larger identity that we have out on the internet, because it's kind of not clear sometimes what are we doing here. Okay, so what we typically do is we create an X509 certificate that is signed by a trusted root authority, and that is what allows our certificate to be considered to be proven identity, right? I mean, I could say, I'm Donald Duck or Mickey Mouse, but how do I prove that, right? What these certificate authorities do is to give us a framework where millions, or some cases hundreds of millions of websites can identify themselves, or individuals can identify themselves and prove who they are. So the way that typically happens is you create something called a certificate signing request, or CSR, by answering some questions that uniquely identify you or your website. During that certificate signing request, you also create what's called an RSA key pair, which consists of a public key, which is you can share and is part of the certificate signing request, and a private key, which you do not send outside and you keep private to yourself. So this is, again, part of the magic of public-private keys. The public key is available to anyone who wants it, but the private key is something that you keep undisclosed. And your knowledge of that private key is how you prove who you are. So the public part is sort of your, I guess, half of the key, and you have the other half. And by showing that they fit together without divulging the private key, you prove who you are. You send your certificate to a signing authority, and they typically will sign it and send it back, and then you install it on your web server, for example, to prove that you're trusted. And again, Let's Encrypt does the exact same thing, although in an automated way. So let's kind of visualize what's going on here. You basically are creating a certificate signing request here, which has a public key in it, but a private key exists over here in the server, which you do not send. You have certificate signing information, and you have a server signature. And basically what you do is you take your certificate signing information and you, what we call private key sign it, and you store it into the certificate signing request. And that proves that you know the private key, which matches this public key right here. That's how you prove that you're the right person to send the certificate signing request. Here's the mechanism of it. And again, I have a lot of these slides I don't expect that you'd understand them or even focus on them. I'm giving them to you so you have them as reference to understand how these fit together. So here we're doing an OpenSSL REQ for request, for requesting a CSR, okay, a certificate signing request. We'll fill in a bunch of information about ourselves, what country we're in, our name, and that will create two files. It'll create a key, which is our public and private key, and it creates a CSR, certificate signing request. And if we run this command, we can actually output the certificate signing request. You can see I live in Newtown Square in Pennsylvania. It's for a website, and here's my web address and my email address. So it kind of fills that all in for you. You can actually dump out the entire certificate by using this command, and you can see actually the public key that's part of it, and also the exponent, and then the private key is not in this file. So you'd really only see the public key part because the private key is in that key file. So only the public key again goes out. If you want to generate a key pair on your own, here's how you would do it. I can actually dump out my key pair, and here I can see my private exponent. So here's my public part of my key in blue, and here's the private part in magenta. So the key file has both the public and private key there together. I actually created a tool called RSA dump.sh, which will dump out the mathematics around your key. I'm not going to go into this again. Previous slide explains this, but it basically will show you your exponent, your base, and so forth. And this is how the exponents are computed for the RSA algorithm. And again, here it is in just to give you an idea of how big these numbers are. 1 times 10 to the 308. RSA and this whole certificate thing really has 3 files or 3 types of files. So you should probably be aware of what these are. The key file, you hear the word key and you think, well, is that the public key or the private key? It's actually both. So if you ever see key, it's usually the public and private key together in one file, and that's private, obviously, to you. If you see a file that's called pub, that is the public part of the key. Doesn't contain the private part. And again, that can be shared with anyone. CSR is the public key and the data to be signed, and the CRT is the certificate. Once the CSR has been signed, it becomes a CRT. So the certificate signing request, once signed, becomes a CRT or a signed certificate. And that certificate is signed by a certificate authority, which we're going to go into in a minute. There are some acronyms here with TLS, and again, we're going to get into a whole bunch of details which you may glance over. Actual certificates use a standard called ASN1, which is an abstract hierarchical data structure defined, I believe, by ISO. And there are 2 representations for certificates. One is a DER file, which is a binary representation of typically a certificate, or an ASN1, which is a type of certificate, or a PEM file, which you may have heard of before. A PEM file is a base 64 encoding of DER data. You'll see PEM files a lot. It's basically armored, so you can open it in an editor like a DER file, which you can't. Typical file extensions for these certificates are PEM, key, pub, CSR, CRT, CRL. Talk about what CRL is later. One problem you have, if somebody names a file with extension PEM, it's not really clear what it is. It tells you what the format is, doesn't tell you whether it's a certificate or a key or public key or private public key or a CRL, right? So I'd sort of tell people try and avoid the name PEM, or if you want to use the word PEM, put another extension after it to identify what it really is. PEM is a format, but is it a certificate? Is it a key? That can get a little confusing, at least in my experience. So am I really making this up? Does this actually work? Yes, it does. What I'm going to do in the next couple slides is I'm going to break apart a CSR and kind of prove how when a browser or an SSL session receives a certificate, how does it validate that the certificate was? How does it validate that the person on the other end of the certificate knows the private key of that certificate? That's really the information. Them having the certificate is immaterial. Everyone can have their certificate. I can download certificates of millions of websites if I want to. Having the certificate is not identity, doesn't prove identity. Having the private key that goes with it proves identity. So how does that work in practice? Typically, what happens when you get a CSR or when a CSR is created, you basically find the CSR, you find the hash method, you hash the user supplied parameters that you give, like your name and your website and so forth, the email address. And you extract that and you use the RSA public key to reverse the signature to produce a hash, and then you compare it. And that's how you actually verify the certificate is valid. So let's actually walk through this. So here I have basically my CSR, which is my certificate signing request. And you can see right here the ASN1 notation. You can see it indented, right? So you can understand it's a hierarchical structure. You can see my website and the type of encryption we use and so forth right here. Sorry. Here's the website. Here's the type of encryption we're using. So what typically happens is you take the CSR, you output it in DAR form, you parse it, and then you create a SHA-56 hash of that. And then you look at the hash, and you can see the hash. It begins with F405. So what I've taken the CSR and I've computed it out. Okay, and you can actually see it reversed. We can actually take the CSR and we can parse it directly, and then use a P key verify to verify that the key actually would sign matches the signature, and that's exactly what we get. We get the exact same output. So here we're proving that the CSR is valid because we've used our private key to verify that it does actually allow us to sign this. You could go in another way. Here's two versions of the same thing. Here we're taking the CSR and we're validating against the key and we're outputting the hash. Here we're taking the CSR and we're just outputting it and hashing it directly. And you can see they're exactly the same. So one, we're using the key to verify it. The other one, we're just computing the hash directly, and you can see they verify and they're exactly the same. How would I do that for a website? Well, here's my website certificate. You can see CMOMGen right here. Obviously, this is an expired certificate, but I wanted to show you this because it has some good examples in it. So effectively for my web server, I have a PEM file, right? Which we talked about was not a good idea, but that's what it came in with the name of. Remember, PEM is a format, and turns out it's a certificate. Okay, so I take my certificate and I output the issuer of that certificate. It happens to be RapidSSL. Then I go to RapidSSL and I find the issuer of the RapidSSL certificate. Turns out it's GeoTrust Global Certificate Authority. And then if I ask to see who the signer issuer is of the GeoTrust Global, it actually is themselves. So in every case, as you walk up the certificate authority, you're eventually going to get to what we call a root certificate. And a root certificate is effectively something that's self-signed. Right. So here we are. We're verifying that this momgen.pem can be validated against these two certificates. It says okay. We can here verify that RapidSSL can be verified against the global GeoTrust Global, which is okay. And then we can also say GeoTrust Global is verified against itself, which is a root certificate. That's okay too. We can play with verification a little bit. If we don't supply all the certificates, we don't get verification. Again, if we supply Rapid SSL and GeoTrust Global, we can validate our PEM. But if we only supply ourselves, like I'm trying to validate myself against myself, that'll fail. If I try and invalidate myself against GeoTrust Global, that also won't work. So what I'm trying to do is I'm trying to validate GeoTrust Global against nothing. But I'll get it okay because it's a self-signed certificate. It's like it validates because there is no signer of that. So rules of certificate verification. I'm not going to go into this, but again, you walk through the process. You receive your certificate. You validate that matches the private key. The server has the private key somehow. They prove that, and then you walk up the chain to find a certificate that you trust that's part of that chain. And if you can't find it, then the certificate's invalid. Somebody can present a certificate, but unless it chains up, it's signed by one or more certificate authorities that eventually you trust, you can't trust it. And that's that chain of trust is the way it works. Okay. And again, the topmost is a root certificate. Okay. This is instructions on installing certificates in Apache. Again, pretty straightforward. If you want to introspect a certificate bundle here, here I'm actually taking and I'm creating my certificate and I'm concatenating with another one, which I can then dump out and validate my certificate. So I'm creating two certificates together because I need to create to include an intermediate certificate with my certificate because I don't know the intermediate is going to be on everyone's computer. So sometimes, depending on who you're using for certificate authority, you may need to supply their certificates as part of your certificate so that the chain is connected. You might not have enough on its own to connect. You might need to supply it. How do you create a certificate authority? It's pretty straightforward. You sign, and I have a blog entry here to explain it, but you basically sign your own certificate. So this is the way visually we do it. We have up here a root certificate signed by itself. We have an intermediate certificate, which is signed by this root. And then we have what we call a leaf certificate or an end certificate, which is signed by an intermediate. The root doesn't need to sign the leaf certificate. It just needs to have a chain that we can trust going all the way down. How do you create a root certificate authority? Very easy. You basically sign yourself, right? You just sign yourself. And then you create a CSR and you sign. Here I am signing my own certificate with my own key. And you also need to create an indicator that it is indeed a certificate authority. You have to use that special extension flag when using OpenSSL to do this. Then that causes the certificate to mark as CA true, meaning that a certificate is identified as certificate authority. Then we can create an intermediate certificate signed by my root certificate. And this is the way that would look. I'm now signing. Here is my certificate authority, and I've got my server key, and I'm now using a root certificate to sign this certificate authority to say this is a trusted certificate by this root down there. Okay. Again, using ASN1, we can actually prove this out. You can see the pieces there. We can verify the hash like we did before, that they match. You see 9B7. That is the exact hash. We can do the same process we had before where we reversed out the two of them. We took the root, we computed the ASN1 hash on its own, and secondly, we took the hash that they gave us and we validated against the public key to verify that indeed that hash was signed by somebody who knew the private key. That's how you know that that's a valid certificate. It prevents any tampering. How do you create a leaf certificate, one at the end? Well, you basically just create a certificate signing request, and then you sign it by someone. In this case, I know the certificate intermediate key, private key, so I use that to sign it. If I didn't have that, If I didn't know the private key of the intermediate, I would have to send it to somebody and they would have to do it for me and then send it back. So that's typically the way it works. You typically don't sign your own. You typically have to send it to somebody, they do it for you, or use Let's Encrypt and that's all automated. Again, same certificate authority, the root's at the top, one or more intermediates in the middle, and then the leafs are at the end. There's a couple of different hierarchies you can use or structures for this. Here we have a root certificate, and the root certificate is directly signing the client, the server certificate, and the client certificate. I don't recommend this hierarchy. I recommend something that has an intermediate so that you can replace the intermediate occasionally without having to rekey everything. I'll show you how that works, but effectively, by having an intermediate, you can replace the keys much more easily than having them signed directly by a root. There's another architecture where the server certificate may be signed by the root, but you decide that all the clients are going to be signed by intermediates. That's also possible. It's also possible to do this. We have two intermediates, an intermediate for the servers and an intermediate for the clients. Either one would work fine. So how do you create your own root certificate? Why would you want to do that? There are cases, for example, when you're using Postgres where root certificates, your own root certificate is actually preferable. You basically sign your own key, you create an intermediate CA, you transfer the root's private key to offline storage. So your root certificate just goes off into a USB key or something sitting in a bank. And then from there on, you just use the intermediate keys to sign things. And that way, if you want to change your intermediate, you just need to go back to the bank, recreate a new intermediate, and then take it back to the bank again, and then your intermediate can stay. So it gives you sort of that extra level of indirection so you can replace the intermediate a lot more easily. Again, there's a nice article there that explains why this is important. There's also something called a certificate revocation list. I recommend you use this. It allows you to revoke certificates that are either have been exposed, like the private key's been exposed, an employee leaves who had access to the private key, or maybe the hardware was under untrusted control. So for whatever reason, if you want to invalidate a key, you can do that with certificate revocation list. You probably are not going to use it right away, but I recommend you set it up so that if you ever need it, it's available. I do have a nice blog entry at the bottom talking about why that's important. Using certificates, again, what we're now bringing to a head here, what these certificates allow us to do is for two parties communicating by TLS to have authentication. So we know we do a shared secret, but what we actually do is we use the certificate to sign the key exchange, and we send that back to the other person, and that verifies that the person who viewed that entire exchange knew the private key of the certificate. And because we know the certificate is valid, because it goes up to a trust that we know, we can then verify that that is a valid key exchange because the key exchange was signed by the private key of the certificate that we are communicating with. Okay, and that's actually how that's actually how you identify that the key exchange was done with the person that you really want to talk to. And again, great description there at the bottom if you would like more details on that. How does this actually work in practice? Typically, certificates are sent across the network. And then what happens is effectively, as I said before, the TLS parameters and the shared secret are signed with the private key and are sent as a signature to the other end. And the other end takes the public key of the certificate, decrypts the signed, takes what was sent, hashes it, and then uses the public key to decrypt the hash of what was sent across the network. And if the two match, they know that the person who created that special hash knew the private key of the certificate that we trust. Very tricky. Let's look at how browsers use these. Again, here's a pop-up of a browser. You can see it's going to my website, and you can see that it actually is using a certificate from Rapid SSL, and that Rapid SSL certificate was signed by GeoTrust. Again, I currently use Let's Encrypt, but again, this example shows the certificate authority is a lot clearer, so we can walk through exactly how the process works. And you can see that certificate actually expired, so it's not valid. Here's a little better display. You can see GeoTrust is the root, Rapid SSL is the intermediate, and Momgen is the leaf. If now you might say, well, how do systems know what's trusted? Effectively, what they do is they have a list of trusted certificates inside their browser, and you effectively can validate only against that list. So here I have Rapid SSL on the list as trusted. In my example, Chrome actually doesn't have that, so I had to make sure it was sent as intermediate. Some Chrome browsers don't. If you remove a root certificate that you trust, you remove a root certificate that you need, what will happen is that you will get a certificate invalid error. So if you're removing a certificate that you need to validate a certificate, you basically get Momgen US uses an invalid security certificate. The issuer certificate is unknown because it couldn't follow the chain up to the root. Again, great URL here. Another case this happened was with Let's Encrypt. They used to have their certificate authority used to be signed by someone else. And in September of last year, that someone else's certificate expired. So all of a sudden, old browsers or old devices, Internet of Things devices that may have been using Let's Encrypt that didn't have the Let's Encrypt root certificate, all of a sudden we're going to throw errors. So that was, if you remember that little excitement in September last year, that's what it was about. That the Let's Encrypt used to be signed by a certificate that was in every device. And now that Let's Encrypt is popular, it's in all devices, but the older devices weren't there, and therefore you would get these errors. And the only way to fix it is really to get the root certificate into the old devices. There's no really other way around it. So that's why there was some excitement there. Just to finish out, I'm just going to show you how Postgres uses it really fast. Here's a tool that allows you to dump out the certificate for Postgres. To enable certificate authority in Postgres, and again, this is not a Postgres talk, so I don't want to go into too much detail, but effectively with Postgres, you can verify the authenticity of the server or of the client using certificates. Typically, you create a root certificate in Postgres. You don't usually use public certificate authorities. You create your own private root, and you effectively have the server verifying the client and the client potentially verifying the server using this certificate authority system. The ordering of the certificates is actually important, so you don't want to just order them randomly. Postgres docs goes into that and why certain certificates are necessary. Certain requirements of, you have to have a chain, just like a normal web browser has to have a chain up to the root. And we also support certificate revocation lists. Okay, so what did we conclude? Cryptography, TLS, gives us authenticity, confidentiality, and integrity. How does it do that? Authenticity with X509 certificates, ASN1 and RSA. Confidentiality, Diffie-Hellman and AES. Integrity, GCM and SHA. I tried to put them all together so you can kind of see how they work. So it's been wonderful presenting to you today, and we're going to be taking some questions right after this recording stops. First, the Let's Encrypt issue, which actually I was specifically asked for by the FOSDEM organizers to mention. It was basically a cross signing of the Let's Encrypt certificate by another certificate authority, and their own certificate was put in most certificate stores at the same time. So it was kind of two happening at once. They were signed in two places. What disappeared in September of 2021 was that second signing. So now they're just a root certificate store. Nobody else is signing them. And obviously, if you had an old certificate store, Let's Encrypt might stop working. Fortunately, we got through that pretty easily. Older systems, might not have updated certificate stores, and that was the big issue. There was a question about ECDSA. At one point, that was, I believe, the preferred method for Chrome. Maybe that was 5 years ago, but now it is no longer the case. So I don't know if people are moving away from DSA or if DSA was considered more secure or not before, and now it's just the same as RSA. I don't know, but I don't see it as much as I did maybe 5 years ago. How does one become a credible, trusted, popular certificate store? Basically, every browser, every operating system makes its own decisions of what certificate stores are going to be in there. So the problem is that if you're one of the smaller certificate stores, you may need to supply, and you're signed by a higher certificate store, you may need to supply your own intermediate certificate when you send your leaf certificate. So I kind of went into that a little bit in the talk, but there are sort of the big certificate stores that are in everyone, and then there's some that are only in some, and some are intermediates technically, even though they're a lot of times in certificate stores, so you don't need to send the intermediate, but in other cases they aren't as an intermediate in the certificate store, and you have to supply it. So it gets the unevenness is certainly confusing. That's one of the reasons I use the RSA. I mean, the Rapid SSL certificate example, because they were a case where Rapid SSL was an intermediate on GeoTrust. In some certificate stores, Rapid SSL was in the certificate store, even though it was an intermediate of GeoTrust. In other cases, it was not in the certificate store, and you had to supply the leaf had to supply the intermediate, which was then signed by the GeoTrust, which was in the certificate store. So again, it gets really complicated. Most cases you don't have to worry about it anymore. Let's Encrypt certainly is pretty much everywhere. So that kind of takes care of that. And I believe that is the end of the questions. So do we have any more questions? And if not, we'll just wrap it up here. Got a lot of clapping hands here, but I think that might be it. So let's call it a day. I want to thank you. Do we have any new questions? No. All right. Well, thanks, folks. Been a wonderful event. This is my second talk today, and I've certainly enjoyed it. Not as much fun as being in person, but still enjoyable. Thank you so much.
I'd request all the audience to please put a virtual round of applause for the speaker. Thank you, Bruce.
Hi, I'm Peter Tonik, open source evangelist at One Identity. Today I will be talking about sudo, how to watch and control your blind spots. So let me talk a few words about myself. I'm working at One Identity, which is upstream for syslog-ng and in a way also for sudo. I help RPM and FreeBSD packaging and write blogs and speak at open source events quite often. Let me give you a quick overview what I will be talking about today. First of all, I will try to define what is sudo. Then I will show you the basics and some lesser known features which lay the groundwork for the rest of my talk, which will be about features which came out after the 1.9 release of sudo, like change root and change working directory support, JSON formatted log messages, relays, and logging or intercepting subcomments. So, what is sudo? I asked these questions to well over 1,000 people at various conferences around the world, and the answers I received largely depended on the experience of the person, but not just that, but also the size of the environment where they were working. For many people, sudo is a tool to complicate life. Why to use a command if you can log in as root? That's something more straightforward, at least for most people. But even seasoned administrators often tell, well, sudo is just a prefix for administrative commands. Only very few people talk to me about advanced sudo features, or that it's a way to control and log access to a system. So, what is sudo according to the sudo website? Sudo allows a system administrator to delegate authority by giving certain users the ability to run some commands as root for another user, while providing an audit trail of the commands and their arguments. So, it's a lot more than just a prefix, as you will see also from my talk. Let's start at the very basics, the sudoers file. It has usually many rules in it. Here we can see the most typical rule in the sudoers file. This comes by default, and it's enabled on many systems. Members of the wheel group can practically do anything on a system. What does the various columns mean on this slide? The first one is who is allowed to do stuff. The second column is on which hosts, then as which user, and finally which commands are allowed for the given user. But even this very simple rule is useful, as if you have multiple users doing an administrative work on your system, you don't have to give out the root password, but you will see who did what, or at least when, on your system. Sudo comes with a huge set of default settings. While they make sense most of the time, sometimes you want to override these for your system and users. This can be done using the default statement. Here are a couple of examples on screen, like overriding what path sudo considers secure, which environment variables are kept from the user, and disabling insults for everyone on the system. You can make these defaults also user or host specific not just generic. The example at the bottom of the screen shows that insults are enabled for members of the wheel group. So, what are insults? They are fun but not always politically correct error messages when someone mistypes a password. It's sysadmin humor. I love it, but some people find it offensive, so they are disabled now by default, unfortunately. Another lesser known feature is session recording. You can record everything what is happening on a terminal and play it back just like a movie. It's especially useful when you need to give out root shell access through sudo, as you can record what is happening in the shell session and play back everything what the user did. The recordings are difficult to modify as they are not clear text. However, by default they are saved locally and therefore easy to delete with unlimited access, and this is especially the case when you hand out root access through sudo, root shell access. The good news is that sudo 1.9 introduced central session recording using the sudo log server daemon. So sessions can be recorded centrally, so the users cannot delete it on the local system. Once you have more than just a few systems, you definitely want to implement some kind of central configuration management. You can use the usual Puppet, Ansible, Salt, and so on applications, or sudo itself has built-in support for central management through LDAP. The advantage of using LDAP is that it propagates real-time and settings cannot be modified locally. On the other hand, there are many limitations, like you cannot use aliases while configuring sudo, and quite a few others. So it really depends on your use case how you solve central management for sudo. Sudo supported plugins for quite a while now, but you had to write them in C, and it was quite difficult. C is not the easiest program language, and you needed a development environment, needed to distribute the results somehow, so it was not easy. Recently sudo got Python bindings, so you can extend easily sudo using Python. The API is the same as for the C plugins. On the other hand, you do not need a dedicated development environment or any kind of compiling, and the scripts are easy to distribute on your systems. My favorite is the iologs API, which allows you to access input and output from user sessions. I coded a couple of simple examples, like you can implement a very simple data leak prevention system by breaking a session if a given text appears on the screen, or you can try to analyze what is typed on the command line and break a session if something suspicious is typed there. Here I want to show you just my simplest example code. It breaks a session if my secret appears on the screen. It's really simple. just importing the sudo module. Then we define a class based on the sudo class, then define a function which receives everything what happens on the terminal, and if given text, in this case my secret, appears in the buffer, then an error message is printed on screen and the session is rejected. Before going on what new features arrived after 1.9, I want to show you my favorite sudo cartoon. It's by XKCD, and it shows sudo as a prefix, overriding what our friend thinks about doing a sandwich to us. The first new feature I want to talk about is change root and change working directory support. Previously, full root shell access was necessary in many situations. When you wanted to use change root, or if you wanted to start an application from a user inaccessible directory. Starting with sudo 193, both of these can be configured from the sudoers file. Let's see change working directory support first. By default, the working directory is the current directory. So you need to, if you want to execute something from the current directory, but if you want to execute something from a closed directory, you cannot really do that. But using the change root option, change directory option of sudo, you can change your working directory, for example, to the root's home directory, as you can see on the bottom of the screen. This setting needs to be enabled explicitly in the sudoers file. There are two possibilities how to configure it. You can configure it using a wildcard, so the user can change the working directory anywhere on the system, or you can hardcode a directory where the working directory changes. Note that in this case, every time a user executes a command, the working directory is this hard-coded directory. So it's not, I'm not sure if it's always the best idea. Using the change root command needs root privileges. Of course, you can start change root through sudo. However, it is still possible to parameter sudo the change root with the root directory, and in this case you still give full root access to your system. Just like with the change working directory option, it needs to be explicitly enabled in the sudoers file. You can use here wildcards as well. However, in this case, you can also the users can also use the root directory as a parameter and have full access to your system. There is just one advantage of using the change root option this way, as it is really nicely logged by sudo, and it's very easy to alert on, as you can see on the log sample below. The directory can also be restricted in the sudoers file to a fixed directory. As you can see in this example. On the other hand, this also means that any application the user tries to start is started within this change root environment, which is not always the expected result. At the bottom of the screen you can see a sample message, which is a similar message is shown if using the change root option or the given directory is not allowed. There are also new options for logging in recent sudo versions. You can create JSON formatted log messages using sudo, and you can forward logs to the sudo log server daemon as well. These features were introduced in sudo 194. Why JSON formatting is interesting? Because traditional log messages by sudo are plaintext log messages with very minimal information. This is due to syslog constraints, as in the original syslog implementations the maximum message size is around 1 kilobyte, which is not too much. Here you can see a couple of example log messages from sudo the traditional way, and here is a JSON formatted log message. Why is it interesting? First of all, because it has a lot more information than the traditional sudo log messages, and it's also in a structured format, so you don't have to write a new parser for each of your new log message, but everything can be easily parsed as it's JSON formatted. You can enable JSON formatting using defaults log format equals JSON. You can also forward log messages to the sudo log server daemon now. Previously you had two options. Most likely you knew only about the first one, using syslog messages, but sudo 1.9 introduced an audit plugin API, which means that you can write plugins in C or Python as well to create custom log messages. And now you can also send log messages also to sudo log server daemon. You can enable it using default log servers equals and then the IP address or the hostname of the log server daemon. Once the sudo log server daemon received the log messages, it will still send log messages to syslog, but it means that together with your session recordings, log messages are also saved to the very same central location. When you check your log messages, you will see from the host field where the logs are coming from. And just as with regular sudo log messages, JSON formatting is also available here. The sudo log server daemon collects session recordings to a central location. Originally, all sudo clients sent recordings directly to this central log server daemon. Sudo version 197 introduced relay mode, which means that you can have multiple levels of relays on your networks to structure your session recording collection on your network. Why is it important? Because you want to make sure that session recordings leave your hosts as soon as possible, so they cannot be deleted, modified, whatever. Once you have relays, you can record sessions even when the central server is unavailable for some reason, for example maintenance or a network problem. It's also easier to configure your firewall, and you need to give out less permissions if you have a single network connection through the firewall instead of granting each host access on your network. And using relay, you can collect session recordings on networks without a direct internet access, like an AWS private network. If you run a relay on the gateway host. On your client or on the central server, everything is the same. You don't have to configure anything differently. On the relay, you need to configure where to forward session recordings, and if you have an unreliable network, then it's better to store session recordings on the relay before forwarding them to the central host. You can configure this using relay host and the IP address or host name, and use the store first option to store recordings first. Of course, you can use TLS encryption here as well. You can also log and intercept subcommands. It's especially useful if you need to give out shell access or access to editors. Before sudo 198, only session recordings helped in these cases. And watching these recordings is boring and time-consuming. Sudo 198 introduced logging and intercepting subcommands, so you can see what is happening inside shell sessions. It works in most cases, but of course not for everything. For example, you cannot see the built-in commands of shells, or you cannot see static binaries and so on. You can enable logging subcommands using default log subcommands. And even if I already mentioned JSON formatting, I want to repeat it here again, as I find it pretty important. You can turn it on using defaults log format equals JSON. Here you can see a screenshot from my editor. I'm running Joe, and I started a shell session within my editor. Here I'm running a few commands like id, listing a directory, and exiting, so nothing really threatening, but of course I could do nasty things as well. And here is what you can see in the logs when logging subcommands is not enabled. You can only see that Joe, my editor, was started and nothing more. And here is what you can see when logging subcommands is enabled. You can see even all the commands and utilities started from the by the bash profile when starting the shell. So many commands are displayed here. And I want to emphasize the importance of JSON formatting, JSON formatted logs again. You can see JSON formatted log message here, and you can see that a lot more information is included, and it's especially useful when you have subcommands, as it's much easier to find the parent session if you have JSON formatted log messages. Finally, I want to show you how you can intercept subcommands. This way you can prevent applications from running even if you need to give out full root shell access to a given user. Enabling interception is a two-step process in the sudoers file. First of all, you need to enable it using defaults intercept, and then you also need an actual rule which intercepts commands. Here my user can do everything everywhere except running the who command. And here is how it looks like. Even if running a shell with full root access, I cannot run the who command as I get a permission denied message. You can also use interception as a way to disable shell access, but it can have some side effects. Here is how you can configure it: defaults intercept, then list all of your shells in an alias, and then use it in a rule. And this way users cannot start a shell anymore. So sudo -s doesn't work anymore, which is quite a bit expected. On the other hand, I did not expect, only realized later, that starting commands from editors doesn't work anymore either. As here is an example. I try to edit the issue file, and then simple start and ls command, but it doesn't work as the editor starts a shell to run the external command, but shells are not allowed to run. So this way you cannot execute external applications from text editors anymore. Let me summarize my talk. Sudo had quite a lot of blind spots earlier, where you had to give two generic permissions to users, but recent versions fix many of these problems, and sudo lets you see and control a lot more activities. Using change root and change working directories support, you need to hand out root shell access in a lot less cases. Using JSON formatting, you can get a lot more detailed and easier to use log messages, and you can collect log messages to a central location as well. And you can track and intercept subcomments as well. Thank you for your attention. Do you have any questions?
Here that would clap after this, but now it's turn of Q&A. So let me start with the first one that I captured from the chat. Do you have any feedback regarding using sudo with SE Linux? How complementary it could be?
I must admit that I do not know anything about it in detail. I can check with Todd early next week. I recall that there are even in sudo some SE Linux specific stuff, but I didn't check it in detail yet. So maybe it's time to write a blog at the URL which I mentioned earlier in the chat.
Thank you. Next one is what kind of sudo extensions are possible using the CPython API?
There are many different APIs for sudo. You can check those on the sudo website. My favorite is the ilox API, which I mentioned in the talk, as that allows you to work with anything on the terminal, both input and output. So you can analyze the command line, you can check what is happening on the screen, but there is API to to create log messages directly within sudo. I mean, you can write a Python script and which forwards log messages to Elasticsearch or to a cloud service. I did such an example. Or you can create additional rules which are checked if all of the rules in the sudoers file are accepted. These are just a few from the top of my head, but there are a few more as well. And you can also replace the whole policy engine if you want, but that's not advised because in that case you cannot use the sudoers file at all. But it's possible.
Nice, thank you. Next one is, does sudo support log format, which is somewhat more readable, halfway between fully structured and human readable?
I don't really know what is logfmt. Sudo provides two kind of syslog messages. The traditional, that's kind of key value pairs, and this JSON formatting was introduced probably a year ago, which is really good, useful as you can parse it easily with practically anything, and use the values within it. So I have I recently made a blog post as well where I analyze these JSON formatted log messages from within syslog-ng, and it's way a lot easier than previously.
Okay, I got another one, which is, do you happen to know why sudo -d has been broken on Fedora Core OS for a while? I don't think it's an intentional limitation because sudo -i is there.
No, I don't know anything about it, but I can try to debug it with Todd next week as well.
Thank you. Let's give a couple of more seconds to the audience to see if there is any other question popping up. Well, it doesn't seem so. So thank you for all the fish. Thank you so much. It was a great talk, and thank you. And hope that next time we can meet in person.
Thank you.
Thank you so much.
Sorry, folks. I'll be running around like crazy. We're going to watch the end bit of the. We're going to now tune into the closing ceremonies, and then if you're on Twitch, we're going to go rate a channel. I'm going to try to get on cam. I just got back into the building. Everything's fine. I'm physically okay. It's just, I thought I was going to have like a calm, relaxing weekend so that I could do these live streams, especially for charity. And unfortunately, that did not happen. Because, hacker life. Am I right? Let's see. I think it's I think it's under here. In the meantime, until 12 noon, I'm going to put in some music. If you, where is this? Again, thank you for putting up with this crazy stream. We're not used to these hours, and we thought the weekend would go completely different than what it is. If you are interested in the content that you see and you're excited for other content that's coming up, such as the Master of Unlocking Lockpicking show happening tonight, 8 p.m. Eastern Standard Time, as well as Crypto Barons that will happen next Saturday, our meeting on the 18th, and other special live streams. You can go at our website at dcg201.org. And we're all over different types of social media to check up on us, such as Twitter, Instagram, the hostducks.social instance of Mastodon, our .onion, and all of that. So I just posted all of those links in the chat. And finally, this was supposed to be a charity stream, but unfortunately, thanks to January, the gift that keeps on sucking, I wasn't unable to put the link, so I wasn't able to extend the charity for another week. So instead, this is the direct link to the Children's Miracle Network hospitals. Donate any money that you want. Feel proud of yourself. Post on social media of what you've done. And thanks to everyone who had donated to our campaign. Even though we didn't reach our $600 goal, 300 is still a nice boost of money for multiple hospitals and pediatric centers in the United States and Canada to help out their patients who all happen to be children. So thank you all. I'm going to play some music, and then at 12, we'll have the closing ceremony. I'll try to get on cam at the end. If you're on Twitch, we will go ready to stream. And again, thank you for sharing FOSDEM with us.
Inside lane, missing exits, glued to the pavement. Between the lines, I'll keep my gaze straight ahead as the last stop flies by. No more waiting for the gun to fire. No more walking through revolving doors. I've gone around once, and I don't need to go around anymore. Break away, forget your sober case. Stop dwelling on empty words. Stop stalling in the doorway. Cancel the cruise control. Switch in the manual. Don't you wanna feel right? stalling in the doorway. And cancel the cruise control. Switching in the manual. Don't you wanna feel right again? Don't you wanna feel whole? Don't you wanna feel? your smile. Now the sunshine brings the light. Fill me out with a flame. I will let you in this game. Take me out when I'm down. 'Cause with you I'm safe and
Okay, I think I might be able to turn the camera on here. Let's try this. There we go. Change his shirt, as you can see. Again, sorry for the past couple hours. I said that I'd be on camera more. I end up being on camera less. And if you hear some weird rock and roll music in the background, one of the reasons why we don't normally stream in the morning, which is why Hackers on Planet Earth was a challenge, is because we have a certain type of neighbors downstairs that are part of an establishment in which they play music. And then it always happens at stupid oh fuck in the morning. So, yeah, they're right now playing like Christian rock and roll music, like not from a radio, like they have a band, and it's oof. So yeah, I'm gonna mute myself until closing ceremonies happens. Again, if anyone has any questions in chat, please let me know. I hope you enjoyed. Well, it's a FOSDEM. Like many things since the pandemic, this is the first time I've ever done FOSDEM, and like if I could make it to Brussels, I would totally visit this. I mean, obviously with FSF, Cambridge, Massachusetts is closer. But honestly, going to Massachusetts, if I had a choice between going to Cambridge for FSF and going to PAX East for Boston, I'm going to Boston. In fact, that's what I'm trying to do in April right now. So cross your fingers that we're going to head back there. If you have any questions, including my crazy hair, why do I have to change a shirt, what the hell does this joke even mean, all sorts of things like that, you can ask in chat. I love an active chat. It's going to be the final hour here. But otherwise, if you're just here to lurk and, learn a bunch of free and open source stuff like you did tonight, keep lurking and keep learning, folks. So here comes the music, and then we're going to watch closing ceremonies together.
Welcome to the closing talk. As they say, it's a wrap. Nope. Sorry, not sorry. Anyway, let's look at some numbers. We had roughly 5K concurrent views. On the platform which we are using, roughly 23K users in total. Of those, roughly 13K were active. More than 4,000 using their existing Matrix accounts. 7,500 using the FOSDEM infrastructure which we built up, and roughly 1,000 connected through Irklabira chat. This equated roughly 1.5 gigabit of peak outgoing streams, concurrent obviously. And we have more than 8,000 video transcriptions, either pre-processing or post-processing or pre-processing or post-processing as of this noon. We'll see a little bit about the transcoding in a second. That equates, as of right now, roughly 300 hours of content. And we have roughly 20 videos published as I speak. Waffles, many. And these slides, almost 20 megabytes. You'll see why in a second. These are by far the largest slides I've ever made in my life. So about this pre and post processing. If you are a speaker or a dev room manager, please, 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 with sugar on top, like your waffles, look for email from noreply@fosdem.org. you are getting emails or email, depending, titled Your First STEM 2022 Talk, titled blah, blah, blah. Please look at that email and go through the steps which are listed out there. We need you to make sure that the video is cut correctly. So the end and the beginning is cut correctly. No issues with audio or anything. And then you can confirm that, yes, this talk is done and final. And then we can actually transcode it one last time and upload it to the archives. If you're not doing this, the video volunteers and the video team are doing this. So they get to view those hundreds upon hundreds of hours to make certain that, yes, the thing is actually correct and it's cut correctly and everything is nice and shiny, and then it can be published. By crowdsourcing this effort, we basically make certain that we get everything up on the archives a lot more quickly. So please look for those emails and please do that work. If you were not able to make it to Brussels, this is what you missed. It's cold, it's rainy, it's great, as every year. In case this doesn't come across properly on the video, this is not a solid block of water sitting on Grand Place, but it is, the cobblestone's absolutely wet. And yeah,
It looks more
Brussels
cheery than anything in England or Seattle.
yet again. This is one of us giving an inside sneak of how the command center of FOSDEM staff is looking these days. Yeah, but I guess it's fine. No matter if you're a single person, if you're on the road, if you're with family, we know what we had, but we are making the best of what we have. Some of you are in hackerspaces with appropriate Club Mate, or just at home with sometimes an impressive amount of devices between all of us, but I do guess we are nerds and geeks. Recording the things which all of you have seen over this weekend. Even taking care of the plush toys and masking up properly when interacting with other plush toys, or doing socially distanced outside viewing parties, or indoor viewing parties, fully masked, and then go outside for barbecue at the beach, which honestly is kinda inviable. Or even going to the metaverse, basically proving that we had this term 20 years ago and we actually have meaning there. In 3D to walk around, or in 2D, reusing what we had for CCC, proving that everyone can be a princess if they really, really want to. One of the things which was shown is how distributed we are. Some of us literally woke up in the night to just give their talk and be there for the Q&A, which honestly is also a little bit of failure on our side with my monitoring dev room head on. We should have taken this into account more. Sorry for this. But yeah, no matter if you're human or if you're a spider, FOSDEM is about one thing: beer. Well, or non-alcoholic drinks if you prefer. But yeah, everyone made the best of it. And we literally filled a few pubs apparently with pizza and people and made it full. Or we're just at home having fun.
I just love how Ubuntu is a spider, and yeah, on social media there was a lot of liquor and waffles. Like that was literally all the FOSDEM was liquor and waffles. Like you ever heard chicken and waffles? Liquor and waffles.
And even fox earrings, or just waffles and beer, albeit with the appropriate plate from Belgium, I guess. Or making your waffles at your makerspace. Sometimes the waffles were different. Sometimes the waffles were made really, really weirdly. But oftentimes the waffles were waffles in a variety of forms. Although arguably, if you put too much chocolate on your waffles, you don't have enough space for all the sugar. So that's an engineering trade-off which you might want to reconsider. or no waffles at all. There were a few happy mistakes. It was waffles at home, not waffles in bed, but this works. It also was not mussels at home, but again, this works. And we also proved that through technology and software and agile processes and avoiding the waterfall model, waffles which initially didn't turn out too well could be turned into quite decent waffles within a mere weekend. It was a waffle sprint. Some of us even went way beyond waffles, and some of us,
I
quite
really
frankly,
do love the tux cake. That was a nice touch, and just waffles, 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 Brussels, waffles, Brussels. I don't know why Brussels is known for Brussels sprouts when it should just be like the waffle capital of the universe, according to all the pictures on social media.
Most of us, I know personally, the main feeling I have about this online FOSDEM and not being able to be in person with all of you is basically this. What? We made the best of it. We come to the thank yous. We would like to thank the sponsors yet again. Of course, without the sponsors, this wouldn't work. We would also like to thank all the volunteers. As you can see, there are a lot less than previous years, but also there's a lot less work this time than hopefully next year. So yeah, please sign up on volunteers.org for the next one. We want to thank the Matrix and Element teams and people who kept the whole thing running on the platform side, and also the Liberia chat staff taking care of the IRC side of the bridge for people to interact on that end. For sending out all the shirts, those are the people we want to thank you. And again, 13th of February is the cutoff when you can order, or when we send out the last batch of shirts. After that, it's gone. And all the stuff. And surprise Harry, even if they didn't make it this time, of course, with all the pandemic and the dark and the cold and everything, they had to go to the Caribbean to kind of get a breather. Hi, if you see this, hopefully see you next year. I'll be getting you yet another suit. I don't know which yet, but you will be getting one. Yeah, and also thank you. Of course, without all the attendees, without all of you coming back year after year, speaking, helping, or just being there and taking part, FOSDEM would not be the same. Again, for the speakers and the deaf room managers, please, 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 please look for this email and please do what it says in that email. Of course, again, any talk which you are not reviewing and polishing to a sparkle, we have to do. And it scales a lot better if you do it and not us. And also for this,
I'm shocked after all the crazy stuff that happened this weekend. I'm just here vibing. I'm like that cat with the bongos.
Those emails and do the thing. In case you have any feedback at FOSDEM.org. You also have all the feedback links scattered throughout the schedule. And
yeah, I think I'm going to submit in and show them the Hackers on Planet Earth website and offer that instead of just having a page that has every goddamn thing listed as an unruly grid and weird links that you click on, that they actually have some sort of dynamic search system that allow you to A, search for the thing you are looking for, and B, just visually organize things in such a way that it doesn't melt your eyes and you don't have to be used to like freaking hex tables in order to read what the goddamn schedule is. The swag's really awesome though. I can't wait to, I'm going to definitely order some soon.
After the 13th of February, they're out and you won't be getting any more. So for now, this is goodbye. But we do hope to hug and see you in person next year. Hopefully. And maybe same as with the anniversary we had in 2020, maybe next year there'll even be cake. Thank you and see you.
I hate doing this, but hang on, guys. I have to do camera stuff now. So I'm gonna turn the camera off for a little bit, probably like the next 10 minutes. Sorry about that. Sorry about that. As this guy does the weirdest dance hand wave I've ever seen. Yeah, they've been having this problem all con where they keep trying to do Q&A sessions. I'm assuming it's on Jitsi, and they just don't work, and that's the exact reason why we normally don't use Jitsi. I hope they figure this out shortly, because this is supposed to be like an hour long. Now this just looks like a bad chatterbait meeting. Hang on, folks. I'll be back. All right, I finally got back, and did like this? Did they just end the stream? But the closing ceremony was supposed to go on for a little bit longer, so I have no idea if they just ended. I think they might have just ended the stream. Oh dear Lord. Oh well. Um, it's good because I have some stuff to do. So this is sort of a blessing in disguise that the stream is dead. Just want to see if Twitch is working. Okay. So you know what I'm gonna do? I think I can hop on camera for like a minute or three. So let me just get everything kind of set up here, and we'll go do our normal signing off process here. Let's switch this back to face. Face. There we go. So hey everybody. Again, thank you for watching this stream. I think you can now see why we don't stream at 3 a.m. in the morning, or even like at like 9 a.m. in the morning normally, because of like how crazy things can sometimes get in the building. That's why it's always the afternoons are great. But hey, again, we're running on Brussels time. I will say that, and what's kind of funny is that I've truly noticed this with the European conferences, where what's kind of odd about them is that I feel like I know that the organizers are in different time zones, but I think no one has like leveraged um like the fact that we're all streaming this virtually. Like I think that that's got lost on a ton of people. So it's like, you know, they're located in Brussels, but like the free and open source software community, even if the focus is on Europe, is all over the place. You know, it's very far and wide. So I have no idea. Uh, let me find this. So I have no idea why no one yet a has leveraged the idea that with online streaming you can almost stream anytime you want. Um, Even something simple as even if you do live streams to do like let's say FOSDEM did 3 a.m. to 12 a.m. They could go on a 2 hour break, and then from like 2 p.m. to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's from like 2 p.m. all the way to midnight in another time zone. They could have just rerun, like it's TV programming, all the previous talks. So like that's something that like again I'm kind of shocked that no one has really leveraged yet. I've seen some some American and Asian live stream conventions attempt to try to do something like that. I think the best use was dead serious, not because we're part of the org, but was DEF CON, where I just love the idea that since all the talks were pre-recorded anyhow, they just released all the talks online the same day, bam. So that way you could just watch those talks anytime you want, and then that way you could focus on like, the challenges, the CTFs, the community chat, the parties, everything else about the event, and it just sort of freed up your time because normally DEF CON physically is so busy that even if you had 30 clones of yourself, you couldn't see everything. I like the fact that they kind of thought ahead a little bit and was like, hey, since we're on the internet and people are just going through rooms by scrolling up and down in Discord. Why not all the talks are pre-recorded? Let's just release all of them, and then people can see what they want whatever time zone they're comfortable with, instead of them trying to like wake up at ungodly times to watch this shit. And then that way we can actually focus on the actual like real time events that are going on. So that's like the best use time I have ever seen um, an online convention being used. I think Hope did. They didn't do something similar, but they kind of did a similar thing where it was just really easy to like look back on their previous days of live streaming. So that way, if you missed something, you could easily just click on it and you could turn back time and get to where you need to go. So here's what's going to happen. We're going to raid a stream now. I have already picked out the stream. It's a raid that we've done before. If they end early, I will host a different stream. But that's it, folks. Again, this was to be a charity stream for Children's Miracle Network Hospital, but unfortunately that did not work out. So I encourage everyone to donate directly to Children's Miracle Network Hospitals. And even though your name won't be displayed on the screen, I hope you feel proud for the $1 or $5 that you've donated to help sick kids across the United States and Canada, because I'm sure I am. I'm still really happy that we even got over halfway for our goal. That honestly makes me extremely excited and happy, and extremely excited and happy for the future. There will be no. We always take breaks with fundraisers, so I'll put it this way. Um, we might do a fundraiser in March for our anniversary, maybe in April. We're definitely doing a fundraiser in May, and the rest of the year during these autumn winter times is really up to everyone else. But that's the live stream. There is going to be another live stream tonight. Tonight I'm having Master of Unlocking, which is the show where I have two shows. I guess it's going to be the only shows for a while for DCG 201 until we diversify our content a bit more. So you're unfortunately going to be seeing a lot of me, particularly this month. And Master of Unlocking is the show where I teach. I'm part of the open organization of Lockpickers, aka Tool, and I teach people how locks and physical security systems work, and what their flaws are, and how people pick them open, bypass them, break them, creating your own tools for this type of stuff, reinforcing the security on existing locks, all sorts of things like that. And I'm really, like crypto barons, there's going to be some cool things. Master of Unlocking, there's a lot of creative things. This one I've already seen people do this lock that I've done, but this is going to be the first time me doing it, and I think a lot of people have not seen this lock before, especially if you're used to just like the big lock picking channels. I don't think they've ever covered this lock, but there's a lot of really exciting like projects um and like me recreating certain tools and reviewing certain lockpicking products that I'm really excited, particularly for 2022 at Master of Locking. Like, don't get me wrong, Crypto Barons is going to have a bunch of cool stuff in it. There's a couple of things that I'm trying to set for that. That should be neat. But I'm really excited for Master of Unlocking. We're also going to bring back Circuit Breakers. I'm going to finally do my episode, the one I've been wanting to do for a while, and our meeting's going to be on the 18th. And I'm already sending out emails for that. I'm basically prepping all the meetings up until like May. So when June hits, probably in April or May, I'll know what June through August is going to be like. But right now, and May is going to be a big one. May is going to be our first themed meeting of the year, where truly themed meeting where it's all going to be about hacking accessibility, coming up with creative technologies, especially DY home technologies for people with mental and physical disabilities. So I'm really excited for that. So anyhow, if you're watching Twitch, stay tuned. We're gonna go raid someone right now. If you like the content that you see, you can hit like, share, and subscribe on Twitch, D Live, or YouTube. If you're on YouTube, because YouTube is a badly coded piece of shit, you can go. Please click that bell and turn on all notifications, so that way you actually get our notifications. Because another cool thing about signing up for us is it's free. We get notifications that you have followed us on these platforms, so we get to cheer you on. I'm trying to add Facebook to it, and anytime we go on live. So if you can't remember what dates, or maybe we're late, or we have to delay it for a day, or move it up a day, or whatever, you will actually get alerts shortly before we live stream, so that way you don't have to miss anything. So that's really cool. If you want to know more about us, you can follow us on social media, such as DEFCON21NJ on Twitter and DEFCON201 on everything else, literally Instagram, hostducks.social, this is Mastodon, GitHub, or .onion. We really should go back to TikTok. I need to make a phone just for that, just because of like data hog usage and Chinese and American spying. And if you want to know more information about us, although we're still wrestling a bit with the website because January threw a wrench in our plans, so hopefully later this week the website should be properly up and running. But if you want to know more about the website, you can go to our website at dcg21.org or defcon21.org. Again, that is the last this is the last day of FOSDEM. Thank you for, despite me not being on Camelot, I have been sitting here watching the stuff when I've been running around throwing pots at things and trying to fight dinosaurs and stuff. So thank you for watching this live stream with us. I can't wait to see everyone at 8 p.m. tonight, and I can't wait to see everyone throughout February, especially in March, where we're going to go back to hybrid meetings. So I cannot wait to also just see people, like actual physical people in the future. It's going to be really cool. So that's it for the show. There's the link for Children's Miracle Network Hospitals if you want to be charitable. Hack the Planet. Dirty Jersey represents. I just realized I forgot to take the QR code off. And remember, even though hackers are insomniacs like me, don't stream at 3 a.m. unless you're in a different time zone, and that's like 6 or 8 p.m. for you. Like, you're a European or a South American hacker or something. Just don't start anything at 3 a.m. You see what you've done with the side pocket. You have broken his bin shell. I'm going to take a mad nap after this stream. Peace out, everyone. Enjoy the music and say hi to the person we raided. Yay. Hack the planet. I wonder why the desktop audio is not working. And for some reason, the desktop audio is not working. I don't know why. We're still going to raid, so we're going to be ending the stream shortly. Again, hack the planet. If the music doesn't work, just imagine music in your head. Do, 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 do. That's why they're going to be in the